about 45, 30 minutes or so. Then we'll just do like a Q&A. And then I want to get into some of the new GPS and SACNAC stuff that I've been looking into.
Sounds good. Sounds good.
About 5 hours.
Yeah. And then, okay, cool. So let me see. I got my screen share going. You guys see that?
Yeah, I haven't quite started yet. I was just fixing the
Okay.
the thumbnail.
Yep, no worries.
And then I'm gonna add everyone real quick too. So are you about ready? Like, should I click go?
Yep, whenever you're ready, sir.
All right, just give me 1 second. I was gonna. All right, cool. Yeah, I'm gonna click it right here, and then yeah, yours will be ready as well. So yeah, about 10 seconds and counting, good to go. And cheers, bro. Yeah, and I'll post for everyone else. I'll post the the Rumble link as well, and then I'll add everyone,
Cool.
and then I'll switch the event on the Discord as well in a second here. So yeah, cheers, bro. Looking forward to it.
All right, cool. All right, so this is The Lost History of Ether Physics, an introduction to toroidal field geometry. Oops, that's the wrong button. Okay. All right, so special thanks to everyone who putting together this presentation. A lot of on the back end of this was tons and hours of research. So thanks to everyone at the ADL. You guys are all legends. A big part of doing presentations, I wanted to give a shout out. This was for the summit, but I'm just going to give the shout out here. Shout out to Jaron for the Cornerism show. That was an awesome platform for people to just go out and say what they wanted. And public speaking was a big thing for me. So that was awesome to get out there and like use that as a way to get over that anxiety. And thanks to Bob Nodell for going out there in the field and doing actual experiments and seeking the truth regardless of what happens. And he did make a 15 degree per hour measurement, but when you get into the implications of what that actually is and how that device works, things don't look so good suddenly for relativity theory and the glob. So, shout out to Bob. And then, so this isn't for this event. So in this regard, it'll be shout out to Geo for putting together Earth Awakenings. It's an awesome platform. If you have an idea or something you want to share, you can book a presentation here. Highly recommend this place. It's awesome community here. So, all right. So thanks for everyone that's here that showed up. And so we'll get into the presentation now. So vortices versus atoms. A vortex is the natural geometric expression of pressure mediation. So we're going to look at a lot of examples of fractals of natural vortices forming in nature and how that kind of relates to the whole entire realm that we live in. And through that, we'll also examine the history of atomism, because back in the day, there were two competing theories that were kind of going hand in hand, and it was vortices and Dalton's atom theory. And there was some experiments that kind of put the atomic theory in a favorable position, especially mathematically, because one of the big things with vortex theory was that the mathematics to describe the dynamics of a vortex hadn't been sufficiently developed yet. So there was a lot of hurdles to overcome in that regard. So we'll go through the history of it all and look at the evidence that was put forward for both models, and I'll give an interpretation of my Ether model. All right. So we'll read here from J.J. Thomson's 1883 Treatise of Motion of Vortex Rings to start us off. So it will be seen here that the work is almost entirely kinematical. We will start with the fact that the vortex rings will always consist of the same particle fluids with a proof, which further requires dynamical consideration. And we find that the rest of the work is kinematical. This is further evidence that the vortex theory of matter is of a much more fundamental character than the ordinary solid particle theory, since the mutual action of vortex rings can be found by kinematical principles, whilst the clash of atoms, and it's all good, and the ordinary, hold on, I gotta get some water, 1 second. All right. Whilst the clash of atoms in the ordinary theory introduces us to forces which themselves demand another theory to explain. So what he's saying here is that when analyzing the fractals of nature and pressure mediation and all that, the vortex theory supersedes the atomic theory in regards to kinematic principles, meaning that kinematics is just you're making measurements of motion, you're analyzing that system through that. You're not concerned with mechanisms or how and why, right? It's just measurements. So to to have a framework to analyze things through that is like, that's fine. But then if you were going to try and analyze that and like build another theory to supplement the kinematics of it, just to even explain why you're doing the calculations, uh he's saying that's crazy. Like you wouldn't normally do that, right? So that's an interesting thing that he points out in 1883. So now we're going to turn to the experimental evidence that kind of kicked things off. So in the late 1800s, the discovery of radiation, or with the discovery of radiation, things were popping off, and they were discovering that there was different types of radio waves being emitted. So we're going to go over the history of that. So this is Antoni Henri Becquerel. This is 1896 discovered radioactivity. So we have some uranium here. We have a material here that's separating a photographic plate from the uranium. And what they found was that the uranium emits energy that goes through this, certain materials and activates a photographic plate. And so through trial and error and using different materials, they found that they could use lead to block the radio waves or the radioactivity or the radiation. So there was an experiment that was done. So what they did was they had a lead cavity here and they put some uranium in it. And so using this method, they could kind of control the flow of energy coming off of that. And they found that using electric plates, running a current through it, that they could separate the different types of that they could separate the energy flow into three different types of radiation. So there was gamma radiation, beta radiation, and alpha radiation. They found that the gamma radiation was what they call neutral charge. It wasn't affected by the plates, so it activated, pretty much in a straight line with the cavity. And then they found that beta radiation was negatively charged, or I'm sorry, had a lower charge potential, and that was corresponded by going up with the electric field. And then the alpha charge was positively charged, so it went to the negative side, and it didn't deflect by as much as the what is that, the beta. So those are different. Those are different energy emissions there, all with different energy potentials, right? All coming from the same source. So they were like, "Whoa, that's crazy!" That we didn't really know that was that's what's happening, because they just kind of thought it was one coherent energy source. So they actually found that there was three sources of energy coming off of that. Oops. All right. So we get a little into the mass energy relationship, the mass to energy relationship, the charge to mass ratio. So we're all familiar with E equals mc squared. This is that's actually that was actually predated from Einstein. There's actually a couple mechanisms for it. So we're gonna talk about the early renditions of E equals mc squared. So we have Hazelnorel here in 1904, who was experimenting with a hollowed sphere, and what he found was when he heated up the hollowed sphere with radiation, the pressure created inside added weight to the system, or an apparent weight, and he came up with a coefficient to express that, and that was given here 4e over 3c squared. So that was basically him. And he found that the apparent weight would go down after the energy had dissipated, right? So that was a early relationship of charge to mass ratio. All right. So then we have J.J. Thomson coming in with a discovery here with a cathode ray in a tube that really bolstered the atomic model. And we'll get into free electron theory also. So J.J. Thomson in the cathode tube experiment, he found let's just get into it. So he found a relationship with with the electron. So what they call the electron is like the lowest amount of energy that they can put into a system. So they came up with an experiment here with a glass tube and a positive and negative here that connects into the tube. It's a vacuum tube. So we have an anode cathode here, and we have a grounded section behind the positive charge here with a slit cut in the middle of it. So this slit creates a coherent beam of pressure mediation within the tube. So within that tube, similarly to how they were doing the experiment with the lead cavity here, they're going to analyze electricity and see if that's like a particle relationship. So that's what they were doing with that. So they have two plates here, positive and negative, that they can run a current through, and they have two magnets here, north and south pole, that they can do that through. And inside of the tube, there's a filament that, when it's excited, it turns green. So when they run the current through here, it'll create a green beam through here, and then they have a scale on the other side, so they can measure the deflection of the beam and go from there, right? So that's the setup for the experiment here. So when they when they run a current through here, and there's pressure mediation building up in here, the the beam that's created gets deflected to the positive. So they determined that this is, they call it negative energy, or negatively charged, right? But it's just a low state of energy. It's a low charge potential. But anyway, they needed to describe this interaction of deflection here, because of that interaction, what they found is, they can change the direction of the flow, right? So based off of all that, they kind of came up with a way to describe it in terms of a ballistic trajectory. So J.J. Thomson came up with a coefficient 1/5 E squared over mu times A. And I'll get in, let me see, 1 second. I need the notes for that real quick. It was, all right, so E is the charge that they put into the system. So they could measure that. So like I said, this is the lowest amount of energy that they can put into a system. Then they have A, which is the assumed radius of a sphere. They came up with that so that they could distribute the energy over the sphere. So that's the coefficient there, the 1/5. So he's describing, if this energy was a particle, what would that particle look like if you could quantify it? So this energy distribution over the radius of a sphere is how they came up with that. So with that in mind, they could come up with a way to describe this as like a ballistic trajectory situation, right? Then from that, once they have that, they can get a mass and momentum relationship out of it, right? So they can kind of backwards compatibility figure it out once they have that assumption of the radius of the sphere to distribute that energy over, right? And then they build everything in relation to that lowest energy potential state for the atomic model moving forward. So to describe further the free electron theory and how that works, we're gonna learn about dielectric materials, and then we're gonna reanalyze the experiment here. So if you look at the periodic table and break all the non-metals up from metals, you can say that the non-metals are insulators, or they're dielectric materials or conductors, right? And then for the metals, you can say that those direct the current flow. All right. So if you have if you have a setup here with a battery, a positive plate, and a negative plate to distribute the charge potential between them will, the plates will be charged, right? And if you put a dielectric material between these two plates, that will hold a charge. It'll store it, right? It becomes a capacitor. It becomes a Leyden jar, right? So with that, when you remove the battery, you can then discharge that potential that's stored in the dielectric material. So with that understanding, that's how Benjamin Franklin understood it. He was the first person to make the dissectable Leyden jar according to history, according to corporate history. So we have a glass material here, a dielectric material. We have two two metal plates here, and those will put the current. Those will direct the current flow through the dielectric material. And what they found was that even if you discharge the metal on these plates and replace new plates, freshly discharged plates that weren't charged, this dielectric material still holds the charge. So it's the charge is stored in the dielectric material. There's not a lot of charge stored in the the metal plates here. So All right, so re-examining the cathode in the etheric sense, right? So we have the positive and negative here for current flow building up. So they're just running electricity through it. So they've got a charge potential building up here. This tube is a dielectric material. It's storing that low energy potential. It's slowly building up. There's a direct flow of pressure mediation directed by that circle cut out here by the grounded. So there's a high to low coming here. So it's just following that, and then that's what's creating that coherent beam when they run the current, and then they're able to manipulate that flow of pressure mediation that's being stored in that dielectric material, with the what do you call it, the positive, the not capacitor plate, the anode and cathode of the plates here, and then the magnetic fields on the other side. So that's my explanation of it. So it's just a current flow. It's not a charged particle carrying a negative charge or anything like that, or like a tiny ball that's negatively charged. All right. So when you look at the cathode experiment, that's basically 1-to-1 what like CERN and all these particle accelerators are, right? They have a dielectric material where they're storing up a bunch of charge potential, then they discharge it into the same, into a local area, and then they're just looking at what happens, and they're analyzing that energy dissipation, and they're making models based off of that, and just it's not little tiny particle interactions, right? So we'll read here from the website here. Oops, from the Fermilab 2 website, from the muon G-2 experiment. So G-2 uses Fermilab's powerful accelerator to explore the interactions of short-lived particles known as muons in a strong magnetic field in quote empty space. Scientists know that even in a vacuum, space is never empty. Instead, instead it is filled with an invisible sea of virtual particles in accordance with the laws of quantum physics pop in and out of existence for incredibly short amounts of time. Scientists can test the presence and nature of these virtual particles in beams traveling in a magnetic field. The muon G2 experiment, or G-2 experiment, examines the precession of muons that are subjected to a magnetic field. The goal is to test the standard model's prediction by measuring the precession rate experimentally to a precision of 0.14 parts per million. If there is an inconsistency, it would indicate that the standard model is incomplete and in need of revision. So that was from the Fermilab. So basically, there's a sea of virtual particles that they're analyzing that they attribute no physical properties to, but where does it come from? Where does it go? Like, who knows, right? It's a mystery. So there is, however, an Aether model that's out there, and this is put forward by Atsutovsky in a book called Aether Dynamics. If you want a copy, I can definitely make that available. So what this guy did is he basically re-examined all the interferometry and all the experiments that quote unquote prove XYZ about so-and-so quantum effect or quantum particle or quark muon lepton change or anything like that. And he just re-examines it and attributes it through the lens of it being vortex pressure mediation, right? So he kind of picked up where J.J. Thomson left off. So quick history, although J.J. Thomson did end up saying that he believed in the particle model and all that stuff after that experiment, because let's be honest, I mean, mathematically speaking, if you look at that experiment and you're able to, calculate that ballistically off of that, that would blow your mind, and you would tell everyone that that's a particle, right? Like I'm not gonna, let's not front, right? That's pretty cool. But he did continue the vortex theory and developed hydrodynamics, like how to describe a vortex. Him, Lord Kelvin, William Hicks, and some other guy, can't remember the name, ended up developing that and continuing it, but they didn't really like push it or challenge, atomic model with it. But anyway, this Atsutovsky guy is picking it up and kind of re-examined everything. So he's got a model for everything. So density, pressure gradients, how fast the wave can propagate in it, temperature, conductivity, heat dissipation, kinematic viscosity, dynamic viscosity. So in regard, he's got a same mass and diameter situation. So like the particle exchange interaction would be what he calls like a condensed form of the ether. So it's just like a smaller, tighter vortex, but then a greater vortex that's pulling it all together. So like a particle interact, what you would call a particle interaction, is just like this tiny vortex basically, right? So in his model, the ether is like a gas, like a really thin gas. So when it's in that vortexual motion, that's when it can hold like form to give it like a particle. So that's his whole thing. It's really interesting. So to give some background on where he got some of the data from. So there was the whole thanks Bob thing, remember, with the gyroscope, where when you take it at altitude, it may or may not give a higher reading, right? So what this guy did, and that's also in regards to Miller's work in through the early 1900s, right? He did the linear interferometry at altitude and found that he got stronger readings than the Michelson-Morley experiments that were done, below sea level and in a basement, right? So he came up with a whole thing for that. But anyway, Galev was kind of following Miller's lead there, and using radio interferometry, he used mountain ranges and mirrors, basically, or reflectors, to send horizontal propagation paths at altitude and he found that the speed of light varies at altitude, and there's also a minimum and maximum fluctuation throughout the day that corresponds to sidereal time, which matches what matches what Miller interpreted. So he's just kind of re-examining all that, and if there's an etheric property to it, if it has viscosity, if it is it like, we give the analogy, electromagnetic propagation it's as if it's being carried upstream by a current, or going down, you're like resisting going against the stream, right? So like, what would the physical properties of that look like? Well, this guy's been looking into it, so it's that's out there. So the model for the way that I think where we live, I think we live inside of a toroidal field that looks like this. The block wall, we're all familiar with that. So to give like a side view of that, so there's an inner donut here. So this would kind of represent the northern hemisphere. The outer donut would represent the southern hemi, right? All right, and then so for single axis gyroscopic rotations on a plane, these would following toroidal geometry, these would look the same. Shout out to Icon Science who made this model. He's not a flat earther. He made the model as a thought experiment. It was very generous of him to make that. So this is where that came from. So this shows an east-west bias in the northern. So in that yellow donut there, focusing out to the and then changing to a west bias. West bias in the blue donut there. So that's what that shows. So to give another rendition of that, play this out. So this is kind of what it would look like in a toroid. So with the toroidal vortex emanating from the North Pole, obviously. So all these gyroscope angles just get absorbed naturally, and the 15 degree per hour, all that follows sidereal time with the toroidal flow of the ether. All right. Okay, so when we're talking about the ether and excitations in the ether, perturbations in the ether, it's like, what does that mean? What does that look like? So if I were to kind of give a visual representation here, so we have a tube here, and let's assume this whole tube is an ether current, right? And this blue tube specifically is just like the part of the ether that we can see for some reason, right? But it's the whole structure, right? But we can only see the blue part, right? All right. So what's happening here is like, as this rotates, you're going to start seeing a vortex form. So you're going to start seeing this build up. So what would represent this rotation would be introducing an excitation into a medium. So a charge disparity between, plates, creating a current. So that sort of thing. So any sort of excitation, oscillation, perturbations, all that sort of stuff is going to result in vortices forming, right? And then within that, there's going to be a dissipation of the vortices where they're going to break into smaller vortices, et cetera, right? And then you're going to get, within that, you're going to get energy. You're going to get actual physical changes, right? So when they talk about an electron falling down or whatever and releasing its energy and becoming a photon and all that, like all that is backwards compatible with vortex. Like it's literally a model. It's an analogy. It doesn't matter. So that's what that would look like. So there was a really cool video from Physics Girl, I think it was. She takes a plate and she drags it over the surface of a pool, and it creates what appears to be two vortices that rotate across the pool. And she was wondering how come these vortices don't push each other away or come together. So she did it again with food coloring, and this is a picture underneath the pool, and you can see a reflection to complete the vortex. But what she found was the reason that they don't separate or collide is because they're actually connected. It's one vortex. It's one vortice. So to kind of give a 3D representation of that with the reflection under the pool, I thought this was a pretty good analogy for like the full vortexual pressure mediation system of it, right? So that's what it would look like, the full complete vortice. So we have here the the highest charge potential is in your head. The lowest charge potential is at your feet when you're grounded. Especially you're dissipating your charge potential, to ground, right? So you have a magnetic field that corresponds to the right hand rule following that high to low pressure change. So you have your own toroidal field. So we exist within a toroidal field, and then we have a toroidal field that gives us our physical manifestation that we were given to us from birth from our moms. So like that spark of life moment, right? That creates a vortex, and I think, and then it creates like a charge differential in there, right? And then that creates that spark of life is a vortex, and then your mother's toroidal field, that pulsation keeps that pulsation alive, keeps that vortex together until it can start manifesting in reality and then maintain itself, right? So that's how I think all that works, allegedly. And then we have here storms. So natural pressure mediation, right? It's like, isn't a vortex complicated? How do you? Well, it happens naturally in nature. That's why I said that it's the natural geometric expression of pressure mediation. So this is a high to low situation in nature, and this is how this creates tornadoes through a vortexual motion of that natural pressure mediation. And what the big thing was with this tornado situation is they were trying to figure out the exact conditions necessary for the tornado to like snap down, and like when does it become a tornado that touches the ground, right? Essentially, right? Like what's that final step? What they were asking, right? So they had a couple of models up to and including air squirting. So I'll save us the 3 minutes where they describe air squirting, and we'll get into the vortex thing, which was verified by experiment or by the data in the field, right? So what they just skip through here. So this guy, I don't want to play the audio. So this guy, he was a vortex theory proponent of how it would work. He thought that there was little tiny vortexes at the bottom of the tornado that was forming that were corresponding to the top, and then that turned out to be true, substantiated by the data. So I'll just click on here. So they're analyzing. He was like, okay, there should be little vortices here, and when they break it down and analyze it, there's little vortices forming under the tornado, and then they model it out. Here's a cool graphic of it, but we'll skip to the better graphic, right? So essentially, this is what's happening here. There's like a moment when all these vortexes snap together and connect with the vortex that's forming in the sky from the clouds, right? All right, and then we'll play this audio here. This is Tom McCowan talking about how the heart is a vortex instead of it's not a pump, it's a vortex. So I think I shared it correctly to hear audio. Let me know if you guys can hear this.
Okay, so how does it work? Well,
good or no?
No.
Shoot. All right, one sec.
okay,
How about now?
so how does it work?
Good?
Yes, audio is good.
Cool. All right.
Okay, so how does it work? Well, the other thing is the blood essentially stops at the tissue level because it has to offload food and oxygen and pick up carbon dioxide and waste. And so you wouldn't need a pump when the blood is already moving the fastest at the entrance of the heart and the exit. You would need a pump where the blood is stopped at the tissues. So the pump has to be at the tissues.
Oops.
And not at the heart. So what happens is because of, Gerald Pollack did experiments with this. If you put a horizontal tube that's hydrophilic and you fill it with water, it creates a separation of charges, and the positive charges go into the middle, they repel each other and start moving. And that process is actually enhanced by light, by UV light. So you shine a light on a living system, it structures the water in the capillaries, that creates a separation of charges and movement, and that goes faster and faster just because it's going from a wetland to a river, goes up to the heart, going fast. The heart is like a dam, fills up the chamber of the heart, and when the pressure in the incoming side is more than the pressure on the other side, there's a vacuum on the other side of the dam gate. The gate opens and it suctions in, and the blood essentially is distributed through this vortex action in the heart to the rest of the body. And in the heart, it's not squeezing, it's vortexing. So like the Sufis say, where, the heart is stopped and there's a vortex, that's where the energy of the world or God comes into the heart through that vortex created in the heart. And that's how it works. And then there's little vortices in there that distribute certain blood to different organs, which is fascinating. And that's how it works. And
All right, cool. So it turns out the heart's super toroidal. Now, if that's not toroidal enough, we have toroidal vision. So this is a diagram of the Withmuller circle, and this has been experimentally substantiated. So this is the diagram of your left and right eye here. So if you take a circle that intersects your eye, and then you rotate it 360 degrees, what you would have here is a toroid. You would have a near field and a far field that would correspond to similar, that would have a different, what would you call it, like a different curvature rate. So the near field would be ecliptic, and the far field would be hyperbolic. So just different types of curvature. That's how they describe it. So in the 1940s, there was a guy named Carl Rudolf Lundberg who merged Maxwell's equations with optics, and what that means is he described that toroidal nature of the near and far field using the same equations that describe the radial change in a toroidal field, right? With magnets and electricity. So, with that description, right, you're going to have, with those two different curvature rates and scaling, for the near field, you're going to have, it's going to produce optical effects where, for example, a building in your near field will be larger than a mountain in the far field, right? So it's that the optical compression rate is dynamic. It's going to scale to how far things are in proportion to you and their size, right? So that's the scaling there, and we see in toroids, right? Curved visual space. So that's toroidal geometry for the optics. So when you have this toroidal geometry, right, and you look up into the sky, you're going to have overlapping sections of the sky. So if you take a look at this, you'll see that there's a green and red circle. So the green and red circles that are solid are observers looking horizontally. So their field of view isn't very long, right? This would be their local field of view. And then when they're looking into the sky, they have a large section that intersects, right? So if you built a coordinate system based off of this, vision, you could, that's basically the lat long system essentially, right? So how we see is just mapped to the sky, right? Prospectively, right? So when you're 60 miles away from somebody, the things in the sky deviate by 1 degree. So if you just map everything to that, and that you would produce, maps that you could say you're navigating on a globe or a plane with, because it's just mapped to the geometry of the sky and your vision. It doesn't matter. So again, here's stellarium, and with that toroidal geometry, the near field here would be similar to these squares, and then your far field would be that. So that curvature rate is going to produce that optical distortion. So when you have observers in different locations all looking up at the sky, they're all going to see relatively the same thing with slight deviations. And if just mapping that for two observers, they were able to, make a coordinate system for people to navigate with. We'll get into that in a couple slides. So with that toroidal geometry, though, this is the mechanism for what produces moon dogs, sun dogs, and rainbows. It's that curved visual space limit, that azimuthal grid that we call it. That's the Mueller circle. That's your field of vision, right? It's your azimuthal grid. So there was a cool clip by Whitsitt from when he was doing a presentation on the azimuthal grid for star optics and star rotations. So this is an example of curved visual space when atmospheric conditions are applied, and you get what looks like what they say can only work on a globe. So I'll play this video out. I don't think there's any audio to it, so it's just a quick thing here. So curved visual space on a plane, and then when you add in atmospheric conditions, looks very reminiscent to what they say only is mutually exclusive with a globe. So here's another image of the azimuthal grid.
Alan, I think the stream just ended.
Yeah, I was gonna say you unshared.
Oh, one second. Got you. No worries. There we go. Sorry about that. Apologies. I'll give everyone a second to catch up. My bad. It was when I changed it to the specific window for the audio for the heart thing. My bad. Okay, so we should be back. So this is that azimuthal grid. So apparent objects in the sky and where what it'll look like for an observer on the ground. All right. Oops. All right, I think that was the end. All right, that was it. So toroids all the way down. Any thoughts, questions, comments, concerns?
Sorry, Alan, but what was that very last bit that you showed? Sorry, I feel like I missed something there.
Oh, you're good. This was the azimuthal grid. So like if an observer, imagine an observer here in the center of this sphere or hemisphere, so to speak, and then what the objects in the sky are doing. This is what it would look like for him in his location, right?
I see. So it's showing, but okay, that makes perfect sense. Thank you.
Yep. No worries.
Alan, could you go back to slide? I want to say it was somewhere around 17.
17.
It might not be 17. It was somewhere. Yeah.
Yeah.
So,
Yes.
can you explain a little bit, if you know the answer, about like how this guy analyzed ether experiments? Like, was he using some kind of computational interface to like model this, or where did he derive these constants? Or no constants from?
So as far as the constants, man, that's where I got to the book and kind of checked out. Not really sure, man. This is a summary from Dr. Bennett, who was going through this, and so yeah, the only thing I know personally about is in regards to the kinematic viscosity, which is the Uri Galev stuff, because that was from my point of interest for the ether measurements at altitude and stuff. So that one is related to that. But yeah, as far as the sound viscosity, he said apparently there's a wave equation that they use. I'm not sure how they use it. He explained it to me once, but basically when you run that through whatever, it gives this speed that's like way faster than the speed of sound, and that's like apparently that's the upper limit of like how fast something can propagate with the ether model.
Just like it might be for interest for further research into this. I know a lot of photooptometry type experimentation was done by the Soviets in like the 50s and 60s, right? A lot of that stuff is actually classified to my knowledge, but there have been small numbers of stuff like released, like the CIA reading room, resources like that, where you can see like experimentation that they did. I'm guessing that this stuff probably was included with it just because of the nature of the interconnectedness between what they were looking at, because they did like firmament measurements and stuff, right?
Yeah, I've
Like there
seen some
might
of
be a
that.
connection there you could find.
Yeah.
It would be a good place to look. I just don't know how someone would get access if the stuff is actually in fact still classified, you know. So
Yeah, dude, it's crazy. This came out of this book that it's in Russian only. I have the only English copy. I had an AI translate it. And it's
oh
like,
really?
yeah, this dude like went over all this stuff. Yeah, Bennett's been going hard on it. But yeah, it's like
Wow.
all the constants and stuff is kind of beyond my pay grade. Like
Another source you might want to check out if you're interested in how they're like the methodology of deriving this, or just this type of theory. I just started digging into Hedgie Lin ether mechanics, and that's got a lot of the similar. It's kind of a similar thing of trying to quantify the ether, and yeah, like a lot of the math is pretty high level. But I'm trying not to be too intimidated.
Yeah, it gets wild. He does go over it. He'll be like, okay, so assuming XYZ about this, and then he'll like build off of that and come up with like a flow for it and all that. But yeah, it's a lot. It got super math intensive real quick around chapter 6. So
Yeah, word, bro. I just noticed something. Like, if you look at second sound velocity, that's like the commonly accepted speed of light under most conditions, 3
right,
times 10 to the
right,
8th, right? So
right,
first sound velocity is like way higher than that. It's 10 to the 44. Like T is less than what I don't know what capital T is, but like
right.
you
That's
know,
the whatever that was is the
or 23. I mean,
yeah. Oh well, yeah. The T was for the temperature one, but
oh, okay, my bad.
yeah, the
Yeah, the
sound
U
viscosity.
greater than
Yeah, it comes out of
the
that some
velocity.
wave equation that they use. I forget the specifics of it, but it yielded that. So he was like that would be the upper limit of how fast stuff can go.
Man, 10 to the 23rd, bro. So it's like a 10 to the 23rd is like ether perturbation velocity, and 10 to the 8 is like reflectivity and the propagation of the ether as light velocity. Man, it makes sense it would be faster. That's dope, bro.
A lot faster. Yeah.
I didn't realize that was Bennett math. That's pretty amazing. Or at least that's his interpretation of that particular literature, right?
Yep.
Right. That's what my supposition, just based on what I think would be a logical conclusion, bro. Like, dude, ever since that presentation yesterday, I feel like I've asked like just logically leading following questions, and almost every time the answer's been like, yeah, that's what they say it does. I'm like, wow, it's so more like intuitive than
Right.
you know what I mean? Like,
Everything's not infinitely disconnected from everything else and filled with empty space, and things actually can just propagate in a way that's sensible.
yeah, I'm like kind of hooked on some of this like it's basically advanced electrical theory at the end of the day, right? So I mean,
Well, yeah, that's
I'm
what.
kind of
Yeah. That's
I
exactly.
mean, I'm trying to absorb this information. It's pretty dope.
Yeah, it's for me it's interesting because I don't know how exactly, but I can just tell that having the atomic model like somewhere deep in my conscious, like it affected the way that I related with my world and my mentality, my psychological state. I don't. It's a weird thing, but like, um, conceptualizing matter, I think really plays into that it's just it has to be the case that the way we conceptualize quote unquote matter has to play into how we interpret our place in the world. So this philosophy of ether versus the philosophy of like a materialistic point of view has, I think, ramifications that go from not just science, not just how we look at physics and electrical theory, although it is, going to help with. I think it could help with a lot of the theoretical physics of that, but also just like it builds up through your mental stack. If you have a deception somewhere deep down in your mental stack or anywhere, like everything kind of coils around that, it wraps around that to this point where you kind of lose. You become detached, right? Like that's what deception does. It detaches you from the truth, from reality. So conceptualizing things in a way where everything is interconnected through an ether. Just the idea of having that framework is I think a psychological win.
Man, that makes so much sense too, bro.
Facts, bro.
It's really cool to me because my brother's on the exact opposite spectrum. He's a nihilist and he believes that nothing really matters and we're all just creating our own reality as we go and yada yada yada.
Oh shit, dude, they
He's-
got him.
Yeah, he's like, oh, just take a little bit of Adderall and Zoloft and go to some therapy, man. You'll be okay. You know, the Earth isn't really flat. Like, you're just fucking crazy. I'm like, come on, man. Are are you just gonna be condescending forever, just because you didn't think of it? But I don't know. I might just give up on him. He's lost cause, in my opinion. But I had to try.
Yep.
I think we can all relate on some level with that, man. We've all got those people in our life.
You know what makes so much sense? I just thought about Toby with this model as well, like talking about materialism versus like Waither Eve propagation version of reality. Dude, they already tell us that 99% of matter is empty space. So like, is this that much of a stretch? Because I mean, maybe they're right. Because the bits that actually fill that space aren't that many bits because it's, this etheric model, bro. You know the reference I'm talking about? How they say 99% of matter is empty space? Am I the only one who's heard that?
Oh no.
No, yeah.
Yeah, I see what you're saying.
Yeah, that's quantum theory, essentially.
Yeah, I mean, like even in their own admission, they're like, it's not really empty. There's virtual particles that they need to balance out the math equations because it's all about pressure. It's all
Quote,
pressure
unquote,
mediation.
virtue.
They need a positive and a negative particle to correspond with everything. That's why they came up with the strong and weak nuclear forces. So back to what J.J. Thomson was talking about with the atomic model and how the vortex model was pure. With the work is purely kinematical. So what he was referring to in that regard is that the atomic model, they had to explain how the positive and negatives weren't attracting towards one another in such a way that it couldn't hold a structure or it would repel and couldn't hold a structure. So that's where they came up with the strong and weak nuclear forces, which they now say are facilitated by quarks that change colors and leptons and all that kind of stuff. And then they say it's like at the end of the day they end up saying, well, it's what do they call it? Color based pressure or color pressure mediation or something like that. So it's just basically frequency based pressure mediation. It's just like it's all analogies. It's all analogies. It's all analogies, just describing a high to low pressure flow. It has nothing to do with like an actual physical particle. Like the whole model is reified by mathematics, and like to the point where they admit that there's a pool of virtual particles that they're pulling from to even explain why they're getting energy fluctuation readings in the first place out of nothing when there should be nothing.
Yeah, that's what Witsit was talking about earlier, like having what's supposed to be a vacuum and there still being like stuff in it, right?
So the magnetic permeability and electric permeativity aren't zero, right? Those are just they're really low values. I forget what they are off the top of my head, but yeah, they don't like even in their own thing, like that's an impedance, right? Like what is it? Where does it come from? How did you get those numbers? Like these are all questions we want to know, but
Right.
but like it's like
We were
those
taught
are
it was hundreds.
yeah, and it's like those are cooked into it, and it turns out that that's like the quote unquote speed of light, but then there's fluctuations within that. So what I've kind of been reading recently is that c is the speed of light with respect to the ether, and then with an observer's motion, right? There's a variance proportional to that observer's velocity. Because that's what causes the Sagnac effect. That's how ring laser gyros work. It's all in reference to an absolute background that not just for a mathematical placeholder, but in reality, right?
Yeah, and when you said the observer's velocity, you mean like in relation to the ether, right? Because in that model, it would be like an ether reference model because the ether is what's drifting in a particular direction and causing the velocity increase.
Yep, that's exactly how. Like, dude. So this gets into GPS, ring laser gyros, like all of this stuff is all based off of that. That's absolutely it. It's all
So
based
so
off
that's
of
like
that.
they have an etheric reference frame.
And they hide it. So the ECI reference frame they use they have all the atomic clocks synchronized. Dude, let's get into that. Should we should we get into the GPS stuff?
Yeah.
Yeah.
All right, cool.
Can I ask a question before we shift gears?
Absolutely. What's up?
Okay, so I wanted to ask a question. The difference between their model, the atomic model, we know that they say that the atom changes due to the different electrons, proton, neutron, different, arrangements, right?
Yeah.
Okay, so now in the etheric pressure mediation model, if I got it correctly, what is it that differentiates between the so-called quote-unquote atom? Is it the different vortices due to pressure mediation? What gives it the different characteristics, like the atomic structure, atomic model?
Yep. I'll show you. Let me see if I can pull up the video. Yep, right here. So, are you guys able to
It's
see
such a
this?
good one. It's such a good one.
Yeah.
All right, cool. So you see,
Yep.
you see how that original vortex splits into other little vortexes.
Yeah.
So when that threshold happens, that's when you get the interaction when it's like, oh, now it becomes a photon. So it, then you could see it like a change, like that whole energy change creates a different interaction. Like, you know what I mean? So it's like a different type of pressure mediation, different speeds, different whatever, and that's what creates the effect, right? It's just like a small fractal of that because these just break into smaller fractals. And there's actually, let me see if I can
Yeah.
pull it up. There's a threshold too for like, for example here, because that's actually a great question. Let me see if I can pull this up in time.
This is the same effect with smoke rings, bro.
Dude, I'm pulling it up right now from the Russians,
Oh.
if I can get to it in time. Come on.
Anytime y'all are in the morning time, set your blinds when the sun's shining in. If you smoke,
Oh,
just
where is
it doesn't even have to be a ring. Just blow the smoke through that light, through those lights shining through the blinds.
Oh,
And the
man. Oh.
contrast between the shadow and the light gives you a beautiful, beautiful, essentially what you're seeing in this video, but with smoke and dark and light.
Damn, I can't find the pictures I have. But yeah, so essentially there's a threshold for how big and how fast a smoke ring can get before it breaks or dissipates into different stuff. And like, basically it's just following that. Um, so when you're adding energy to a system, like there's a greater vortex, holding it all together. And like once that it just gets into different like different modalities of the ether are just different vortices essentially. You're absolutely right. That's what it looks like.
That's what I thought you were saying. Okay, I just wanted some clarity on that. Okay, interesting.
Yeah.
You know what else this reminds me of, huh?
What's that?
A bubble chamber.
I never heard of it.
Yeah. If you see the way they show their swirls and stuff when they say, "Oh, we found the God particle," or "We found this and that," it's basically some swirls like that in lines. So it reminded me right away of that.
Oh, I haven't seen that. What's it called? A bubble chamber?
Yeah. I'll find the picture for you.
Mm.
Oh, is this where the God particle lives?
Precisely.
Oh,
Yeah.
hell yeah, that's what's up. Yeah, he's definitely in there, but you can't find him because you'll violate the Heisenberg principle or whatever. But he's definitely he's definitely in a cloud
You
of
can never find him
distribution in
and know
there.
where he is at the same time. Yeah.
Yeah, and if you did, you could hypothetically entangle him and say that he's over there, by inference, but only inference, right? So very cool.
Somewhere about over there. Yeah.
Somewhere thereabouts. That's awesome, dude. Yeah, there's nothing like little oscillating rings that are just interconnected vortices, man. That's awesome.
So that's interesting that ether's like propagation can be modified in ways that it's like vortexes, like vortexual perturbation, so to speak, or like also straight line perturbations. Because think about like firing a laser, right?
Well,
So, like,
it's
there's
just
different-
it's just a smaller vortex.
a narrower like vortex, extremely narrow.
Yep.
Okay.
Is it's still produced by the same type of frequency, right? So it's still going to be proportional to some sort of vortice. Right.
So like on a sine wave table, right? Would you be drawing like making it more like 3D by drawing like a vortex in the middle of like the center points between the trough and valley paths?
Yeah, so that's a great question. So that intersection point, don't have the graphic for it, but yeah, if you look at what is that called? The dipole model. We can see of a
Maybe.
wave of a EM wave. What do you call it? Yeah, this right here. One second.
Hey, Alan, I posted for you on live stream 1 if you want to have a look. It's freaked out.
Yep, check it out. 1 second. Oops. There we go. So that intersection point here you're talking about?
Yeah.
Yeah, absolutely.
Well,
That's that. So that's what in Atsutovsky's model. That's what he calls the aimer. So that would be like the highest charge potential that's carrying the electromagnetic propagation. That's the intersection point for those field because no an electric field has never been proven to self-induce a magnetic field. There has to be a charge potential between them, and that's mathematically they say that they don't need it, but or whatever, but they've never experimentally shown that. So this is the intersection point is that like that's the ether.
Bro, I've never heard of this. Like, I mean, I've heard of it like kind of now, but
Bro,
I
check
just
this.
don't understand like how intuition leads to questions that are like mentioned a positive yet again. Remember me telling you that 5 seconds ago? Like, I ask all these questions that just seem intuitive, and then you're like, "Yeah, that thing's right here."
Yeah, yeah, man. That's exactly, dude. It's exactly it.
Like, I feel like where's this knowledge coming from? Like, I can't be. I'm not. I'm literally making this up.
So
And
so
every time I make something up, you're like, "Yeah, that exists right here." Like,
so check it out.
bro's not generating these graphics in real time in like 5 seconds after I ask the question, right? Like,
Dude, am I chat AI or whatever?
yeah, like this. Okay, it's so intuitive, bro.
So these were added to Maxwell's equations. This term here, I forget what it's called. It's the displacement current. And basically, what this is saying here is that a wave, an EM wave, can propagate without this intersection point. The current can just self-induce this magnetic field, no problem. Is basically what they say with that mathematically, and that was never and then that's never been experimentally substantiated since this term was added to the equations. And that's from a paper written by Anel Deneau for his master's degree in 2012. That was his thesis, and he did get his master's. Congratulations to Anel. So he did a history of Maxwell's equations in this whole intersection point debacle with current physics, and it stems to this. So like these equations here basically describe like stationary magnet fields. So we're not really concerned with that. It's this right here. So this is the term that was added to describe to say that they don't need that charge potential point. So this is how they teach people electromagnetic propagation theory and stuff without talking about the ether. They're just like, oh yeah, we got that classic self-induced magnetic field from the electric current.
Right. I was actually wondering about the points like equidistant between each of those points, like in the center of the line where the red and blue, yeah, right there. Oh,
Right here?
right there. Yeah. Yeah. What would be going on? Because it'd be like inversely proportional to that on like a 3D waveform like scale like this. So
I don't know what
it's
that would
equidistant
look like.
between them,
I don't know what that would
right?
look like, but I need someone to model it out because like it would look insane, right? It
Because that
basically,
was the point I was originally asking about.
yeah. Have you seen? Yeah, my bad. I thought you were talking about this point.
It's okay. I mean, that's also relevant, so it's fine.
Have you seen like cymatic patterns? So there's like
Like
2D.
snowflakes
Yeah. So like
or
when you
sound, like sound in
yeah
water or whatever.
yeah. So like when you have sand on a plate or whatever, and you're resonating a frequency through it, that it naturally forms like geometric expressions in it.
Yeah.
Okay, so those are 2D representations of like a three-dimensional form. So I imagine that like waves are like that, but or, like we talk about them through this like two-dimensional situation. But I imagine I bet you they're fucking crazy, dog. I bet you they're like like they look like that.
Yeah.
They look
Yeah,
like
because there'd be like an invisible inverse to this that's flying over it, and then that center point that's equidistant between those 2 points would be the point that's like, because you would draw like a full sphere right around the other top of that, with like the.
No, you're
And I wish
right.
I could had a pen. I wish I had a pen right here. It would be like a full circle, but half of it would be material, and half of it would be the invisible part. And that center point that I designated right there, like that would be between those two flip parts.
Right.
Like I'm presuming that it's like invisible marker, right? Drawing it right here on here. Man. And the oscillation then is going to go. Man, this is like, I bet that looks freaky, bro. Like you said.
Yeah, I was thinking about it the other day and it blew my mind. Because I didn't even realize that those cymatic patterns are 2D representations of a 3-dimensional frequency. When I realized that, I was like, "What? You mean that's
Reminds
not?"
me of DNA, bro.
Yeah,
Reminds me of
exactly.
DNA.
Exactly, dude. It's just crazy, crazy. So
It's probably what it would
It'd be
look like
like
when you add the other one, because it's that double helix. Probably what it would look like.
it'd be like if somebody was blowing glass and they somehow were able to get one of those patterns to resonate through the glass while they're heating it and whatnot. Have you guys ever seen someone blow glass before?
mm-mm.
They blow bubbles into
Okay.
like the bottom, blow air in it, like they make a cavity.
Kind of, yeah. But like I've seen some crazy stuff because they'll heat it, and then they'll stretch it out. They'll push it back together. They'll put a certain like touch a little bit in there, and I don't know. It's a beautifully crazy process. But I can imagine, like especially with what he said about the cymatic patterns being a 2D representation of a 3D form. Like, oh man, you can make some really cool glass art.
But there's no question the patterns that arise from the different sounds, that is like spectacular. Look what Geo posted for past the hour. Like
Oh shit.
that's just amazing. Like just to imagine that a different kind of a sound, different kind of vibration will make a specific pattern every time. Amazing.
Yeah, that is nuts.
Oh, you can get a good example in freezing ice, actually, of what it would look like if you were to get it in glass blowing or something. But like these patterns, yeah, you can get them in ice by writing certain words, allegedly, on the water, on the like container that you're freezing it in.
It's costing.
Now you're getting into magic.
I mean, we all use spelling, right?
I was being serious, not facetious, brother.
So am I. You think that they call it spelling for no reason?
Oh no, I know all about it.
Yo, so is this what? Dude, Geo, that's nuts. What?
Bro, that is crazy. How are they?
Yeah,
how
and it
is
shows all the different harmonics, and it like
Yeah,
it's
GG.
incredible.
That's it. that's
Yeah,
that's what I think a
seriously
wave
awesome.
looks like, and you'll never convince me otherwise. Oh, that's cool.
How's it levitating and like staying in the same space?
Sound.
Like single drop of water, right?
Yep.
That is insane, man. 3D cymatics. Wow.
Have you guys ever seen the magnetic fluid that they've done with this like the cymatic patterns? It's kind of like this.
Damn, this is crazy. Hold on, I gotta steal this.
I don't have an example. I want to try to find an example.
Save references. Cool. Yeah, that's awesome, Gio.
There you go. That's how they build the pyramids.
Thank you for those, man. I was. Oh man, that's kind of what I imagined it looked like without ever imagining it. Really.
Star drops.
Yeah, I was watching that fucking chapel in England, the Templar Chapel or whatever. when you zoom in on all the chevrons and the arches, the sides are like essentially lined with these like mandala type patterns that they matched them directly up with a bunch of patterns that they did through cymatics, like direct matches. Pretty
Yeah,
sick.
this one I just posted. Yeah, does this show what you're talking about? These like church windows.
Oh,
No, not well. That's no, not that. But that could be similar. No, I'm talking about on the underside of the arches in that, what is that fucking thing called? The road, whatever, priory of something. I forget. It was on the underside of the arches. So when you look up, instead of just seeing an arch, you see an arch with a bunch of these like mandalas on the side that looked exactly like the cymatic patterns.
I like this phrase here. Music is liquid architecture. Architecture is frozen music.
oh, that's awesome.
That's cool.
Frozen music. That's kind of beautiful, man. Who said that?
Yo, Noah.
It's on this one I just posted. I don't know who said it originally, but the guy grabbed that from somewhere. I didn't make it, but
I'm attributing it to Bernie Mac. So
Noah, did you see the pictures of the stained glass windows he was sharing? What if I told you that the reason that that glass is there is because it was added later? Originally, there was no glass in that. It was just a resonation chamber, like a port on the buildings, so they could resonate out the frequency that they're producing, and they perturb the air in there with the giant organs and the pipes that ran. They were basically doing like acoustic therapy inside of like a resonant chamber in these buildings, is what like a lot of people claim is the technology at play here.
do you think an organ was made to
Yeah, I
soothe your
call it
organs?
information-inducing music.
What'd you say, Alan?
Including Eric Dollard.
Oh, sorry, I think I talked over somebody there.
Oh, you're good. I forget, to be honest with you. It's all good.
Have you seen them investigating that geometry in those churches and like the tech at play?
Yeah, there's a guy on YouTube. Have you guys seen the channel Paul Cook, who goes out and let's see if I can pull it up. Paul Cook. This dude's channel is awesome. He goes out and does stuff in the field and investigates like these ancient structures and stuff. And he found this old book that had a bunch of references. Basically, what he found was how people used to get electricity back in the day, according to this book, was similar to how I showed the Leyden jar. They had a Leyden jar that they would take to their local church. They would charge it up and then bring it home, and that would give electricity to the house for the whole week. Like they had a spot on their mantle that they would just put the jar in, and it would give electricity to the house for a whole week. And then they would take the jar back and to the church and get it charged there. And basically,
What?
yeah, dude. So the way that the structures for these abbeys and stuff is laid out, and with red brick and stuff like that. Like I don't know the specifics. Like I'm just kind of repeating what he says. It might not be true or whatever. But basically, how they're laid out is they store energy. So they're just storing electric potential with water, because they used to fill in with water. And the red bricks were, let's see, something with the iron. But anyway, it would just basically store electricity, and then they would have these jars of water that had like electric potential in it, and they would take it home for a week. And it's like, dang, I did, and that was before I knew what a Leyden jar was. I was like, that's crazy. That there's no way that's real. And then it's like, oh yeah, Benjamin Franklin invented something called a Leyden jar. It's like, what's that? The thing that Paul was talking about but just to a higher degree in like, free, basically, right? Because it's like, how do you put a price on that, right? You could just charge it up naturally. You have an entire structure built. Those cathedrals and stuff, those abbeys. Like the whole structure is designed to just give people power for free. Like the star forts, like they store it in a resonant frequency shape. Like it's crazy, dude.
Well, yeah, we were talking about analog energy storage last night, bro. like physical mediums are essentially analog energy storage where you have like solid state storage, which is like batteries, I guess, kind of, or like even like lithium batteries now, bro, that store so much energy. That's kind of digitized, right? If you think of a waveform function, the difference between analog and digital is like the reproduction of the sine wave. So sine wave clips on digital when it goes through certain transformations because it can't encode all the data. It's it's got a loss to it, right? So when you change that waveform from like up to down, if it's too abrupt to make it out smooth, it'll end up as what's called a clip signal. So in analog, there's a 100% reproduction of that waveform. So in terms of comparing like storage, which still, um, like we had the what was that motor? There was a like a flywheel where they had a weight on one side, and then they had like a generator on one side, and then like a motor on the other side, and they input mechanical energy into it, and it was running both machines, and it was just storing it, and then they plugged it into like an outlet, and were powering light bulbs and like a power equipment off of it. And then they said, yeah, like this is a common like backup energy storage technology. So in terms of like the church being or the starfort being a medium, it would be an analog medium for the energy, and it has a specific frequency. That's why the acoustics are there. Man, it's like solid state electricity almost, or analog electricity almost, instead of analog kinetic energy storage like the flywheel thing.
Yeah, dude, imagine how much more like involved you are and connected you are to your energy rather than just like, you money gets taken out of your bank account sometimes or once a month and you have energy.
Yeah.
It's like there was a whole different process back then where it was like, you went to your local church or whatever it was called back then cuz like I think like weren't they repurposed as churches? Were they even churches back then? I don't
mean,
remember. There's like some ambiguity there if I'm not
there were
mistaken.
cathedrals, right? But like, yeah, were those actually religious gathering places, or did they like retrofit them into churches?
Yeah. So yeah, exactly. So there's like a whole thing there, but it's like so like you used to go to this local communal point and get electricity and hang out with the boys or whatever, and then go home with your Leyden jar and then just have electricity.
Alan, do you have a citation for that Leyden jar thing?
Yeah.
Like the I wanna read into that. Could you send that to me or post it somewhere, please?
Yes, sir. Sending it right now.
But it's crazy how like waveforms can be like incorporated into a physical medium, right? Like they're literally reproducing a 3D waveform through a cymatic pattern. That's pretty crazy to me. And using it to store electrical energy.
Yep.
Am I the only one here thinking this is profound? Like,
dude, it's the craziest thing ever, man. So yeah, on page 9 or 10, I think it is, he gets into the specifics of the Leyden jar. The copy that I sent should have it highlighted.
You're definitely not the only one, bro. This is amazing stuff. I've always been intrigued with cymatics. Now, this 3D one, that's like mind blowing.
I'm sorry, I had a text message. Can you repeat that? I apologize.
No, I was just saying I was always fascinated with cymatics. Now, to see the 3D one, that's like kind of mind blowing.
Yeah, it's
for
nuts.
real. So it goes to show you absolute connection between sound and matter and shape and distinctive shape, not just like frequency kind of a shape, like not just any kind of shape. Yeah, this is like remarkable.
Yeah, it's pretty profound, man. It's
I think they're called Lichtenberg figures. It's where someone takes, you can make them yourself. You take a board and you get it wet and you put a nail in it, then connect that to like a car battery, and it creates the forms like you see if you look at a map from way above, of like you see all the rivers and shit spidering out, or like the brain. But it's, I don't know. I assume if you were to do that in a 3D form, it would end up looking somewhat like the vortexes you're showing, you know?
Yeah.
Maybe not this musical aspect, but. And then you saw that I tagged you, that Thought Forms book. That one, you can go through and it talks about the different thought forms actually having like shapes. And they claim that certain people can actually see them. But there's one part in it that it talks about whenever a specific musician was playing at a church, that the person said that above that church you could see like a cascading formation, like a cymatic form rising above the church, just because it's like the way the churches are built, along with the precision and like quality of the music itself, the harmonics itself is pretty crazy. I think you really might like that Thought Forms book specifically, Alan.
Yeah, thank you.
Hey
Have you guys seen the Tesla electric discharge speaker that plays music?
Oh, the lightning bolt that like plays like frequencies.
Yeah, plays
It
music.
it sounds
actual-
kind of
yeah.
it sounds kind of weird reproduced. It's got a super metally sound to it.
What, the singing Tesla coils?
Yeah, but still, man.
Oh, it's cool. Yeah. Well, that's like a so. Did you have a dock on there, Alan? That was like the quadrupole electricity.
Maybe.
Well, I was thinking because electricity, right? It's got a positive and a negative. Usually, you can think of it kind of like dipolarly, right? Like there's two poles, bipole, whatever,
Yeah.
bipole model. But then if there's like a material bipole and an etheric bipole, you add 2 and 2 together, it makes 4. That's like a quadrupole, right?
Well, here's
So-
the thing, homie. The godfathers of electrical engineering, Steinmetz, Heaviside, and the other lads, that was their understanding of it. That's why they used.
I literally just made this up based on the title of the paper. Bro,
Yeah,
oh
that's
my gosh.
that's why they're not like talked about. Like they godfathered all of this stuff, and like their mathematic framework and understanding of it was that there was an etheric component to it that, as you just described, dog. That's literally why they used this is what Cyrus said. So shout out to Cyrus who dropped this gravy. This was that's why they were using like the what do you call it? Like imaginary numbers or whatever. Because that's how they had to balance it out, but it was they were accounting for that, exactly what you're talking about.
Man, I mean, that's like 3 times, and that's just like tonight. And I was talking about this happening yesterday too, and it's been like nonstop the past day, bro.
Dude, is there any other like things you want to just shout out that happened to be super true?
I don't know, bro. It just comes to me, and then I say it's like, is this a thing? Like, yeah, I don't know, bro. It's super interesting though. I mean, I could be fooling you. I could be like just the most well-researched person you've ever met on this stuff, right? And just be like a ghost in here pretending to be nobody, but that's not actually what's happening. So,
well, as soon as you said it, I was like, is he inside my head or?
it's just so intuitive, bro. I don't know. Like, that's what I'm gonna blame it on, for lack of a better explanation, right? But yeah,
It's the vortex. I'm telling you guys, there's a giant vortex with every single person that is extending out and looping back to connect to all the other vortexes with every single person in this room. Apparently, specifically between you and Alan, but that's all I'm saying.
Yeah. All right. Are we ready to get to the GPS and SAGNEX stuff?
yes.
All right. Very cool. All right. So, real quick, here's a meta argument for relativity theory. So, the constancy of C is a result of the emergent properties of relative simultaneity, meaning that there's no coherent chain of events for observers in relative motion with respect to one another. So, here's an excerpt from a paper that I'll read explaining the situation in regards to relative simultaneity versus what's called global simultaneity, because in GPS, the relative simultaneity is not manifested, which is a huge problem, because if it's not, then then there's no reason to accept any of the mathematical framework, i.e. Lorentz transformations, to explain any optical phenomenon regarding light. So here we go. Global simultaneity versus relative simultaneity. In any debate about the speed of light, the problem of simultaneity is always a focus. Special relativity claims the relativity of simultaneity, which states that two events occurring at two different places, which are viewed as simultaneous for one system, or for an observer in a system, usually will not be simultaneous if viewed from an observer in another system. But contrary to this, simultaneity is key to GPS operations. GPS is a time-ranging system. It does not directly measure the distance between two places where two events, i.e. signals transmitting and receiving, occur. It measures the difference of two instances when the events happen, and the distance is calculated when with the range measurement equation, which we'll get into here in a minute. GPS, especially its space segment and control segment, make a huge effort to establish and maintain GPS time, or simply, GPS time, or GPS system time, or simply GPS time. In a scope where GPS is applied, roughly a scope of a diameter of 50,000 kilometers or bigger, if one is using GPS, one is using GPS time, and therefore the concept of simultaneity of GPS, i.e. two events happen at two different places, coordinate system given here for event number 1 and coordinate system given here for event number 2, are simultaneous if the time portion in both coordinate systems is equal to one another. There is no true match, or there is no true matter to who the receiver is. This is true no matter who the receiver is, or the observer, or where the receiver is, or what status or speed the receiver is in. This is the basic operational principle of GPS. We call it global simultaneity. So they had to have they don't call it relative simultaneity. This is a special. They're gonna invoke a special case of Earth coordinate system where relative simultaneity doesn't apply. So if somebody asks you, or he starts talking about relativity, and they say, well, length contraction and time dilation and all that are emergent properties of relative simultaneity because c is a constant speed. Ask them, where on Earth does relative simultaneity take place? And when they find out it doesn't take place in GPS, and then it takes place in a coordinate system elsewhere, ask them, is there a gradient? Is it like, how do we get there? What's the, anyway, so when do we have to account for relative simultaneity? In a book about special relativity is the most commonly cited example about relative simultaneity is the example about a railway platform and a moving train. It says that two events, e.g. two strokes of lightning, A and B, which are simultaneous with reference to a platform, are not simultaneous with respect to a moving train, and vice versa. But GPS receivers have been utilized extensively on railway platforms and moving trains, and lightning at two different places. A and B conceptually is the same as the emissions of GPS signal from two satellites or 2D GPS stations. In fact, if two signals are emitted from two satellites or 2D GPS stations at the same GPS time, both GPS receivers on the railway and platform and the GPS receivers in the moving train will acknowledge the two events, and the emission signals will be simultaneous. Without this basic acknowledgement, GPS cannot function at all. So, special case. The Earth has no relative simultaneity. It exists in a coordinate system yet to be defined. So that's part one. That's a meta argument for relativity. To just cut right into it.
So, just to clarify, this means that for GPS to function, it would have to be able to physically measure the same time on both sides of the transmission, and we would expect to see results that transmission is always the same in all directions, right?
Yep.
Okay.
All right. So what they
That's not
find,
what we find though, right?
what they find is there's a cohesive chain of events, and it doesn't matter the velocity of the receiver at all. Everything works out fine. And further on that, we'll get into the range measurement equation and the implications that it has with the speed of light. So let's say the EC, EF, and EC, EI reference frame. So we'll go over these real quick. So I had originally interpreted the ECEF as a, or I'm sorry, the ECI reference frame as a stationary frame that's fixed stationary with respect to moving stars, and the ECEF frame as rotating with respect to fixed stars. I think it was. What they actually do is all GPS time, all the atomic clocks are all synced to the ECI coordinate system, and that can be what that synchronization means is they've synced it to sidereal time. It's actually just a little bit off of sidereal time, but they sync it to quote unquote sidereal time, right? So this frame is equivalent to being, stationary with it's like moving with the stars. You could look at it either way if you think you're on a rotating device, right? But kinematically, the frame's stationary. Now this the ECEF had these. Oh my God, they're backwards. I'm sorry. The whole time I thought I was talking about the ECI reference frame. So this is the reference frame that the initial measurement is taken of. This one on the right here. Sorry about that. I had them backwards. This is the original frame that the measurement is taken with. They say that this frame is, rotating or whatever, right? But it's station. It's so confusing, man. I have multiple sources where it's stationary, and rotating, blah blah blah. The end of the argument is that this frame, they use it. They use a center point, from the center axis of the Earth, right? So they take that stationary point, and then from outward, all clocks are synchronized to a coordinate system to sidereal time with this. So this is a locally Earth coordinate system. They don't use any other coordinate systems or anything like that. Now, this is a real problem because of the synchronization and with the orbits. If all reference frames were the same, you couldn't have that synchronization because the time would be off. It would be off from other perspectives because the motion would be different. So from other perspectives, go ahead.
Sorry.
Yeah.
I just had a question. Is it okay?
Yeah, go ahead.
So basically, if this light travels the same speed in all directions, regardless of setup or circumstance, then it would work naturally and there'd be no need for any correction, right? But the fact is that light travels different speeds and preferred directions and altitudes.
So
they're making an account for that in real time, in real life.
So not only that, but there's a delay that's proportional to the velocity of the observer. And relativity theory explicitly states that that's not supposed to happen. So what they do with this range measurement equation. So let me go over the range measurement equation. Let me start over because I kind of got ahead of myself with the orbital and the clock synchronization. Let me back it up a minute. So let's start with the range measurement equation with GPS. Okay, so GPS, the way it works is it takes where's my range measurement equation? Second. Cool. All right. Oh, range measurement equation. Here it is. Sorry about that. So these might be a little hard to see. I'll zoom in a little bit. But basically what they use here is it's the absolute value of the time the signal was received and sent, and the time ratioed against the speed of light, essentially, is what they do there. So from the look of the equation, you don't immediately assume that there's any variance to the speed of light. You're like, okay, nothing weird, no C minus V there, right? So what an analysis given by Ruyang Wang on GPS and how it works in this equation, we're going to read what he has to say about it. Some people think that the range measurement equation is based on the constancy of the speed of light. On the surface, this may appear to be true. C, the speed of light is the only velocity term that appears within the equation. Expressions such as C plus V and C minus V, which are often seen in discussions of special relativity and classical physics, do not exist in this equation. Therefore, people would conclude that if this equation is correct, special relativity is correct. If this equation has been proven to a high degree of accuracy, special relativity has been proven to a high degree of accuracy. For example, it will be concluded that special relativity has been confirmed to a limit of epsilon C over C over, less than 5 times 10 to the minus 10. So super accurate, really fine precision is what you would think out of that, right? So, but we should not judge things by their appearance. We must try to grasp their essence. If we analyze the implication of the range measurement equation carefully, we will find that contrary to to what appearance tells us, that um, and what some people might think of the correctness of GPS's range measurement equation, it actually leads to the incorrectness of the principle of the constancy of the speed of light, and furthermore the principle of relativity. This may be unexpected, but it is quite understandable if we compare it with sonar systems. Recall that in underwater navigation, sonar uses the same range measurement equation in a reference frame based on the water to calculate the distance traveled by sound through a receiver moving relative to the velocity of water, or I mean moving through the water, right? Or moving to relative to the water. The difference here is that the speed of sound in water, A, is used instead of the speed of light in a vacuum, which is C. However, no one would emphasize the constancy of the speed of sound, and contrarily, everyone thinks that the speed of sound is dependent on the motion of the sound receiver. All right.
Oh my goodness, it makes so much sense.
So, dude, it's so obvious when you hear it, right? So this equation, right? So it's like, okay, there's a variance proportional to the velocity of the receiver, right? So let's say you're a SAGNAC device and the receiver is the photographic plate and you're in rotation. Well, what SAGNAC measured is a variance in C proportional to that rotation, right? So we'll get into the cop outs and all that here in a second, but this is more on the GPS stuff. But in this situation, the electromagnetic propagation is coming to you, and there's a variance that's proportional to your velocity. So when you get into the GPS manuals, what they actually say, one second. From the ICD documents, from their interface control documents, they say that there is a Doppler shift of the frequency of the receiver signal. Of the received carrier signal that is proportional to the relative velocity of the receiver with respect to the satellite along the line of sight of the receiver. So they try and equate this to a Doppler shift frequency and not a change in the speed of light. But here's the thing: that range measurement equation and how GPS works, being a time interval system based off of C, that's what they're using to derive distance, right? So if C is a constant in that regard, when they take a measurement in this in the ECI reference frame, when they take that first measurement, they have a distance that's derived, and then due to covariance, which I didn't really get into, but I'm just going to skim through it real quick. Basically, this distance transformation has to be invariant, meaning that because it's based on the speed of light and the same time, it should be compatible with any coordinate system, right? So it falls under the covariance in this regard. And what they find somehow is that when they transform to the Earth-centered, Earth-fixed frame, right, the rotating GW8 ellipsoid that they say that we live on, there's a discrepancy there. Now, that's a huge problem because that's it's like what's going on, right? So that variance is proportional to the velocity of the observer in the same way that a rotating SAGNAC device has a first order dependence on the rotation of the device that's what causes the French shift. That's what physically causes the French shift. That variance. It's not just a Doppler frequency shift. There's a physical mechanism happening.
You know what's crazy,
What's
Alan,
that?
that I just realized?
What's up?
Bro, so you use GPS, right? All right, and it's based on the calculations that are actually deriving your position and your speed is based on these equations that account for your velocity as well compared to the speed of light. And so that means that they would be accounting for it, but when you compare it to like a map, like a globe map, right, in which the relief is not exactly consistent with the relief from like an azimuthal equidistant projection, you would expect to see that during certain portions of the driving, when your connection is otherwise known as stable, that the speed that it is telling you are going would be inconsistent with what you observe in reality on your odometer. And I mean, I personally experienced that, when I drive in areas with good connection, moving at a known speed, even with like those little speed trackers, sometimes you can verify your, odometer's accurate.
Oh,
You'll see that the GPS
tell you
will
you're
track your
faster?
position. It'll like track your position correctly, but the speed it's giving as to how fast you're moving will be slightly off by a mile or two a mile an
Oh,
hour or two in either direction, like plus or minus, right?
oh
So
yeah, yeah. They're giving a wide air tolerance there just to make it seem to give ambiguity to it because they have it down to the millimeter in that first measurement.
well, no, what I'm telling you is that the reason it's telling you that your speed is wrong is because it's doing that transform and then it's applying it to like a globe map and not an AE map, and so the inconsistencies are basically converted into errors in the projected speed that you're traveling. It's not
No,
actually measuring your raw speed relative to the ground at some points. It's actually doing the transform. It
no,
appears accurate most of the time.
no. It accurately gets all of that to the millimeter. Like what they're giving you is so that you don't know that.
Yeah, that's what I'm saying.
Oh, okay, okay. All right.
They gather accurate data, but they like tell you that you're moving the wrong speed, even though they actually know how fast you're moving, right? Like
Oh, okay, my bad, misunderstanding. I thought, okay, yeah, no, that's exactly it. So, and it's even worse than that too. So I found that they have this thing called a meridian correction for atomic clocks. So atomic clocks are accounting for the Sagnac effect as well. So what that means is in reference to an atomic clock, why would an atomic clock be accounting for the Sagnac effect? Let's see. Let me pull up an atomic clock here.
mm,
So the way an atomic clock works is similar to the cathode ray here. This is the inner workings of an atomic clock. They basically convert cesium to an energy frequency that they turn into electricity that they amplify and then measure that frequency and make sure it's oscillating at the same or like at the known rate, right? Which is like 9 billion something oscillations per second. So with that mechanism, what they're finding is that there's a delay in the propagation that varies to that's causing that oscillation to desync that's proportional to the velocity of the moving craft. So they call it a Sagnac correction. So that's insane,
mm.
right? So it's
Everything is kind of hidden in those Sagnac corrections.
and then
Like,
yeah,
go ahead.
sorry. Yeah, I was gonna say. So on that note, there was a guy named what was his name, Paul Marmot, who in this paper goes over atomic clocks, Einstein synchronization, and all that stuff. And what we find is that Einstein's clock synchronization isn't real. They don't do that. The way that they actually synchronize atomic clocks is through the Sagnac effect. Um, and that's noted from the Heffel and Keating experiment that was a complete failure in 1971. Quoted from Heffel himself, he says there was such a disagreement with measurement and experiment. I find it quite disturbing. I personally wouldn't look at this experiment and think that it proves relativity. Kind of paraphrased a little bit at the end, but that's what he said. And that was because the clocks didn't give an Einsteinian agreement. But then in 1972, the papers that were published were corrected for and gave an agreement with Einstein synchronization. And then we're told that atomic clocks and GPS work off of Einstein synchronization, but that's not how it works. That's all noted from this paper here from Paul. What they're accounting for is the Sagnac effect, and there's another correction that goes into them too, where he mentions that it is where is the meridian correction. So when these crafts, whatever's carrying this satellite, whenever it crosses the meridians, they have a correction for that. So they're literally like if you were gonna fix distances and have everything conform to a quote unquote globe, if we lived on something that wasn't a globe, these are the mechanisms by how you would fake it by cooking the books on the readings with light, because these readings are super accurate. They have to be accounted for, but it's the explanations in which they're accounting for them that are in question, right? And then the fact that they account per the meridian. So like that's really interesting, right? So if a signal is sent at a certain time and it goes for a certain amount of time, they can literally cook in on the back end whatever corrections would be necessary to fit it to a glob on a satellite orbiting at this height and altitude. They could literally change it all on the back end before it's all sent out. And that's exactly how it would work, and they already have the mechanism for that. And they talk about it in atomic clocks. And that guy Paul Marmot, after he published his paper on the criticizing Einstein clock synchronization and revealing all of this, he was kicked out of academia. All his research grants were canceled, and they came to his office at the university that he worked at and fired him, evicted him, gave him an eviction notice. straight pieced them out. So this isn't like, you know, the meridian clock synchronization is crazy, because that's exactly what would be the mechanism for how they would hide stuff and change things. So they got this correction. How do they hide it now? How are they going to hide it? So in the 1980s, there was the what is this called? The Ashby. Let's see, Neil Weiss. Okay, Alan, David, Weiss, and what's the other guy's name? Neil Ashby did this around the world relativistic Sagnac experiment. And they say that there's this mysterious effect that they have to account for, which is the Earth's rotation. So that they attribute a 2% air margin deviation, with the speed of light to that Earth rotation. So that they cover. So if you're going 30 miles an hour and there's a variance in the speed of light proportional to your velocity and all that, that's all swept up by Earth rotation correction for that. So they just uniformly swept that up. But what they're actually what they're admitting to, or not admitting to, but what they're doing and sweeping under the rug is about the speed of light is this right here. This is Daniel Garzi, and he's analyzing this GPS conundrum that we're talking about here with the speed of light. So let's see here. Okay. So I'll read this off. So this is in regards to analyzing data that's stored on a GPS data center and the corrections that are made to it in regards to the speed of light. So one of the most familiar arguments for the validity of special relativity comes from GPS, a navigation system that is said to that wouldn't achieve high accuracy without making relativistic corrections. The principal correction cited is a first-order timing adjustment to compensate for the signal propagation time variations that arise from the motions of the satellite and the ground receiver and the local Earth-centered Earth-fixed frame due to the Sagnac effect. But the Sagnac effect is purely classical. It is a first-order effect, and somehow it has been incorrectly misclassified in this interpretation as a effect of special relativity. This is noted by the experiment from Ashby and others with their Earth rotation correction, right? So let's see. So a first-order timing correction must be made for the accurate performance of GPS, just as the amount attributable to the velocity component of the satellite constellation along the line of sight in the ECEF frame. The fact that a first-order timing correction is required at all is in direct conflict with special relativity. So remember earlier when I was talking about the covariance issue, and if the speed of light was actually truly the same, when that distance derived should be invariant under transformation, so they shouldn't have any issues. There shouldn't be any back-end corrections like this. Because that equation, what Wang shows is that the range measurement equation can fully derive the Sagnac effect. So it's not even required to explain any of this. Even within GPS, it's already in there. If the speed of light were truly
Hard-coded.
Yeah, if the speed of light were truly c, and they worked as they say, these transformations would not require this correction. These corrections directly refute relativity on the face of it. So sorry, go ahead.
Sorry. I mean, I did have a question, so I guess I'll ask. It wouldn't just be GPS satellites. It would be all satellites, because satellites have to project accurate motion of their paths and simulations of their movement. But the way that they're tracking where they are is through this, signal triangulation, which is moving through the ether. And so they have to compare the timing of it, right? It would give incorrect distances just as well for those trajectories. When did they come out with the first satellites? This was the early 60s, right? Like 62, right after they formed NASA and did the Antarctic Treaty, because what had they found in the South, right? So then they went up and they launched the first satellites and started doing all this upper atmospheric research. Like, I mean, bro, they know about this stuff and they discovered it, and the timing lines up.
Yeah, and then a lot of engineers went through figuring out this stuff, and we're just kind of looking at the back end of all of it. So we'll read here. So Wolf and Pettit, 1997, tested the isotropy of the one-way speed of light by analyzing the GPS network timing signal database and found no dependency on the source and receiver motion, which they interpreted as evidence that C is isotropic. However, Wolf and Pettit noted that their dataset that they analyzed had been pre-processed and corrected for the Sagnac effect. In this case, a first order change to the time of flight to the radio signal between satellite and receiver, and justified this by making this correction by claiming that the Sagnac effect was a relativistic effect of the second order in C, and that there would be a correction negligible, and that this correction would be negligible in their analysis. But the correction that had to be made, but the correction was made was a first order in the first order in the velocity component of the line of sight between each satellite and the ground receiver in the ECF frame. Thus, while the effect of the first order line of sight velocity component of the GPS satellite is clearly evident in the raw timing data signal, the first order component had to be removed from the data set that Wolf and Petit analyzed to show that the speed is isotropic. So, right, so that correction, that Neil Ashby, thanks Neil, Sagnac correction, swooped that right up, and now they analyze this and they're like, all right, the speed of light's the same.
Man, like they literally backwards, like inversely cooked the books to have the corrections inherently built into the coding, and then when it comes out looking linear because you literally transformed it, they say, "Oh, look, it's just C equals 3E8."
Yeah, and it's a win-win because they can hide everything in there in that exact calculation that occurs.
Yeah,
man.
So let me scroll through here and see if I can get this. Okay, so let's see if I can get this straight. So this is kind of a new argument I'm gonna lay out here. Okay, so we're told all reference frames are equally valid, right? Not just our ECI and our ECEF, right? We're told that all of them are equally valid. So if you were to analyze the motion of a satellite from another perspective in the solar system or in the universe or what have you, the orbit would look different. It would be, instead of being ecliptical, it would be a cycloid, right? So it would have this kind of pattern to it. It wouldn't have that ellipsis to it, right? So its true motion, right, would be different than what we watch, right? So, and clock synchronization would have to depend on a position that preserves all reference frames uniquely, right? Not just our specific one, right? So the atomic clocks are specifically synced to the ECI reference frame, which is synced to just it's super close to sidereal time. I don't have the exact number on me, but I just read it this morning. They keep it. It's super close, and so that puts the frame. They use a kinematically stationary frame, right, to make these measurements, to take their first order measurements of the variance in the speed of light to get accurate distances down to the millimeter, based off of clock synchronization that only works on a stationary Earth. Okay, because
Bro, you know what they've done, right?
What's that?
They have taken. This is what they've done. They've used this principle, and they're accounting for this ether drift. And over these years with this tech, they have sent so many satellites up and built like a web of interconnectivity, and they have 3D modeled the virtual, like
the geometry of it,
perception of the ether drift. Yeah, like in 3D vertically and everywhere.
Yeah, I could.
Yep.
Yeah, that's good. That's what we want to do. They already did it. Yeah,
they've done it. Of course,
that's actually it.
Is there something exciting this?
No, that's 100% it. And here's how we know that we're stationary, right? So they say that the velocity component of Earth's rotation is what's producing this desynchronization, yada yada, right? Well, if the velocity component of that is producing that, well, the Earth is also moving at 30 kilometers a second, and 700 kilometers a second with respect to the CMB and all this. There's like 5 different vectors that would have to be accounted for in this universal perspective frame. None of these clocks are synchronized to any of that. There is no other velocity vectors affecting this. There would be a first order dependence on the from the equations. Like that's how it works. Like that's how it's able to derive the effects accurately. So these additional velocity vectors do not exist. And this is noted from GPS engineers. I got this paper here This is just one of many. There was a guy named A.G. Kelly who went really hard on this concept. There was a guy named what's this guy's name? I just found him the other day. Sato Masananori, whatever this guy's name is. This guy, like, same concepts. They're all realizing this, but they try and explain it through, because they assume heliocentrism is correct. So they try and explain it through like XYZ effects and, special case scenario, blah blah blah. But it's like people notice this and they're like, why don't these additional velocity vectors matter? And then they'll try and come up with an explanation as to why. Yeah, up to and including invoking a stationary ether model that's entrained to the Earth, so it protects us from these additional velocity vectors. So that's why all the clocks have to be synchronized to the Earth specifically.
That's a heck of an explanation. That's hilarious. That's
Yep.
what they did to try to say that
Yep.
why it's there.
Mm-hmm. Yep. And
Like, oh, there's like this drift where like the sky doesn't move at all and the Earth does, and
yep. And if
we're
they
just
were
catching the drift of it.
Yep. And if they were going to account for that, you would have to. There would be like fluctuations like in their equipment that would be like, oh, you're axially aligned perpendicular to this velocity vector, so now you're going to start experiencing this amount of desynchron. No, nothing. Never once. It's all local to the Earth.
Man, dude. Well, you know what this also means?
What's up?
DOE energy research laboratories that are doing like high level energy research are probably actually studying Aether right now as we sit here speaking. So there's people working in these jobs like with full knowledge of all this stuff and are working off an operational understanding of it. And they're using that in their labs and it's working because that's what we actually live in, but we're still in university level school told like it's this relativistic principle, and you probably don't find this out until you like get those jobs that like this is how it actually works.
Yeah, it's probably how it goes.
They attributed to things like Brownian motion, a bunch of other terminology, till kingdom come, pretty much.
Man,
I dropped out of MIT solid state chemistry under Professor Michael Sema, specifically because I found out the real purpose and causal factor of Brownian motion is Aether physics, which is noted by Wilhelm Reich's work and Dr. James DeMeo.
so you found that out and your professor knew and you confronted him or what?
No, I just dropped out because I knew I wasn't going to get anywhere.
Dude, you could change the world, man.
Nah, bro, you gotta go. You should go back and finish, bro, and then actually know the other stuff too. Like this is the true stuff, and then just have the credential just to meet the bare minimum. And then, like in your job interviews, if you ever go to a high level position, just straight up open up with this when they give you that room at the end to like ask your questions and stuff, and input that into the discussion, bro. Like if you truly believe that this stuff is true, then if you like apply to do something like that, the people who actually run this stuff and have an operational knowledge would also know it. They would necessarily have to. Therefore, if you already know this stuff and you're going in there talking about it in like a private job interview, you would think that that would have a positive effect, right? So I would get your degree, bro. Don't let that stop you.
I don't say this a lot, man, but I agree with Jesus. And
Sorry.
It's people like you that it's people like you that actually could make positive change if you know what I mean, like, because if that's true and you were in that field and
Nah, you
see
really
that,
can't though.
I think it's that kind of work that changes it, right?
Field by knowing the field, by building it with your bare hands and letting nobody stop you.
Heck yeah, bro.
A degree to tell you how to make a machine.
Yeah.
A degree is a piece of paper that allows you to be a slave and work for somebody else, which is not my prerogative.
I see, bro. Well, I mean, get it how you gotta get it. I'm just saying, like, it might not be as bleak as you have to try to make it. Give it a chance, bro. You can always do what you want, man. Like, I'm just saying you might not be able to procure the funding privately, like if you don't have any kind of basis for credentialing the way the world works now. I'm not saying you couldn't. Like you could go be an entrepreneur and then gather the funds on your
by
own.
just hiring somebody who has the piece of paper, whether they know what they're doing or not.
Right, but you got to be an
You know,
entrepreneur with the
hire
money
somebody
first.
who's 55 or older because that's who gets the grants. They don't give a shit about people coming out of college, you know, when they're in their 20s.
I don't always agree with Jesus, but when I do, it's about the ether.
What kind of
So
funding y'all
I
want?
literally dropped out of my position of chief of science before because of these reasons, not having certain degrees, you know, and whatnot. And we found somebody else who was like over 55 who had a degree in astrophysics, another degree in theoretical physics. Yeah, so we just find them, you know, find somebody who's written a couple of books and whatnot, and then we just put them in the position of our position. But in reality, I'm still the real chief of science. You know what I mean? In the back room, the one who's 6 miles underground. You always
Gotcha.
hire a face guy who, you know, just has the piece of paper. That's just how everything works. Real work is never done by those people because all they do is paper and they're stuck in their books and in their mouths.
Yeah, I know we argue a lot in here, but it really is my hope that just some bright guys in here like Witsit. I mean, a lot of you guys. I'm not going to name names. Alan. I'll name another name. But regardless, a lot of bright guys in here with fringe ideas, and I really do hope that you know, there's like a paradigm change coming from somebody like one of you guys. It'd be exciting for me.
Word to
What do
that,
you?
bro. Always keep your eyes open and look to what you can see, right? And if you can make this stuff be seen by people, then why not accept it, bro? And then you can accept where it logically leads you after that. We might be sharing a home as friends one day, Kosho. So you never know, bro.
Yo, I kind of agree with that guy about getting like that's kind of smart, bro. Like instead of
Right. Did
fucking
Elon Musk
being
have all those degrees? No, he didn't. He hired people who had them.
that's weird.
Like you can have an understanding of the field, and that way you can find somebody who's not totally full of shit, you know, and whatnot. That way, when you hire them, you know, you kind of know that they actually can do what their degree says. So it's good to have some understanding too, instead of just only hire somebody, obviously.
Yeah, bro. That's why I'm trying to finish my degree.
Yep, and for the people who need the piece of paper and they don't understand what you're doing and what your field is, that piece of paper will push that person in the favor of deciding whether or not you're, you know, a good candidate. If that person does know the field, they don't need you to have that piece of paper because they can just ask you certain questions or see what you've built based on that field of research.
Oh yeah, bro. If I built something dope and I could demonstrate my practical understanding of something by doing that, I'd bring
Yeah,
that to a
that's
job
like
interview with me.
bypassing the degree.
Yeah.
At least in some cases, you still need degrees and paperwork for insurance purposes and different things like that, unless you're already, you know, incorporated yourself and you're a contractor and you've already got your own bonds and your own insurance and whatnot. Then, you know, that obviously there's two ways to do it. You know, they
Yeah, bro.
pay for your liability, or you already have it, right?
Yeah, I want to do the research though, and I'm not going to go through this process to get the millions of dollars. So I would love to try to do it, by getting a career in that field. I mean, I'd probably try to do research on the side too, when I got to that point in my life where I was able to do that, but I would be starting out like doing this, right? Doesn't mean I can't go anywhere else with it. It just means that like I can do a good thing, right? And hopefully getting into a position just like Kosho said, like, I mean, how cool would it be to actually like work in this field and help develop some of this stuff, right? Even if you had to sign NDAs, even if you weren't allowed to talk about it, bro, like it wouldn't matter. You'd still be able to like further research in this stuff. And
Yeah,
like,
that's another reason why I don't work for other people. Right there, I don't sign non-disclosures. People sign mine.
that's fine, bro.
Hey,
But
I
I'm just
want
saying.
I want to pass it back to Alan because I think he's still rounding up his presentation on the GPS. But just Jesus, just to close it out real quick. What are you planning to study at school?
Engineering, bro. I'm
Oh,
like
that's cool,
halfway
man.
done.
That's cool, man. But yeah, I don't know if Alan, I don't know if you wanted to pick it back up because I feel like
Oh no, that was pretty much it. So that was the recent developments that the atomic clocks and, or have meridian corrections. They say they're accounting for the Sagnac effect. They're essentially accounting for the velocity of their own craft. And then there was some patented technology with some very interesting implications that Toby and I wanted to share.
So like, I don't know if this is like sidetracking the conversation too much, but when we talk about sort of conducting experimentation with things, this sort of ether, is there any practical application? Like someone mentioned before, like creating something or innovating something useful, and I'm just kind of curious, like, what can we use this for? Is it like
Funny you should ask, because Alan is pulling up a very interesting patent right now.
All right.
Oh,
So
cool.
so we all remember Ruyang Wang of the generalizing of the Sagnac effect right here. So before we get into the technology here, quick recap on Mr. Wang. There we go, generalized. Okay. So he took a Sagnac interferometer. He took a fiber optic gyro, did some different configurations of it, and found that you can absolutely measure linear motion with it. Right. So there was some ambiguity on whether or not he was measuring relative motion between this part of the track that's moving and the stationary observer, that kind of stuff, right? So is there a situation like that? That is not the case. And the only way to maintain that position is to philosophically invoke absolute space to to preserve the distance, so that you could say that the distance started versus the distance traveled, to preserve that, to maintain the speed of light. But then you're going to have another problem though, because in reality there's a fringe shift that's produced. So you could get a Doppler shift out of that, no problem, out of that philosophical argument, but you cannot get a fringe shift that's proportional to that velocity as well. And that's actually what they measure. That's how a FOG works. So this technology explicitly works off of measuring absolute space and a variance in the speed of light. Now, when Sagnac took his original configuration of the interferometer and rotated it, he found that there was a first order dependence on the fringes that corresponded to the velocity of how fast the table was turning, right? So they try and say, oh, this is only you can only detect rotational motion with this, and linear interferometry, such as Michelson-Morley, etc., is off limits. That's because the speed of light is constant. Can't measure linear motion. Earth's orbital velocity is a no go. You got to hit up your boy Lorentz and see what's up with that transformation, and for all of that, right? So keep in mind they've divided interferometry into two separate sections, linear and circular. So for the linear, they use Lorentz transformations to explain everything. For the what do you call it? For the
rotational.
Yeah, sorry, thank you. For the rotational circular interferometry, closed loop circuits, they use they're okay with allowing a variance in the speed of light, because they say, well, it's a non-inertial reference frame. It's rotating, so we can have the variance in the speed of light. So what they do is they'll use the philosophic implication of preserving a background medium to preserve the distance, so they could say that the speed of light's the same. They use that justification to use the Lorentz transformation to analyze the situation from a different perspective, where they can view the center axis of rotation from a different perspective, and they're allowed to see that the speed of light varies from this perspective, right? That's how they explain it, because it's a non-inertial system. So they can only explain the physicality of the fringe shift with a Lorentz transformation. They can explain the like a Doppler shift with this equation, and you could hypothetically in your mind conceptually preserve the length, blah blah blah, right? But to get that fringe, for the technology to actually work and produce a fringe proportional to the velocity, the speed of light has to change. So in this equation, you'll note that the only things in there are the velocity of the device and the speed of light. So that is what they're. Go ahead.
I'm sorry. Are you telling me that a Lorentz transformation is actually a 1-for-1 inverse with the distributed Sagnac effect across the ether drift?
No, they have different contraction rates for it.
Oh,
and-
there's okay. Because I was like, if it matched up like that, because you're saying they basically offset it using a Lorentz transformation.
no,
So unless they're just saying,
so
oh,
th-
go ahead.
yeah, so they say the speed of light is the same, and that the apparatus contracted slightly, and that produced the fringe pattern that we see. So like that's how they use it for that. There's
Right.
no, it's not like a ether. It's not an actual like ether thing. They just use it to scale things proportional to how they need to warp their coordinate system. It's not like a fixed value. You know what I mean? It's like a scale.
But wouldn't the offset that it makes have to be proportional with the actual corrections that they're making in order for them to offset each other and not appear in the final result?
No, because they assume the speed is the same. So like they take them, they don't even consider the fringe as like part of the measurement. They just
Oh.
yeah, like there's no like proportional, like, because I thought that it was like that they use the contraction to explain the fringe in the way that you just thought, but it's the opposite. They say that there's no fringe, and that the little that they did observe is due to that, but not to a proportional ratio or anything in the way that
So they just steel man it. They don't even try to go through all that math. They just steel manned it. They're like,
no.
it just shrinks the proportion. It just shrinks proportionally to whatever we need it to offset it. Like
Like
it's not
worse than
even-
you expected, right?
Yeah, it's worse than
Yeah, worse than
Yeah,
you
it's all
could,
just ad hoc.
worse than you could ever imagine. So that gamma factor correction though scales proportional to things like mass, velocity, gravitational potential, etc. So they can literally get however much distortion they need out of a coordinate system to make the speed of light appear the same. And that's because once you've accepted the Lorentz transformation, like that's it. That's all it is. If you need the speed of light to be the same, call in your boy Lorentz and he's got you. Like that's all it is. If you don't care about that and you can just derive it from classical effects and show that the velocity, or that the fringe velocity is proportional to the or when ratioed against the speed of light is proportional to the velocity of the observer, right? So, and that's where it gets crazy, right? Because that's where you're actually measuring absolute motion. So this was in 2002, 2003, Toby, and then
2004. And just like real quick to bring it back to the GPS thing. So with GPS, you are measuring the velocity of a one-way electromagnetic wave, right? And with this, you actually have a full optical, like a FOG setup, a fiber optic gyro setup, where you're actually measuring a full fringe shift. So that there's a difference there versus like a one-way electromagnetic propagation versus this being a full fiber optic gyro setup where you're actually measuring a fringe shift within a in that case, the lab frame would be between the two moving satellites. In this case, the lab frame is this full apparatus in motion. And it's a pretty cool setup. As you see, there's like I don't know if anyone is like confused about what we're looking at there, but you've got 3 different linear motions that are happening because the conveyor moves the FOG. So like you'd have your laser going through all that optical fiber, which is coiled around those 2 wheels there, and then you have one quick motion where everything moves in that linear velocity, that linear motion there, and then that linear motion is measured proportionally, just like it is in a classic rotational interferometer, like a classic Sagnac device. So what that means is that absolute motion, the linear motion, is being picked up by the light. So what is the light, and what is relational to that light that is causing a fringe shift? You have to. It's a really, like, if you really think about it, like if you're running with a flame, like a torch, and the torch is getting dragged behind you, the air is causing that, right? But in this case, there is no air, there is no resistance. They actually tried with a glass core fiber and an air core fiber, and the what's the word I want? The refraction does not play into the fringe shift difference. There's no the relationship is the same whether it's glass core or air core fiber. So there's an absolute space that's being measured. There's something underneath of the glass, underneath of the air core. There's something else that's measured with that velocity. The length of that fiber optic cable, when that whole thing moves, the length of the cable did not change. The length of the cable stayed exactly the same, but the fringe shift showed up. So the only way to explain that, because the speed was different and proportional to the velocity there, the only way to explain that without acknowledging that the proportional velocity changed plus or minus on whichever side you were going, because it's going to be either faster going with the velocity or slower going against the velocity, is to invoke a Lorentz transform.
So
Which
can I ask
causes
a real basic question?
Yeah, go ahead.
Is this sort of proposing that I mean this sounds like you can measure time and space, and then we can start getting distances, right? That sort of, I mean, this implies that we can make a tool like that is an alternative to, say, like what would be accelerometers that we have in our phones, etc.
Yes. Yeah, you've got the kind of the right idea here. So now Alan pulled up the patent. You can take it away, Alan.
Yep.
That's exactly you've definitely got like the right idea.
Because that's interesting. Just on a side note, because I remember Witsit sort of talking about this idea of having trouble on water, working out what your distance and your speed. It's all done in knots, and it's like, what is it? It's I think it's just sort of measured by water displacement, like how much water you're moving through, but you can't tell what the current's doing, etc. So it sounds like this piece of technology might have a way for us to actually measure. Because what was it? Yeah, it's like boat speeds in the southern hemisphere are apparently less than the ones in the northern hemisphere, and the hypothesis is because of the way that they've wrapped the globe around and its effects on the GPS signaling.
Yeah, so this device is,
like
I believe, over 2 meters in length, which I didn't realize for like the first time I looked at this paper. And that fiber is wrapped around quite a few times. So I can't recall if it says exactly. 11 turns. So that is all necessary to get a level of precision to actually be able to measure that motion. I know with like the Michelson-Morley original interferometer that they did, that had the highest level of precision that could detect would have been 2 kilometers per second. So his speedometer patent that we're like pulling up here now, I'm not sure how large it would actually have to be. Maybe it would have to be quite large, especially if you were going to try and measure X, Y, and Z axis. But yeah, maybe I'm getting a little bit ahead of ourselves here.
Yeah, cool. No, thanks for answering that.
Sorry, Alan, I didn't want to take it away. My bad.
Oh no, you're straight, bro. Killed it, bro. Yeah, so that's it. That's the crux of the issue. So this does measure linear motion. You can only preserve the constancy of C by swapping out your ability to physically explain the fringe shift. So you're trading the Doppler shift for the fringe. The classical interpretation where C varies keeps them both. So me personally, I'm going with the classic interpretation for my interpretation of this experiment. All right.
Pull up that patent real quick.
Yes, sir.
And let's just like look through those diagrams because
Yeah.
Also, I'll lay out real quick the timeline. Wang did his first experiments in 2003, discovered that the linear motion could be measured with interferometry. And then if you scroll down just a little bit, Alan, or no, there it is at the bottom, 0.60 there. The provisional application for his patent was filed in January of 2004. So, and then it was finished being filed in 2005. But so he finished the first set of experiments, filed the provisional application for the patent, and then in 2004, same year, he did the other set of experiments that we just looked at to further confirm that he could detect the linear motion. He did a couple more. He did multiple more configurations, in multiple ways, and then So then this patent got filed. Oh, when he did his experiments in 2004, by the way, like he was using multi-million-dollar fiber optic gyro setup. He had, like super expensive air core fiber, super expensive glass core fiber. If you go back on the paper there, it actually says where the materials were provided from. I believe it was the Navy, I believe.
Yep, the Naval Research. Yeah, we thank Dean Langley for a useful discussion and help. We thank Robert Mueller of the Naval Research Laboratory for technical assistance, and the NRL for the loan for the FOG. The air fiber was purchased from Crystal Fiber in Denmark.
Okay, so yeah, there you go. But so that the Navy was interested in this, for to me obvious reasons, and they wouldn't have been interested in it if they thought it was some kind of parlor trick or if it was something unremarkable. And yeah, so Wang got it. Wang immediately filed for the speedometer patent using this exact thing. And then Wang still is talking about this today. Like he wrote a paper in July of this year talking about the preferred directionality of the speed of light. And a few years ago, I want to say it was 2017, he did another paper where he was like taunting people. he just proposes like a ton of new configurations for his linear interferometer test, going through a vacuum, through like empty space, like separating, like he's just like every which way you can possibly just slice and dice special relativity. So it's, he in my opinion, it's because he knows what's going on. He hasn't just been spending 20 years obsessing about this for no good reason. The Navy wasn't interested for no good reason. Yeah.
Yo, so the same way
Wow.
we get Bennett on and shit, like, is there a way we could actually get this Wang guy to pull up the patent holder? I mean, he might be a very busy man, but
No, this
you
is
know,
why
I don't think he would be.
Bennett reached out to him and Wang ghosted him. And I reached out to him and was talking about something completely unrelated to this, and he ghosted me just on the implications of the ECI reference frame. So like this dude is not trying to talk to anyone about anything regarding this, like, this stuff.
Yeah, he worked with the Navy and signed an NDA, and he can't talk about it. So he's like, "These people are bothering me. I don't want to be bothered. Like, I don't. I want to tell them, but I don't want to get in trouble."
Yep.
So he just wants to own the patents and make a fat chunk, essentially,
Pretty much.
but doesn't want to break off any of the bread or gravy.
That's what it sounds like. I mean, they couldn't
You don't
stop
want to
him.
get a foot broke off in his,
Yeah, they couldn't stop him from publishing. Where was that? Was that new paper? 2023,
like 2017-ish. Oh, you're talking about that one. Yeah.
Yeah. It's like he may have signed an NDA, but they definitely didn't include. Wait, this isn't the one. They didn't include that he has to. I can't find it.
Which
But,
that one's funny too. That one's also just like another proposed way to just body bag the rotation measurement.
Yeah.
That they claim. Pull up the one from like 2017 or whatever. I think is pretty interesting. Just it's like the number of configurations he lists it's just funny to me. He's like, you could prove relativity wrong this way. You could do it this way. You could do it this way.
Oh, man.
The risky configuration is the best.
Oh yeah.
Dang, is there a hot drop link where we can just download that patent real quick?
Yeah.
Yeah. I mean, it's on Google. If you just search Ruyong Wang patent, actually, you'll find it.
Yeah. Here's the patent. Let's put it in chat.
But yeah, I can try.
I can't find my paper on that. I got it.
I can pull it up.
Do you know the title of it,
Just send a
Toby?
drop in chat. No, let me pull it up.
I put that in a search engine and it said no results.
Go to Google
Light drag effect of vacuum tube versus light propagation in stationary vacuum tube with moving source and receiver.
What is it?
Let me. So this is the experiment, and then I'll drop the patent as well.
Yeah, I don't have it. Can you screen share, Toby?
Sure.
All
right. Won't have all your beautiful highlights, but it's okay. Show in folder. There we go.
Light drag effect. Thought I had this.
Real quick, let me see if I have the patent open while we're in here. Yeah, here's the patent, so I can drop this too. But so yeah, here's like just him, his proposed configurations. It's just so with this one, you'd have the the receiver and the source, and you would move a group of media to the left. So you'd be measuring that motion. And this one, you're moving the source and the receiver this way. So you're measuring motion of the moving source and receiver rather than the media. With this one, you're doing it through glass and a vacuum. Then he gets a little bit more in depth with these. Like right here, you have a stationary source and receiver, and then you would move this way. Is that what this one is? Yeah. And you can see he's got like all the, like it's just hilarious. He's got like a vacuum cell in the middle with glass rods. So it's just like you can't make any kind of weird assertions about refractive indexes or anything. And then he gets like he starts getting way into it with so yeah, with this one he's got like a like yeah, there's empty space in between, or there's like he actually talks about the drag or the refractive index, the drag of this area being being inconsequential. It's been calculated. You can calculate it out. But yeah, you've got glass going through. You're going through glass and a stationary vacuum. You're moving the source and the receiver, and you would detect that. Is kind of what, or would you detect that? Is like what he's saying, you know. And then with this, you're going from an atomic clock. I mean, clearly, in my opinion, this is like, all right, I know how atomic clocks work now. I know what's going to happen here. He's talking about moving the atomic clock with the source and the receiver. And
I mean,
then
etherics are literally running these technologies, bro. Like
100%.
It's the only way it can work.
Yep, that's why they had to make the Bob 15 degree per hour like such a psyop and so shameful and whatnot. Because if you actually investigate this, the whole thing comes unraveled. The Sagnac in 1913 directly refuted special relativity on the face of it. In Einstein's own 1905 paper, he says that any closed polygonal circuit is in uniform rotation is considered an inertial reference frame. Because if you take that closed polygonal circuit, stretch it out to infinity, all the parts of it are basically like there's the deviation between linear and circular motion is it's not gonna matter. So it's literally an inertial frame as stated by Einstein in his own words. Sagnac comes out with a uniformly rotating device and shows that there's a variance in the speed of light proportional to the rotation of the device.
Bro,
that's it, and they have no explanation for that. That went unanswered until 1917 by not even Einstein. You would think the guy that made the theory would pop up and be like, "Oh, that's cool. Let me explain how that's actually not the case." Nope, doesn't address it. Somebody else did it, and through a coordinate system transformation. So basically, this is the introduction to explaining the Sagnac effect without explaining the Sagnac effect. What was that paper called? Tartaglia.
Oh yeah, Tartaglia. Pure geometry. The Sagnac effect in pure geometry.
Yeah,
I mean, bro, literally,
Such a wizardry
literally,
name.
the whole reason this has to remain secret, a lot of this technology is done under private contract development with like defense operations and just the government themselves and the military, is because if the public was like, if it was like, you know, open, admitted, and it well known that the etherics were driving these physical systems, that admitting the ether would therefore implicitly admit geocentrism and by extension God. So
Yep.
They don't want that to happen.
It's all an end user result to consumer energy. Everything is about energy. Everything. Cannot stress that any more than anybody else can do. You have to understand that all of this is simply to prevent you from accessing more efficient systems. Through this understanding, you would have over unity driven motors You would have fuelless planes, fuelless boats, fuelless cars, etc. That's why it's hidden.
Man, I'm just wondering how
You know,
knowledge of the
I
ether
agree
would
with.
result in that limitless energy, though.
Well, it will lead to more efficiency. That's the key. So, like, if you have a generator and you're spinning it, you know, a certain way in a certain part of the hemisphere, and you're able to like generate more energy by doing something a little bit differently with the symmetries and whatnot, then you're gonna this access to this knowledge is gonna help you do it.
Okay, bro.
Hey, Alan, Toby,
What's up?
thanks.
Yeah, dude. Thanks for sharing this stuff. Like, this is freaking dope, bro.
Dude,
Yeah.
I've been
No worries.
super into it.
It's all very exciting.
It's just insanely fascinating, honestly.
I mean, I wasn't even like planning on necessarily getting to sit through all this, but I've been absorbing this like a freaking sponge, bro. Like, no cap. This is great.
Your questions have been awesome. Just like it's been awesome listening to you just be like, well, wait a minute. That makes sense. Well, wait a minute. What about this? It's
Thanks,
awesome.
bro. Thanks, bro. Yeah, it's been great. Thanks.
So an example of the application would be uniquely designed antennas to induct energy in from the environment, from the system that we're, you know, obviously swimming around in, so that you can tap into the radiant energies and use it as a power source directly. Of course, Tesla was trying to do.
Bro, have you ever thought, like, just for a second, how deep does this ethereal connection in our like reality go? Right, like just how many facets and aspects of our material reality that we have a current perception of would be heavily altered if we understood the ways in which that interactivity propagated through ether? Does anybody understand that question?
Yeah.
A total understanding of it would eliminate scarcity overnight, literally.
I mean, just the flat Earth being real kind of eliminates scarcity, but this is like, wow.
Yeah, this is.
Oil wouldn't matter. The price of oil, you know, price of anything wouldn't matter because we would have a full understanding that everything is energy and matter is energy, matter is light, light is energy, light is matter. And once you have a full understanding of all this stuff, then you can equivalently exchange everything to everything else. So you create, you know, you induct the energy from the environment, compress it, store it, and once you have enough, you can create any matter that you want.
I mean, that if you're saying that that this is what you would do, then what you're basically saying is this is what they are doing and have done, and why would they not be? And therefore, they probably already have access to the dude, like the public research releases
and whatnot, but alchemical transmutation of like mercury to gold is 100% proven. I personally know people who have done it themselves, but it's not like something that you can really do on a mass scale. At least we don't know how to do it on a mass scale yet. So it's like you're better off just getting a regular job, you know, and working, you know, making $20 an hour, and it's buy the gold, right? And you can, that's actually more efficient because you can't make enough of it at one time. But with these understandings of the way these things are working, that could change, and we may be able to start doing things like this on a mass scale, which, you know, definitely would be something that would be kept secret because, you know, anything to do with pricing of anything, making it appear as if to be scarce. I mean, that's how you literally control everything, you know.
Midas, this is Midas's touch, isn't it? And the cautionary tale. Start playing with this technology, you start turning everything to gold.
With the way you would build your antenna systems to efficiently take this energy in, and you have to know the symbology and the pre-existing movement of all things. because you want to work with that. You don't want to work against it.
Right. I mean, dude, Tesla figured this stuff out. Tesla figured this stuff out, and they destroyed his research in his lab, and
And
you
he
know,
rediscovered it too. Like we had all these ancients who understood this stuff, and they
right,
were doing it.
But
I mean,
like at this point in time,
holes underneath their pyramids.
at this point in time, they've like snapped in like an information control program to like remove the knowledge of this from our society.
Oh no, no, duh. Yeah.
I mean, like, because you got to think about the implicit connections, right? So, if you look at the and assess the connections between like the etheric medium, like acceptance of it, the publicly disseminated full total understanding of it, like that would draw conclusions that would lead people into like the worldview shifting stuff I was talking about earlier. And so they absolutely just literally you have a form of energy, and the understanding in the realm of energy is like leading to a revelation of like a worldview and paradigm shift.
Right, which is the magneto-dielectric connection. Instead of using terms like electromagnetism, and all this transverse nonsense and whatnot that we've continued to use, there is a superior way to propagate energy that is more in harmony or coherence with the universe.
Oh yeah, you were saying. Oh, so you're basically talking about like instead of the cross reference between magnetism and electricity, as that like relates to one particular type of propagation, magnetism and dielectricity.
Right, like you get a lot better credit, and you will lead somebody to more information by telling them magnetodielectricity instead of electromagnetism.
What's the difference in the cross reference of those two things? Like, what happens that's novel as compared to?
The biggest novel change is the differentiation between, as example, transverse propagation and longitudinal or standing wave. Any names for it? Another name is scalar.
What does it? What does that look like in a graphic form, like a visual format, to elucidate
It's
the form
more
of the waveform?
like a drop in water. I posted a video where you can kind of see it and whatnot earlier in the research. Let's see, hold on. The research videos channel. I'll repost it. Hold on.
All right. So I think we'll probably wrap up the presentation here now then.
I reposted it in the live stream.
All right. All right, bro. Thank you. Yeah, absolutely, bro. Like golf clap for that presentation, man.
Yeah,
Good job.
No worries, man.
So anybody, maybe we can, I don't know if you guys still got the stream open, but anybody in the chat, like, because I know that a lot of people aren't actually talking in here, but anybody in the chat, like, got some worldview shaking, I don't know, angles taken away from that conversation y'all listened to? How about the stream, bro? Like, anybody in this, we got like dozens of people in here right now who had their, who had themselves question their worldview, or at least the implications of this stuff tonight.
What'd you go over this evening, Alan? Sorry, I just got into the.
Oh, what's up, Napalm?
What up?
Went over vortices, pressure mediation, GPS, the Sagnac effect, atomic clocks. Everything synced to a stationary Earth. They don't account for any additional velocity vectors that they would have to, if their whole thing about all reference frames being equally valid were true, because the satellites would be experiencing those motions, irrespective of any interpretations that we have of Michelson-Morley. So if they're going to account for the Sagnac effect in their technology, which they say they do, so that's it. The basic the basic stuff. Oh yeah, we went over linear interferometry, or I'm sorry, the Sagnac effect being used to detect linear interferometry, which obviously falsifies the claims about your mic's going off, bro. Which falsifies their claims about not being able to detect linear motion, with Mickelson, Morley, and whatnot. So we got him on all fronts.
Nice.
Got a patent for a speedometer that detects absolute motion using a preferred frame. The huge.
Did you go over the translation between the ECI and ECEF?
Yeah, sure did. So the
Is
way
that
that
part of it?
so the atomic clocks on the Earth are synchronized to sidereal time. So that's how they make the frame match, quote unquote, Earth rotation or what have you. So they're match the stars. So they get it synced up with that. It's actually slightly off of sidereal time, but that's what they have it synced to. And then the corrections, the so-called corrections that they make, the quote, I'm using air quotes, the quote unquote relativistic corrections that they make don't exist, and they're just accounting for the Sagnac effect, which means that they're just accounting for the velocity of the craft, whatever speed that may be. So that's how they're making the adjustments to do that. And also, whenever they cross a meridian, there's an additional correction that they apply so that nobody can actually determine the distances that are derived from GPS and all that stuff. So that's cool. That's cool.
Interesting.
Yeah. Yep.
Awesome. I'll have to go back through it.
Yeah,
Check it out.
and so both of these frames are stationary, turns out. So even though they say, because I've read, like I know what Doofus is talking about when he mentioned that earlier and brought that up. There's definitely references to that, and it says that as well. But when you look at what the math is and how it's how the clocks are synced, they're explicitly saying the Earth is motionless. The only thing you could say is that is if you wanted to be generous, is you could say that the Earth is stationary, but it's rotating, and they're accounting for that rotation, in the globular paradigm. But you could not extrapolate Earth motion, in terms of like orbital velocity, moving through the cosmos, any of that stuff. Zero.
Right. It's just rotational. And so my understanding is like it's either synced with the star's rotation or without the star's rotation, right?
No, it's synced to the rotation of the stars to make the speed of light like appear to be the same, because they basically sync it to the ether
Right.
wind, right?
Right. Which just if the ether wind is a translation of the star's motion to begin with, then it's
Oh,
yeah.
right.
No, I got you.
Yep. Yes, sir. So it turns out there's a preferred frame, and
I
it's
have a
a
question.
stationary frame. What's up?
This may be too abstract. I guess it goes to scale. Now, I've got my own opinions on that, but it's all right. How big might the area outside the dome be, in your opinion? How far away might stars really be? You have a guess?
Yeah, I don't think there's like a dome or like outside of a dome. I think it exists inside of like a field. Like I don't like, I think that the distances and stuff that they give us is just like
Oh yeah, but okay.
yeah, like I think it's all like in a local field. I don't think it's far or anything like that.
No, you don't think it's all that any of them?
Nope.
Like the planets or whatever. That you don't hold it all to these classical moderns that have
No,
7
no,
planets with different.
no,
None of that
no.
at all.
I think they're all really close.
Huh. Okay. And so obviously it's just all the crap about redshift and all that is bullshit, obviously. Interesting. Okay.
Yeah, well, like the redshift phenomenon itself is real, obviously, but their interpretation of it and what they apply to it, and when you have the leniency of the
Alright.
assumption of correctness, I mean, when you look at
Yeah.
the corrections, and like they can just interpret it however they want, man.
They gotta revise their models awful lot, don't they? Well, it is
Well,
what it is.
well, they got to cancel people that directly refute the model, like they did with Holton Arp, where he made the observation with the quasars having filaments connected to the galaxies, which they that can't happen. The quasars are supposed to be like essentially like an infinite distance away, so like they can't be
it's any
interacting with that. So yeah, they banned him from.
consolation,
I'm sorry. Go ahead.
I was gonna say, if it's any consolation, this happens in it appears every area of science
It seems
that
that way,
I've run
man.
into.
So you said the quasars interact with what? Or
So
can you repeat that again?
yeah, so that whole NARP guy made observations with quasars, and he said that he observed a filament that's connected to the galaxies. So obviously, like the distances can't be like trillions and gazillions of light years if they're connected.
So some part of like the apparent like rotation or motion that they appear to give off was linked between things that were supposed to be like infinitesimally far apart,
As the story
and that.
goes.
What's the
Yeah.
filament? I'm just wondering what that means.
So like the interconnectedness between what they call a quasar, which is just like a dot in the sky that emits energy that it doesn't move, and the motion of a nearby galaxy. So they say that there's like an interconnected energy, or he's saying that there's an interconnected energy there, and that wouldn't be possible, if the quasar was actually like billions of miles or infinitely behind the fucking galaxy or whatever.
Mm-hmm.
Because that's their interpretation. Because it's crazy, dude. Quasars are a real problem for them, man. There was a really interesting paper I read from the '60s by a guy named Y.P. Varnishi, who basically there was like an observation of like 57 different quasars or something, and the configuration in which you can see them in, you can only see them from the Earth. If we were in a different coordinate system, you couldn't see all 50 whatever of them, 57 of them or whatever it was. So he was like, the implications here are that like we're unique and we should probably throw out the Copernican principle, relativity, all this stuff. And then he was like, or we can abandon our interpretation of redshift. Anyway, I'll leave it to you guys to figure out. And then he like pieces out the paper. Like it's crazy, dude. It's like these observations that directly refute their model exist. Somebody gets a paper out and then just nobody talks about it. They just deal with it by not talking about it, and then hoping that nobody ever brings it up.
Man, so like the people who create missile tech and all that kinds of stuff would have to be using, when they say they use like an Earth-centered or Earth-fixed non-rotational reference frame, right, in the papers, like a linear derivation model, they would still have to be using this even in that model because they'd have to account for the drift for all the distances. Like it says it guides itself off of Polaris, right? Like that's what a lot of these ICBMs and like missiles that like shoot really far do when they get up in the upper atmosphere. Their reference system goes to a guidance by comparative location and Polaris. And like so where you are on the ground, where it is in the sky, and then where Polaris is in the sky, right? And so, or where its target is on the ground, right? It calculates all that. This would have to take into account that ether drift as well, or it would not work. So even people who like work on weapons and defense systems and stuff like that would have to know this stuff.
Yeah, YP Varshini brought that smoke, bro.
Yeah, I'm looking for it right now. I got it somewhere. That paper was a banger, bro.
Dude.
There was so you did a presentation on that, the geocentric presentation, and you know how you had all those quotes and stuff, and everyone's like, "Oh, it's a quote miner. What a quote mining loser." I was like, "Okay, bet. Let me look up these quotes and see if it's a quote mining loser." So I look them up, and that YP Vernici paper was like the paper itself was even way better than what you had quote unquote quote mined from it. I mean, that paper was insane. The implication there.
So the redshift hypothesis for quasars.
Yeah.
Is the Earth the center of the universe?
Is the Earth the center? Yep, that's the one.
Yeah. Go ahead. Sorry.
Hey, I had to step away.
The
Did you
quote
say
I have
where
right
he got
here
banned
says.
from?
The quote I have right here says, "It is shown that the cosmological interpretation of the redshift in the spectra of quasars leads to yet another paradoxical result, namely that the Earth is the center of the universe."
Yep.
Stop quote mining.
Quote mining.
What's the
quote miner?
Yeah, can somebody? Oh my gosh!
You
Thanks,
quote
Alan.
mine. Yeah, yeah. That paper
Oh
was
my
insane because it's so obvious. He's like, so he gives 3 possible explanations at the end of this observation that can only be explained if Earth is at the center of it. He says explanation number 1. Coincidence in distance could be possible if there was clustering. However, an examination of the coordinates of the various members of individual groups show that in most cases there is no such correlation. Hence, this explanation should be ruled out. Explanation number 2. Quasars may be arranged like atoms in a crystal lattice, with the Earth being either at the empty lattice site or in a suitable interstitial site. Which, should that be the case, one would expect some pattern or irregularity in the discretion or distribution of the quasars. Let's see, belonging to a certain group. No such evidence is found, and this possibility must also be abandoned. Okay, so two possibilities were given. Not that one. Is it the third one? Maybe. Let's see what that one is. The Earth is indeed the center of the universe. The arrangement of the quasars on certain spherical shells is only with respect to the Earth. These shells would disappear if viewed from another galaxy or quasar. This means that the cosmological principle would have to go. It also implies that a coordinate system fixed to the Earth will be a preferred frame of reference for the universe. Consequently, both the special and general theory must be abandoned for cosmological purposes. Well, did he go with that? Let's see. We must also consider two other possibilities. Oh no, there's two more. What do we got? Which must be discussed here in the literature of the apparent redshift of quasars. This difficulty in the assuming that the redshifts are like gravitational redshifts, which are known, they're not, spoiler alert. We should be able to repeat them here. In addition, there is no reason why these coincidences of these values of the redshift, corresponds. The local Doppler interpretation, but basically he's saying if all else fails, we can always abandon our interpretation of redshift. So,
but they can't. But they
yeah, but they can't. Like they can't. But like,
do you have a link to your presentation tonight?
Yes.
This is why the only responses I got to that presentation was just the baseless accusation that I was quote mining, because there are some damning quotes in there, and like Alan said, these aren't even recent papers. This is from like the 70s. They just pretend it never happened.
Can I get a link, please?
Yep, linked it in the chat. It's still live at the moment too. But yeah, man, those papers were awesome, and going through those quotes and then getting the full context, it was like, oh no, this isn't. This is like, if that's the only refutation to it, then yeah, it turns out when you measure something and how fast it moves across the sky and build a model off of it, that doesn't actually give you a diameter or orbital radius or anything. You have to extrapolate all that. The best possible evidence, in my opinion, for heliocentrism would be stellar aberration, but we swooped that up recently, so rest in pieces.
Yeah, and like, so I need to really redo the geocentrism thing, because like you've gotten tons of new resources and stuff like that, and we found new stuff. But bro, that took me so long, like
You got this, man.
Yeah, that was
took
a
me so
dope
long. You have
presentation.
no idea, bro. You have no idea. Like Kai knows, I was just up all night, multiple nights in a row, like making memes.
Dude,
Oh,
it shows. Even just screenshotting the memes from that video took me like 20 minutes to an hour. Like, yeah, and then when I remember doing that, just thinking like, holy cow, like this was so much work for him.
And I went and found the picture of each person.
Yeah.
That alone doubled the time, but yeah, I think we should do it again. I mean, I will say it's not even aesthetically pleasing. It's like, I think we should really hone down on the geocentrism thing, because we'll just sit back. I mean, they're gonna end up falling over this way anyway.
Yep.
We should bury heliocentrism as a
I had a
priority.
question also.
What's up?
Because the guy that made the quasar observations, you were interrupted when you said he got banned. I was curious where he got banned from.
Oh, all the what do you call them? Observation, all the observatories in America. Yes, he had to go to the United Kingdom to use observatories over there.
Wow.
Yeah, straight
Are
blackballed.
you talking about Halton Arp?
Yep.
Yeah, yep, Halton Arp, and he was like famous in their paradigm. He came up with some of he was renowned for coming up with certain maps, stellar maps, or more so galaxy maps.
Did he
Right?
get that ban in writing? What was the reason?
Did
they
He
provide a reason?
he's famous for the Atlas of Peculiar Galaxies, the catalog of peculiar galaxies produced by Halton Arp in 1966. A total of 338 galaxies are presented in the Atlas, which were like previously unaccounted for, and it was like revolutionary. Right? So he's cool. He's awesome. And then he stepped out of line and said, okay, what we're calling redshift is just, there's no way it's correct. Get out of here.
Well, he had to say that because the only other option is that the Earth's not moving.
Well, he kind of leaves that. He kind of leaves it up. Oh no. Like if redshift's wrong, either you're screwed and the Earth's not moving, or someone's going to have to come up with some new creative alternative, right? But as he points out that the current one doesn't work, he's not even saying like here are the ramifications or implications of it. Just like it doesn't work. People won't even look at it. They're like, no, 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 no. So it's really wild. I mean, this is how many? I mean, 5 decades ago, 7 decades ago.
Wow.
That's why I said I don't bother and I just dropped out. It's the same old, same old. Don't confuse us with the facts. We've already made up our minds.
Don't confuse us with the truth. Yeah, that's essentially it. So yeah,
Easier to just
they
leave
scooted
the
him right out the
scene,
door.
build in quiet, and then come out when you've built something that they can't build because they follow broken science.
So are these observatories government funded? Like, can any regular Joe like schedule, you know, access, or how does
Oh,
that
good
work?
luck. You got to get approval. I mean, like you can go try to visit them. Can you walk up and use the observatory? Hell no. Hell no, because they're so expensive. I mean,
Yeah, there's a waiting list.
They're
Even
government funded, right?
well, yeah, but no. Here's
government
the
funded, so technically you can try to get to them, right?
there's a huge
I
waiting
mean,
list. Even people that aren't blacklisted, like you have to fill out requests. You're on a waiting list. You have like observation windows, and if somebody's project like supersedes yours due to some XYZ important phenomenon that's only going to happen, at the same time yours is, like, sorry, you just lost your observation. Like they go through a whole rigmarole over the telescopes. So yeah, like control over them is definitely like
I'm sure they'll let
a
us go
mechanism they
if
can
we tell them
yeah.
that we want to make
Yeah.
geocentric observations.
Yeah, we want to see if we can invalidate Harp's work or whatever.
All of cosmology.
Most of them have open houses and stuff. That's about the closest you ever really get to them.
Yeah, which that doesn't count, right? I mean,
Yeah. You don't get to aim the telescope at what you want to do and spend 2 hours looking through it.
I'm telling you, bro, the only way it's all gate kept. The only way you're ever gonna make like meaningful, super meaningful long term progress is to like most likely use their facilities, which they're probably gonna make you sign an NDA for. I mean, you can do this research, but like the speed of which they're able to do it compared to you is so much faster because they're actually devoting effort to this and they have an unlimited budget. So you can still do research on your own, I suppose, but just thinking that you have a very low chance, I feel like, of outperforming them in terms of your research.
But we
Oh,
don't
but
have
it's not.
to.
It's this is the thing. This is like how they've spent billions of dollars in dark matter, so we can just pop in with the 100K and do better than them because they're looking for something that's retarded and doesn't exist. We can start Aether Enterprises LLC or as a nonprofit. We can then go through scientific grants and funding. Right? We can actually build an entire intricate business plan. And
I
then
still
we
like
can
your
get
idea
funding.
for climate crusaders.
Did you see the rough draft of the proposal I wrote?
What's
No, bro,
Climate
that's
Crusaders?
It's so funny, bro. It includes gender diversity and climate change, so we can get some funding.
Oh, is this a Trojan horse?
Yeah, yeah.
Nice.
It was written tongue in cheek. I'll show you.
Is there any
Definitely.
systemic problems mentioned in this proposal?
No. We think we might know how to discover dark matter, bro. You didn't know?
Oh,
Need to go to Antarctica to do it. Yeah.
and we need a diverse group to go with us.
Well, we've
No,
actually we
we
discovered
need to
that
find
there's
what woman will step up to lead.
Me,
If you
I'm
don't
the
let us
woman for the
finish,
job.
Hey, I'll
Are you
honor
the
my
woman?
ancestors and wear a kilt. Does that count?
Well, you can declare yourself a woman. No one can question it.
I was gonna say, you just say, oh, me, yeah, doesn't matter if you're a boy or girl. Girls have dicks these days, right?
Can somebody I don't know why it's not letting me. Can someone search like from what's it and find it shouldn't I don't post that much and there's this like whole thing. If you could copy and paste it, it's so funny. Let me see if I can find it.
dude, why are you making people do work for you, man? Come on, come on, Austin.
I mean, because I can't find it.
What are you looking for?
It's all good. I'll find it. Okay, here I found it. Don't even worry about it. All right, I'm gonna paste our proposal. Okay, and you guys let me know what you think. I think we're in there. They're never gonna know. Yeah, we don't play around.
You made Chat GPT write you a diversity and inclusion climate journey to Antarctica, didn't you?
Yeah, let me actually read the prompt. This is the
Fluidity.
prompt I gave it. Check this out. This is the prompt. I said, write me a government grant sales pitch for the need of funding for Antarctic research for global warming. We need to check the path of the sun in their summer to approximate the ice caps melting and the angle to the sun's relation to global warming. We also need to take 90-degree zenith angle measurements of the star trails in relation to the southern celestial pole to verify where we are in the annual precession cycle to understand the correlation of that cycle and our cyclical global warming position in the historical timeline. We also need to measure the shadows from the sunlight to verify its position for this purpose. We also need funding for innovative dark matter and dark energy research in Antarctica. The Southern Lights relationship with the Northern Lights shows us the energetic connection of dark energy that was previously assumed to not be present in our solar system. There also seems to be dark matter in the Antarctic regions due to the exotic matter's environmental requirements of extreme cold temperatures, cold dark matter, and the compactness of the material lends credence to the dark matter superfluidity model. So write a compelling business proposal or request for government funding and grants for these fields of research. We also want to explore the new, exciting, and innovative field of gender fluidity and how it applies to the superfluidity of the background comprised primarily of dark matter. Gender diversity, inclusion, and discovery will be aided by our Antarctic discoveries as well. So that's what it wrote me.
Dude, this is the best proposal. Like, I want to contribute to it right now financially.
It left some of the good parts out. You see how we're getting all of the stuff we want to do in Antarctica? It's beautiful. I'll never know.
It's so good.
So how much information did you have to feed the AI to like get
I just
this?
read the prompt. That was the prompt I wrote. So my prompt is pretty.
Yeah.
Wait, your
Yeah.
prompt is a chat GPT, bro. What the
Yeah,
hell?
right. It's a
Damn.
long prompt.
Dude was like, I want
Actually,
to
it kinda
measure the
dropped the ball.
Dude.
I dropped the ball on a couple of the details, but whatever.
Yeah.
It's pretty funny, man. It even gave us look. It gives us the names of the project. It's the Antarctic Research for Global Enlightenment.
That's the best kind of enlightenment.
Bro.
We just
Man.
need 50 mil, bro.
Hey, bro. Hey. I'm trying to be a part of ARG. You know what I'm saying? I'll get you some funding.
I
What does
love
pinning
our
the message
project.
do?
Our project will explore parallels between gender fluidity and the superfluidity of dark matter.
You should hit up Kenneth. See if he'll.
Hey.
See if he'll.
We get
so funny.
to get money and then
Using
actually go do this in
scientific
Antarctica. Bro, imagine just getting read in. Like you would have to get read in on a briefing before like you went there, bro. Like it would just hands down like whoever
Okay,
reads this
I'll
proposal.
temporarily dye my hair blue. I'll throw on the Glober glasses. I'll wear some tight, skinny jeans, bro. They'll never know. They'll never know, man.
You should wear a dress and say you're tired of white men doing all the scientific research.
The dress is where I draw the line, bro.
No, it really sells it though. Like that's what's gonna get you in, dude.
Whatever. I'd rather us just sit in Discord then.
Oh man.
You like how I tied in this gender fluidity with the dark matter superfluidity, bro? Ready with the smoke, bro.
Oh man.
Using
It's funny
scientific
'cause-
metaphors and findings to enrich our understanding of gender fluidity and inclusivity.
I know it's perfect. I could never even type that without throwing up. It's where the
They
AI
have to
says,
give you money with that in there, man.
right at the end.
Parallels between gender fluidity and superfluidity of dark matter.
It's funny because I'm like, oh yeah, we're gonna look into the southern lights and how it applies to the dark energetic input, and then there's promise. The dark matter superfluidity theory is very promising, and Antarctica checks the boxes. We're gonna go find dark matter in the Antarctic ice, bro.
Well, I hope that you have a really successful expedition.
Thank you, man. Anyway, I was bringing this up to say, like all jokes aside, we could actually create a non-profit or even just not for profit, and you can get business funding and government grants, right? For scientific research, and we can just if we actually put our energy into that. There's no telling what you could pull off because there's not many people that are doing like even smart enough to think outside the box. But like really, typically they shut down alternative research and theories by way of not funding those things. But like getting access to an observatory, for example, and looking at what's really going on with the southern stars would be great. Let's see the Sigma Octantis and let's see when, where, and how we see this alleged star, right? So we need access to stuff like that to really get the ball rolling.
You have to pretty much rent time on those, don't you? Isn't that how it works?
Yeah, maybe, I don't know, but it's a good thing the government's going to give us funding because of our gender diversity.
Yeah, well. No, I mean, quite a bit of the time you can just buy the time you want on a lot of these networks.
I mean, what's ironic about the strategy is that that's the next card they are supposed to play against us. So it's kind of the irony is that, you're doing Uno reverse on them. You're using their own card and their own strategy and playbook against them.
Yeah, the idea actually isn't terrible, even though this was like clearly a joke. Like,
Right.
really, it's not a terrible idea to start like being tactical against them.
Sorry, I think it's called co-opting.
Subterfuge.
Brenda will be our spokesman. Or,
That's actually
spokesperson.
perfect.
No.
I'll never know, dude.
Right.
Did y'all already talk about the lost history of ether physics? Did I miss that?
Yep.
Yeah, Alan tore it up.
Send you a link though.
You want to pick it back up from the jump, bro?
Yeah, you hit that reset. All right, let's roll.
Sucks. I always miss you, man. It's like there's something in the ether that like keeps me away until it's almost over or something.
Well, did you see it was the same one I did at Maru, so if you saw that one, you're golden.
I got to see a decent amount of that one.
Nice.
The worst part of the summits for me is that I'm like, I have to miss a lot of them. Yeah.
Oh, yeah.
Yeah. But I did see a good amount. You crushed it.
Thank you.
Oh, is it that same presentation? Then I'm golden. Good. Good.
Yeah, that's freaking. I mean, yeah, dude. I mean, this is. Don't get me wrong, bro. You already had in my opinion, you see the arguments for the motion. We like comparing like laser interferometry no motion implications with, the dark matter and energy problem of relativity is great, even on its own. But then like just learning more about like the etheric implications of it through this kind of stuff, like that's even more powerful paradigm shifting information, I feel like, for a lot of people, because like if there's just this ethereal like matrix we're living in, pretty much like this just grid of superfluid ether everywhere, like that, I feel like that would add even more credence to the view that we try to give people. Like, look, dude, we're living in this electric universe with like, a geocentric Earth. And
I think it depends on the person. Like, depends on the level of thinking someone does. I feel like some people don't give a crap if you tell them about ether. They're not gonna really even get it. They're like, oh, so it's not atoms. It's like this other stuff. It's this fluid. It's not little dots. It's fluid. Okay, whatever. But then people that have like really contemplated it and thought a lot about it, they need to hear the ether part of it as well as the flat Earth part of it, because they need to like understand the full paradigm like switch. They need to understand that basically the whole thing has to be turned on its head, and why the whole thing got turned on, why it all got flipped upside down in the first place, and how the velocity of light is where this whole deception kind of stems from. And we used to actually understand that there was a background medium. It was just kind of like a philosophically sound position to take. So yeah, like I think it depends on the person. Some people, I think especially like just more contemplative people, they need to hear the full paradigm shift.
Yeah, and like I will say, my position is like I don't agree with the exact interpretation of the ether that existed back in the day, right? Like I specifically disagree with. Like I don't think that light permeates ether. right? Like I think that light is the ether.
Yeah.
It doesn't permeate it, you know. And the primary notion back then was that all of this stuff was permeating ether, or that ether was a space filling substance, and that this phenomena permeated through it. I don't agree with that, but that just kind of shows you that they put a pause on it for like a century, right? Where we would be so far ahead if it wasn't for that. Like, and another part of it is what I don't get about, like, say, the baller or whatever. That here's this stuff. How do you not see all of these just like lethal blows to your paradigm that have been swept under the rug? And to this day, there's no one. You can't run to appeal to any authority. You can't find anything that's going to give you an answer to this stuff. Like, how does that not like make you step back and think like, wait a minute? Right, that's the part I don't get, because there's no answer to almost any of this stuff. It was never addressed. It was just ignored. You know what I mean? Like,
Like what
wouldn't you
stuff?
notice that? Like even the Sagnac effect, the inability to truly apply a relativistic solution to the Sagnac effect.
Did you see
Like
the
just
paper that I sent you a couple days ago about exactly that?
no, I have no idea who you are or what you're talking about.
This is Grayson. We met at the MDD convention. I messaged it to you on Telegram.
Okay, you messaged me a relativistic application to the Sagnac effect.
Yeah, yeah. It was published in 2022 in the European Physics Journal. See?
Oh, European Journal of Physics is now legitimate. No, I'm just kidding. Okay, yeah, I'll check it out.
Yeah.
It's funny. It's 2022. When was the Sagnac effect discovered?
Hang on, what's the paper called? Let's look at it right now.
It's a
Please,
quest for
please
the
look.
origin of the Sagnac effect.
A quest for the origin of the Sagnac effect.
I mean, this actually kind of verifies my point that it's a paper from 2022 in a less known publication. According to the ballers, that they just publish anything, because I found the Neo-Tychonian, Newtonian, Machian analysis of planetary motion in that publication, so it could be dismissed. But if it's 2022 and people are just now trying to still propose relativistic interpretations for the Sagnac effect, that something's not adding up. I mean, that's 1935. Or 1925, it was like further verified with MGP, right? So, like, why would it take that long? Shouldn't it be simple? Like, that
Well, I
doesn't even
think
make any sense.
I think it's because, like, historically, the Sagnac effect was like just exclusively attributed to like a rotating frame of reference, but then with Ryu Wong's experiments in the early 2000s showing that it could be just any shape of a closed loop, then that sort of made people start to think about it again, because he was showing like an application of the Sagnac effect in like something that was previously unheard of until then.
Well, it's
Yeah,
even.
there wasn't a relativistic application or solution prior to Wang, though, right? Like that's the truth.
And even still, there's really not, because what they do for the relativistic derivation of it, they invoke a reference frame which allows the observer to watch the speed of light vary and accept it, while denying the validity of the reference frame being inertial. Because the real crux of the issue is that Einstein already defined a closed polygonal loop in uniform rotation as an inertial frame, as if you extend the closed polygonal loop, to infinity, it's basically, traveling linear. So it's, like, he made that clear in his own paper. So that's why Sagnac came along and was like, yo, I showed the ether, the luminiferous ether with a uniformly rotating platform. Because that's it. It was literally in the face falsified relativity on the face of it. It went unanswered until 1917. And then 1918, Paul Lavue stepped in with his by saying that, well, because it's a rotating platform, we have to treat it under general relativity. It's an acceleration, blah blah blah, equivalence principle, yada yada. So they use relativistic effects to say that basically the device is generating little pockets of time dilation, which is
little pockets of time dilation.
Which is just
like, I just got dumber.
I don't know if that's necessarily true. I mean, it was just my understanding that the two counter-propagating light paths, like, one was just traveling a longer distance than the other one, so that it would explain the effect.
No, absolutely. So the classical interpretation, where if you were trying to preserve the speed of light, you could invoke a hypothetical absolute space where you preserve that distance traveled and say that that the total time was increased. Unfortunately, the equations are set to a specific distance, and what Wang showed with his experiment is that only the specific segment in motion actually contributes to the motion with the first order dependence on the length and the velocity, right? So huge problem again right there. Like
I'm just curious, Witsit or anybody, I guess, in the chat, has anybody been able to speak with Wang about his results and how he personally interprets them?
Yeah.
Yeah, they said
So
that.
yeah, so Robert Bennett reached out to him. This is a retired PhD. Saw the results of Wang. He reached out and asked Wang to redo the experiment by and place an additional fiber optic gyro on the conveyor to be pulled to see if that would also detect linear motion. And Wang declined to do that. But the reason he declined to do that is, as we found out, is that the same years that he was doing those experiments in 2003 and 4, he filed for a patent that detects absolute motion off of a background, like basically linear, like you know how they say, oh, in special relativity you can't detect linear motion, but well, nah, this dude patented technology that explicitly detects motion with no external references. It's all based off of interferometry and the fact that the speed of light changes proportionally to the velocity of the observer.
Yeah, this Wayne guy like sounds like he's doing a lot of really interesting kind of work, and I'd be really interested to see if anyone had been able to like have an interview with him or something.
Yeah, no,
he ghost somebody?
he ghosted the guy that called and asked him about that, and then I emailed him about a separate subject, prefacing that I was interested in his satellite paper and stuff, and he hit me back and was like, "Yeah, totally, ask whatever questions you want." So I asked him questions about the significance that he was putting on the ECI reference frame in his paper, and a couple other things like in regards to what it's like in the academic world to be against Einstein, because he's pretty staunchly against it. And he mentions a couple things in his papers about how in mainstream academics, like it's kind of unsettled that the correctness of relativity theory. So I was trying to ask him about some insights on that, and he never replied. Just straight ghosted me as well. Like he won't talk.
because
He won't talk about this. He has a patent. He has patented technology that explicitly falsifies the current understanding of modern physics.
He is in Minnesota, right?
Yes, Minnesota, the University of St. Cloud or whatever.
Okay, I've got some family there. Maybe next time I visit them, I'll see if I can talk to him.
Just call the university and talk to him. That's what Bennett did. His email is on his papers. You can email him. That's where I got
Bennett
his email.
said as soon as it got to the conflict with relativity, everything changed, right? Like, I mean,
oh, sorry. Go ahead. Sorry.
the point is that he's probably he's not going to be like welcome with open arms to propose something so staunchly in opposition to relativistic assumption. So like when someone else hits him up and they start bringing that up, he's just going to be like, all right, I'm just going to step away. Like that's what he did with Bennett. That's what he's going to continue to do, right?
So he won't really like take a firm stance, is what you're saying?
I'm saying I don't think he just wants to deal with the headache of like vocally being opposed to Einstein with specificity, where then people can go and like prop him up and throw him in the center stage so that he has to deal with the pushback of it. I mean, I could be wrong, but it doesn't make any other sense if you read his stuff. He's already done that. He's done that to such an extent that there's really no way around it. Right. And you're saying that you have a paper where someone attempts to explain his
Yeah,
results?
I pulled.
Oh.
I pulled it up here. I already knew the answer, but Toby found the what we were looking for. So yeah, they just invoke another transformation, invoke a position where they can allow the speed of light to vary from your perspective and deny the validity of the variance from where it's actually in the frame that it's actually occurring in, which is contradictory to the fact that so the frequency you could do that with hypothetically with, right? So like in the classic sense where I said you could invoke absolute space to preserve the length, you could definitely do that and say, okay, look, the Doppler shift is proportional to that. Okay, cool, whatever. But there's also a physical fringe that's proportional to that velocity, and that can't happen unless the speed of light varies proportional to that velocity.
Yeah, I just don't think that that's what's going on in this paper, guy.
No, you could read it. Toby just quoted it too. That's what goes on in all of them. They explicitly say that.
Oh, is it in the chat?
Yeah, they explicitly say that in the Tartaglia one too, which is like the other go-to one. They go the classic interpretation is C plus V. It requires no further investigation. Here we'll examine the relativistic derivation of this. And he goes, all right, so here's what we're going to do, boys. We're going to get we're going to invoke a cylinder coordinate system for the rotating device, and while we're at it, we'll give us a cylindrical coordinate system, and we'll place ourselves at the center of that cylindrical coordinate system, and we'll place that over top of the rotating coordinate system so that the axes are aligned, so that we're now at the center of it. So we're watching this rotate from a space. We're watching a non-inertial reference frame from an inertial frame, and therefore we can see. Hold on one second.
I don't think that.
No, this is the complete steelman of what they say is happening. This isn't what I think is happening. This is what they say is happening to justify relativity. So once we're in our hypothetical coordinate system, looking down at the non-inertial frame, that's actually an inertial frame as defined by Einstein in all of logic. We're told that we can examine the speed of light varying, and it's totally fine. It's just an illusion.
Again, that's not what's happening in this paper.
Toby.
I mean, look.
Okay,
Let me just
you know what's, watch how easy it is. You tell us what they say in the paper, then
I'm about to read it. Yeah, I'll read it. We conclude that the origin of the Sagnac delay or the phase difference in Sagnac or Sagnac-like experiments is the non-midpoint measurement of arrival times of counter-propagating waves leading to unequal path lengths traversed by the opposite directed light rays. So like they're just saying that the two light rays are not traveling the same distance, and that's what's resulting in the effect.
Hold on. What?
That's C plus V.
Yeah, what is the measurement for time?
It's because of like the asymmetric position of the observer.
But speed is just distance over time, right? So if you're going to invoke an adjustment to the distance proportional to a speed, you're adjusting the speed.
No, you're not adjusting. It's the same speed going over different distances, and that's why there's a phase delay.
But the distance was actually the same. So what
How
changed?
do you understand this? The distance is actually the same. They have to create a transform, a relativistic transform, as if the distances were different, even though that they are the same.
It's the position of the observer that makes the distances different relative to the observer, which is like the measuring apparatus.
Okay, 1 second. Here's where you're wrong. The measurement is taken on like in the fiber optic gyro frame. So that's where that frame determines like if it's an inertial frame or not, right? So that frame, as defined by Einstein, is an inertial frame, regardless if it's in uniform rotation or if it's in linear motion. It's still either way, falsified on the face of it. I know it sucks, bro. It's mind-boggling that it's like this, that you're like, there must be something we're not getting. It's not. This is the deception that they've done, and there's no answer for it. It can't be done.
By the way, it's going nowhere. We're just going to replicate it. We're just going to continue to do it, and we're just going to put it all over the place, and we're just going to get it in front of millions of people. This isn't just going to disappear because dishonest, disingenuous, relativistic, religious people have swept it under the rug. It's not just going to go away, and you're not just going to be able to like throw some math on it and pretend the opposite of what happened, and then somehow relativity still works.
It's the same thing as NASA. Never a straight answer.
We are going to replicate these tests.
Patented technology. It ain't going nowhere. Someone's making money off of this at some point.
So can you explain to me where the deception is in this sentence in particular? They're saying that in the lab frame, the non-midpoint position of the observer and thereby inequality of the path lengths of the two oppositely directed light rays in the Sagnac experiment is straightforward.
There's no.
That's what they're saying is
there's no
effect.
there's no hypothetical observer in the midpoint reference. It's just the measurement of the device. It's in that frame.
When they say observer in an experiment, they're not always talking about like an actual person. So in this case, the observer.
I realize that. Yeah.
No. In this case, they are invoking an observer in the lab frame to watch it, so that they can say that the non-inertial frame is the justification for it.
I don't believe that's the case.
As if it's changing based on our external observer position.
It's explicitly the case because they won't touch the fact that the inertial position is determined by where the observer is. So where the measurement is being made. It has nothing to do with a guy in the lab watching it.
in this particular case, I don't think that the observer is an actual guy. I think it's just a measuring device. And they're saying that because the measuring device is not in the midpoint of the closed loops of the counterpropagating light paths, because it's not the exact midpoint, then those two light paths are going to be different distances, and that's what's causing the phase shift effect.
What is
How would they
how are
not
you
be the same
invoking how are
distance?
you
They're measured.
I'm sorry, two people were speaking at once. I didn't hear either.
Go ahead, Jesus.
I'm saying, you're saying that are you, let me just clarify. Are you saying the apparatus is different lengths and it's just actually different lengths? Like you reverted to essentially a Lorenz transformation of like a shortening of the arm lengths?
No, he's saying that since the where the measurement is made from is not in the exact midpoint, and the distance relative to the position of that measurement is going to be different.
Right. Well,
Yeah,
it's a
Which
ring
is
laser
that's what
gyro though, because I mean, anywhere within it, it would be able to receive like the same amount of like motion because it's like it's the entire ring laser for all
It,
like a full loop, right? It's a
dude,
closed loop.
and not only that, only the linear segment contributes to it. So it's not even a symmetry issue of the observer. Like it's literally, oh man, that's hilarious. So that's the only other thing that they could try and say. That's great.
Well, it's
Thank you.
it's the linear one, but again, it's a closed loop. It's like there's a looping kind of cyclical nature to that linear movement, and it's just saying that like the position of the observer, the measuring device, is asymmetric with regard to the two different light paths.
Yeah, yeah. And if that mattered, the prediction based off of the length wouldn't give the correct fringe prediction for the velocity. Like it's literally a non-issue. Like that's
it's
not
why are we stepping out of the lab frame to take a measurement? It's just
Well,
insane.
Do you actually not see that you're defending the side that's just desperately grasping at straws?
Yeah, well, hold on a sec. To be clear, he didn't in this particular case. He didn't step outside the lab frame in that regard. He is in the position of the device making the measurement, but he's invoking
Yes.
asymmetry of the frame, which
Thanks,
doesn't
Alan.
matter because it's a closed loop, and it's only contributing to that part. So like if the symmetry mattered in that regard, then like the rest of the length of the loop would be included in that, and the prediction would be off.
I don't understand how you can invoke a lack of symmetry without stepping out of the lab.
Well, no, he's stepping into the perspective of the moving device, specifically in this instance. Like this isn't the Tartaglia thing. It's the inverse of the Tartaglia, but it's the analyzation of it is not applicable because the distance doesn't actually change.
Hey, Witsit, I can resend you this paper on Telegram just so you have it.
Okay. I will say I'll vouch for this guy. I talked to him in person. He's in terms of a baller. He's cool. Like everyone just be cool with him. He's cool. But like I
Thanks,
would
I
say
appreciate
I just want to actually.
it seems obvious that your side is grasping at straws. I mean, it seems kind of obvious.
Hey man, I'd still love to have a conversation with you about like dark energy, dark matter, ether, all this fun stuff.
No, yeah, we'll set it up, bro. We'll set it up.
Cool, man. Whenever you're free.
I don't
But yeah.
understand. I really don't understand. If someone can try and explain this to me.
Yeah,
Yeah.
critical base here. Can I get clarification here? Are you claiming that the actual distance is different? Because I mean, it's
Yeah. Between the two
the
two
literal
counterpropagating light
distance.
paths relative to the observer, the measuring device, is going to have different distances because it's not at the midpoint between those two closed loops.
Midpoint. How are you invoking a midpoint?
Yeah,
The midpoint would be like the point that's equal along those two counterpropagating loops. Like any version of the sonic effect is going to have two counterpropagating light paths.
I understand that, but
a
the
closed
midpoint.
loop, and then the midpoint would be exactly like between them. But because either in the case of rotation or because of linear motion, the observer is going to be off of that midpoint, and that's going to mean that the two light paths are asymmetric, which is going to result
Observer-
in the phase difference.
But no, but the observer moves with the midpoint. It all moves together. It's all one inertial frame.
But it moves asymmetrically compared to the two different light paths.
Well,
How do you invoke a lack of symmetry without? You have to stay in. If you're in the lab frame, how does it become asymmetric?
it's asymmetric with reference to the two different light paths. Like the movement is going to be different relative to one path relative to the other. You know what I mean? Or am I not?
No, because the distance is the same along both paths. You have the same amount of fiber optic, the same length of fiber optic cable going both paths, regardless
why
of
I
whether
asked
you
you,
move
are
them
you
or not.
saying-
The center
That's
point
why I
stays
asked
in
you,
the
are you saying
center.
the literal? Sorry, go ahead, Toby.
Yeah,
No,
but
go
just
ahead.
as a result of either rotation or linear movement or any kind of closed loop movement, those paths relative to the observer are going to be asymmetric.
But the observer's in the inertial frame.
You
I
could
don't know how
literally
that
put the
matters,
observer
honestly.
inside of each of the tubes, like in the center of each tube, if you wanted, and it would. I mean, it doesn't matter where you try to center it, bro.
Dude,
Like, it's
you
in the
could
same reference frame.
you could invoke as much as you want. The symmetry doesn't matter in that frame.
I would just, I mean, it sounded like you guys hadn't read the paper yet, so I would just, I would like to have this conversation maybe after you guys are maybe a little bit more familiar with the paper, so that you can, because it sounds like you're, like the paper is even referencing some of the other explanations that you guys were talking about, and it's shooting them down. So you might be interested in its logic. I mean, I think it's a good read either way.
Yeah, thank you.
No, I mean, I agree. I agree that if no one's read it, then we should read it. And like, to me, and by the way, I will say, like I said, I invoke and obviously it's not even from my paradigm. Newtonian mechanics is actually retarded in my opinion, but I invoke the Neo-Tychonian, Newtonian, Machian analysis of planetary motion, right? And then people are like, oh, that's not a real published paper. It's like, oh, European Journal of Physics, like, oh, that's not that's just
No,
this
no,
offshoot that
I'm not
publishes.
T-Jump. I know it's real. I know
Yeah,
Popov's
I know,
paper
but you
is
get what
real.
I'm saying. Yeah, but you get what I'm saying. And so, like, I will say that it does normally give a chance to things that maybe aren't typically. It'll be one of the publications that'll give more fringe ideas a chance or whatever, even though they end up turning down a second geostatistical paper. I'm saying all that to say that if it's 2022 and we have people still coming out, I mean, that is even since Wing, right? That's many, many years. So this in and of itself, it's validating the point that we're making that's being so often dismissed, that there's a problem here. Whereas the vast majority of these people are saying, like, acting like we're making this up and we just don't know what we're talking about, right? There is actually a problem. So I mean, if this goes through all their other explanations and says what they think what's wrong with them as a hostile witness, and then we can see the best they have, then that's good. That would be like a useful addition, right?
Yeah,
'Cause
I mean, there's definitely stuff that you could use in here. Like, if somebody is saying like we totally know exactly what this is or whatever, you could definitely cite this paper because, they do. Let me see if I can find the exact quote for you. But I think it's just a really good read either way.
So when you're invoking an asymmetric position, like, are you invoking? I don't see how you do it without invoking an absolute frame of some kind. You have to invoke an absolute space.
That is one thing that I wanted to ask y'all about, like your conception of ether, like not just the 19th century conception, but the ether that y'all are talking about. Does it provide an absolute reference frame?
I mean, it's within the absolute reference frame, which is the Earth.
The Earth is the absolute lab frame, reference frame, right? And then, yeah, the ether would be an absolute background, but there's a drift within. The propagation rate's relative to that motion, and the absolute is the lab frame.
Okay, so because to my understanding, the original like 19th century ether was proposed as like providing an absolute frame of reference in the universe.
Yeah. Yep. Because that was the assumption that the Earth is moving through it, right? So, like, you
Yeah.
have the Earth spinning, you have the Earth orbiting, and then you have this idea of a fixed ether. Therefore, you'd be able to measure the fringe shifts relative to that. You didn't get the orbit. You got a fringe shift, just ignored it. Instrumental error. That was like a rap right there, right? So they got rid of that, and they ignored the instrumental error, or they just called it instrumental error. And then we got the rotational prediction with a 98% accuracy, right? With the Sadnik effect, Michelson-Pearson. So then the assumption of the fixed ether can't just sit there. You know, either the Earth's not moving or the ether's not fixed.
So
Right,
there
like,
is.
okay.
Sorry. I was just gonna ask, like, in your conception, then there is still like ether drag or ether wind type effects, right?
Yeah, there's a
Measurably so.
drift. Yeah, there's an ether
Measurably
drift.
so, yeah. Yeah.
And so that's what like Michelson Gale Pearson would be showing in your paradigm.
Yep, and that's why it
And
changes.
Michelson Morley. And
Yeah,
Michael
and
Simorley showed it as well.
and Dayton Miller, yeah, and it changes with altitude, time of day, time of year.
Yuri Gallop, 2001, 2002, altitude.
Oh yeah. That was one thing that you brought up in your debate last week that I was super interested in was the differences in altitude as you go higher.
Well, bro, Einstein himself admitted.
This dude cut out.
Oh yeah, he lagged
Yeah.
out. I thought I lagged
He
out for a
admitted
second.
if Dayton, he's going to say if Dayton Miller's results are correct, then his theory collapses. Chris, you cut out. You cut out. You might want to leave and come back.
I can't hear shit, man. Sorry.
It's all good.
I moved him to hot mic. He'll come back, but that's what he's saying is that he admitted if those findings are correct, then I mean, if there's not a fundamental error or instrumental error and Dayton Miller's findings are correct, experiment reigns supreme, and that his theory has to go. I mean, it's been replicated with extreme precision at this point.
Yeah, bro. Were you in here earlier when we were talking about this stuff, Critical?
No,
Did you?
I got here kind of late. Sorry.
Oh, so you probably missed the bulk of the presentation itself, dude.
Oh, I
That's
did. Yeah.
So that's like what we've been talking about this whole time. So you came in at the end without actually having seen all that stuff. Okay, that
Yeah.
makes sense
Yeah.
now. That totally makes sense now.
But he was still just saying, like, look, he was saying to me, like, I sent you the paper that they claimed to explain the static effect. He jumped in the conversation. We were talking about how the static effect is.
Yeah, this is
problem with them-
specifically a reply to Wang too. Yeah, continue. Sorry, what's it?
Well, and I was making the point that, like, I don't get how people can see that something as fundamental as the static effect doesn't even have proper relativistic solution all these years later. And it's been kind of swept under the rug like that. How does someone just look past that? Like, how does that not click in their mind? That was the context, right? Where, like, it's obvious that there is something wrong. If major tests have been done and just ignored, I mean, something's not adding up, right?
Right, for sure.
Hey, sorry. Am I coming in clear now?
Yes, sir.
Yep.
Yeah, sorry about that, guys. Hey, what I was gonna say to you,
Critical base theory. If you'd
base
like to
theory.
review what we're going over earlier, the Roundtable 11 on Alan's Space Audits channel is really good.
Like, is channel on here or on YouTube or
YouTube.
Oh, okay.
Yeah, Space
Sure.
Audits. I can throw you a link if you'd like.
Yeah, that sounds good. And y'all can call me Grayson. That's my name.
All right, Chris, go ahead, brother.
Yeah, sorry about that, guys. Hey, no, I was just gonna say, like, I don't know if you guys already covered this while I was out and trying to reconnect, but like in terms of like you were saying like what's the view of the ether or whatever, like Einstein himself, you can pull up quotes of him saying if we could confirm Miller's experiments were not the result of something, say, like due to instrumental error, that it would be the end of relativity right there and confirm the ether. So, I mean, and if you look at Miller's work as his finding, I mean, you can see
Euler.
I mean, it's basically inarguable at this point. If you just go over his findings, that they were not due to instrumental error. He was measuring the ether wind and its maximum and minimum dimensions directly correlated to the equinoxes, right, in sidereal time. So right there, I mean, if you want confirmation that the ether is not static,
Alan, are we about
and
to
that
read
Earth
it?
is stationary, there you
Are
go.
you about to read it or whatever?
You're talking about Dayton Miller's work?
In Miller's work, yeah.
Okay.
Yeah, and I can link you. I can link you to some papers. I could drop some papers in the chat for you to go over that. But in terms of like,
That'd be
just
really
to
cool.
yeah, for sure. I'll
I'm
drop some
for
here in a
some
second.
reason I'm not seeing anything in the chat. Like, did you guys just see that message I said hey, or am I just in the wrong chat or something?
I think you're in the wrong chat. Are you on?
Oh yeah, you're in the one for the voice chat. Most people
Oh,
hear
okay.
you
I
live
see it
stream
all
one
now. I see it all
text.
now.
Yeah.
Cool.
Yo, and critical base theory, just FYI, I had like a pretty contentious debate about Wang's paper like 2 days ago. So
Ooh.
Sorry if I jumped on you there a little bit.
No, dude, it's all good. Where can I watch that debate? That sounds really interesting.
Let me pull it up. I can link it here.
Yeah, you get them.
Yeah. And I also just want to say that you guys are the best Discord flat Earth server that I've come across. Like, you can actually have like a higher level discussion here without getting like muted or shouted at or insulted. So I just appreciate the conversation going on.
A lot of good Christian people here, bro.
Watch it, bud. You're gonna get muted if you keep that up, okay?
Okay, sorry.
Just play it.
Hi, welcome.
Sweet. Yeah, I'll definitely be watching that debate then. This is
Well,
I mean, I'm super interested in these topics.
Funnily, he didn't bring this paper up, which is kind of funny. He just
It's kind of
referenced-
newer, you know, it just came out last year.
He referenced Tartaglia's direct, like what's it called, Sagnac effect in pure geometry, which is kind of just a relativistic explanation for the Sagnac effect, which this paper actually refers back to, or the paper you provided refers back to. So it's kind of, yeah, it's interesting.
To my knowledge, it's the most recent addition to this whole discourse in published literature.
I just find it interesting that after all this time, they really did like, yeah, we're just going to invoke a reference frame where it's like, not, it's like a, it's basically a custom reference frame just for like purposes of invalidation of this experiment.
I don't know if I would really agree with that characterization of it. I mean, the reference frame is the reference frame of the observer, which seems kind of crucial to any measurement, right?
Yeah, and even without symmetry in the frame, the accurate measurement is predicted and derived.
In which paper?
Wang.
Yeah. Man, I really want to talk to Wang.
Hit him up.
Did you see all the circuit diagrams that he built showing like 30 something different ways where relativity would be disproven if you could make a circuit like this, which would function like the same as the other circuits?
No, I haven't.
Oh, dude, he goes in on it. Like, how many pages are there? Were like 3 pages or 4 pages of those circuits? Like, there were a ton of.
Bunch of different configs he came up with to try and satisfy this. But then you start
Yeah.
getting into like atomic clock sync issues.
With vacuum tubes and then like just all this other stuff.
Here we go. Which to me, it's funny. It's like he did the 2004 paper. He got a patent made on that, and then here he is. Like this was like 17 years later, 16 years later, or something like that. He's like, here's a bunch of other ways you could do this. I think he was definitely knew that he had found something special.
It's just weird that if he thought that he had found something so special that he would like, I don't know, be so subtle about it. I mean, you'd think that he would be more broadcasting of his conclusions.
Not necessarily, because when 2003, he showed it was linearized, and then he files his patent for a speedometer, an interferometer-based speedometer, which is like crazy conceptually to me. And then that same year, he gets like a multi-million-dollar fiber optic gyro from the Navy and a bunch of like air core and glass core fiber to do more experiments. So to me, that's just kind of obviously he's, there was military interest once the patent was and so that's why he wouldn't be talking about it.
He's on the team.
Other than his papers he's published to show how you could test it.
Right. I mean, he probably sold like material usage rights of that patent to the military and like it's sitting on it, but he had to sign an NDA for the contractual deal to sell it. So that's probably, he just doesn't want to talk about it, I think.
Hey, have you seen his patent? Critical?
No,
can we pull
actually,
it back
I've
up?
just seen I've just seen his like papers from like the mid to early 2000s. I haven't seen his patent.
Pretty cool. It's a speedometer based on interferometers. I'll tag you and bump it here.
See, this is just making me want to talk to this guy more.
Right, right. But I think I think it's true. He's got some kind of NDA, is my guess.
Oh yeah, here it is. Man, interferometry is super interesting. I'm trying to go visit LIGO in Louisiana next month.
Nice.
But before you do, maybe watch Alan's most recent. He's got a short video where he clipped out a discussion of him and the boys talking about what the data, the filtering process, the data from LIGO goes through before it reaches our ears. But definitely worth listening to if you're interested in LIGO at all.
Okay, yeah. I mean, Alan seems to be putting out a lot of videos that I'm interested in and having debates on it. I also I also have a YouTube channel where I do debates and stuff, but so maybe I'll have to talk to Alan
Yeah.
at some point.
That'd be awesome.
Dude, hit me up.
Because I try not to be as what how should I put it? Uh rude or obnoxious as a lot as a lot of debaters out there, but
Yeah,
like I
I
try
try
to
to do the
actually
same.
engage. I try to actually like engage with the substance of things.
Although I've really only
Were
done
you
it
in here?
once.
You just got a sub, my man.
Were you in here for the discussion of the technology built into GPS tracking and motion systems?
Nah, dude, I got here extra late. Y'all were talking about um man, I don't even remember, but it was past the entire Ether presentation.
Okay, that was I mean, that's the whole crux of all this, bro. They use basically an etheric reference frame for satellite motion because of the difference in the drift of the ether in one, a preferred direction, and two, the altitude variation of that drift. They include that math into the GPS calculations. It's nuts,
Is this
bro.
from that guy? What is his name? Hat?
What was it? What was his name?
I thought his last name was Hatch, but I've heard like a bunch of
Oh, Ron Hatch. Ron
Ron
Hatch
Hatch.
definitely
Yeah.
wrote a book about it. Yeah, but there's other papers on it too.
Okay. As long as there's something that can be corroborated independently of Ron Hatch, then I'll be happy. I just don't want to find something like because a lot of the times when I hear stuff about GPS, it's like the only source is Ron Hatch, and I just want just another independently verifiable source
Well,
besides him.
it just so happens if this person chooses to reveal their identity, there is a member in the audience who worked with Ron Hatch who may or may not be able to substantiate some of that. That's all I'm gonna say. If they want to chime in, the floor is yours. Sorry, continue.
Yeah, but I'm not like I don't know. I'm definitely I really am interested in the science and the physics, but I will be the first to admit that the engineering and like the GPS technology is not my I'm not the most knowledgeable on, but I'm always interested to learn. I mean, part of the reasons I love debating this topic is because you end up learning so many things about so many different areas of science and technology.
Yeah, I
Well,
mean,
in terms of laser interferometry, you seem like you kind of know a little bit about what's up with that. You are
Yeah.
aware that the entire theory of relativity was proposed due to laser interferometry. I mean, that was literally a laser interferometry experiment was the basis for why we have relativity in the first place, right?
I would probably say partly. I wouldn't say entirely, but it was definitely a huge factor. Like explaining Michelson-Morley and like using like Lorentz's math, like that was a huge influence on Einstein for sure.
As an electrical engineer myself, the biggest thing to understand with all this stuff, for me, is you have to understand that capacitors, resistors, and basically all the different parts that machines use, right? Have things what we call thresholds, and no part is really like the same. So like you can, like me personally, like I can build 2 frequency generators as an example, right? I can do all the math, build it, and then after I've built it and I'm trying to detect like what am I producing, right? Like I'm doing my waveform analysis and my oscilloscopes, checking everything that I've built, right? Even though I've used the same parts, same batch numbers, and whatnot, and built the machine to the closest that I possibly can do as a human, um, I do notice that there's still discrepancies. Like the field emission that I'll produce is just slightly, off. Like not per to the same hertz. Sure, like I can get a whole hertz pretty easy, right? But when we're talking like down to microhertz or picohertz, different things like that, that's when it can start getting much more difficult to be precise. And when you're talking interferometry, which I haven't really built one of those yet, but I definitely want to do that. That's where it's going to get extremely precise. So, like, I would like to see people build 2 copies of these things. You know what I mean? And then look at the results and see is there discrepancies. And
Wouldn't
is that something that was
sorry.
done? Like when these people made these interferometers, were they building double copies of their machine and running like redundant, experiments?
Isn't that sort of the idea behind LIGO? Is that there's 2 identical observatories, one in Washington, one in Louisiana, and whenever they
Right.
both pick up a signal, then that's like wasn't that kind of built into the whole setup?
Yeah, not sure in terms of what they did there. I'm just
I
going
mean,
by my own work, whatnot, and I'm not too
I'm not sure if they're I don't know. I'd have to do more research to figure out if they're exactly identical, but my understanding of LIGO was that they had 2 separate laser interferometers far distance apart, and then when they both detect the same signal, then that's how they knew it was real.
right.
But yeah, I agree. There's always going to be like a margin of error whenever you're doing any kind of measurement or apparatus.
Yeah, for his tests, for the original test, it was like 1/100,000th of a wavelength of light, something like that.
That's pretty damn good.
Pretty precise, yeah.
Can I'm gonna have to dip out of here soon, but can I ask just a quick question before I go? I just want to gauge if you guys have heard. Actually, Daryl's in this chat, so I know he's heard me talk about this before. But specifically in terms of dark matter, because I know you all have probably heard the rationale behind like spiral galaxy rotations or maybe like the bullet cluster or something. But have you heard the argument from the power spectrum of the cosmic microwave background?
Let's see here. No, tell me more.
Um, so that like I'm sure that most people have heard like the cosmic microwave background being brought up as evidence, but specifically what I find to be the strongest evidence for the current model, like the lambda CDM model for cosmology, is the power spectrum of that microwave background. So the power spectrum is where you are basically graphing the temperature fluctuations on like the y-axis is kind of the intensity of the fluctuation, and then on the x-axis is so if you guys know how like a Fourier transform works mathematically, where like you take like a really complicated signal and you break it down into its component like sine waves, it's
I'm not
like
super
spherical
familiar.
harmonic.
What's your level of comfort with Fourier transforming? Because I'm looking for a Fourier guy.
I mean, I've done them like in my quantum mechanics course or whatever I took in an undergrad. I've like used Fourier transforms before, but I mean,
Awesome.
like I'm not using them on.
That's cool.
I'm not using them on the day to day.
Is Discord a good way to contact you?
Yeah, absolutely.
Okay, cool. I sent you a friend request. I got some Fourier
Okay, yeah.
questions for you. I don't have them all prepared or whatever, but it's a side thing I'm looking
Sure.
into with a buddy. Definitely super interesting. Yeah, are you
Yeah, sounds
familiar with
good.
I think it's called like something crystal photography or something crystal photography, where basically you can take refracted images from light signals basically and like reproduce an image with the Fourier transform. Are you kind of familiar with that? You seen it?
No, but that does sound super interesting, and maybe I don't know if they do that at gravitational lensing or not, but I know that they do reconstruct images through gravitational lensing. I just don't know the methodology. But no, that sounds super
Oh,
interesting.
really?
My
Dude, you have to
my
tell me more about that.
my point was just that so Fourier transforms don't really work on spherical coordinates. So like something like the cosmic microwave background that's in every single direction that we look.
Uh-huh.
You have to do spherical harmonics instead of a Fourier transform. And so like the x-axis is basically like the analog to the different like sine waves. There's like different wave numbers for the spherical harmonics. But whenever you chart that, the the power spectrum for it was predicted in the 1970s. I think actually in the year 1970. And then we were not able to measure it until like maybe like the 90s or the 2000s, or the most recent measurement was with the Planck satellite in 2013. But the the power spectrum was what was predicted. Um which I find to be the most compelling evidence that the Big Bang happened, because when you look at how they predicted what the power spectrum should be, like the built-in assumptions are like the Big Bang, inflation, cold dark matter, like those are like there are only like I think 5 or 6 free parameters for something that has like thousands of degrees of freedom if you were just trying to make any function that'll fit it. So I find that to be the most compelling evidence, and I never hear anybody talking about it. I've been trying to talk with Daryl about it, but he he doesn't want to right now. But yeah, I just love. I mean, the power spectrum is one of my favorite bits of evidence, and nobody ever talks about it, I find. So I just wanted to hear if you guys had ever even heard anyone bring it up.
Yeah, so the cosmic microwave background, the the axis of evil or whatever, right? You're talking about. So it
So
that
yeah,
back.
uh,
Go ahead.
so if I could just that actually ties in really closely to what we're talking about, like the axis of evil and the cosmic microwave background, because that axis of evil only really shows up in two of the different multipodes. So like the multipodes are that's what you get whenever you do a spherical harmonics analysis of it. Where I was saying like that's what's plotted on the x-axis in the power spectrum. And so like the different L values are like the different wave numbers for the different multipodes. So I don't know if I'm doing a bad job of explaining this or not. I'm trying to be clear, but the axis of evil only shows up in the lowest two L values. So like L equals 1, L equals 2. They're called the octopole and the quadrupole. And that those are so it's only in the very lower values of L that this axis of evil shows up. Whenever you get to higher values, which are like kind of like looking at the image with finer detail, you no longer see the axis of evil. So there is some question about whether or not it actually exists, because the sample size is going to be different for their different values of L, because your sample size is like equal to 2L plus 1. So the higher value of L, the higher your sample size, the more confident you are in that data. And the axis of evil literally only shows up in the two lowest values of L and is the strongest in the absolute lowest value of L, where like you know the sample size is the lowest.
Oh no, I did
What
not.
is
I
what is
didn't know
Al
that.
exactly?
L is like it's the multipode number basically. It's basically or like the wave number. Commonly, it's sort of like I'm trying to figure out a good way to explain this. It's related to spherical harmonics, which is the spherical version of a Fourier transform.
Here you go.
So like it's
Does this
basically the
image help
most.
you? Hold on one second.
Let me look in the. I wasn't looking in the chat. Hold on.
The two lowest ones are the dipole and the quadrupole, and it does turn up in the higher ones as well.
Let me look up. Wait, let me look up a picture that I can maybe illustrate this with. Could the guy that just talked repeat? Because I didn't quite hear what he was saying and it sounded
Yeah,
interesting.
my audio is stuff. It's Daryl here.
Oh,
It's
okay.
Daryl.
Hey, Daryl.
It does turn up in the dipole and the quadrupole, which is the two lowest poles, and it does turn up in the higher ones as well.
I think that the quadrupole is the lowest one, if I'm remembering correctly. I don't know if there is a dipole, but to my understanding, it was only in the lowest two and not in the higher multipoles.
Yeah, the lowest two. If you're right, and it's the lowest two. The lowest two are the dipole. That's the lowest one, and the next one up is the quadrupole.
To my understanding, the quadrupole is the lowest one, but okay.
Yeah, there's a
No, it's
dipole,
dipole.
quadrupole. Like, there's all kinds of
Yep.
poles.
Yeah.
Oh,
it's
okay. Here
dipole.
you go. Yeah, here's a picture, and it's showing it in the dipole. So yeah, there you go. Let me. Oh yeah, so Alan already put that in the. Yeah. So there's some different examples of. The one I posted is labeled the dipole, the quadrupole, the octopole. So. But yeah, you can kind of see that it's sort of like the resolution is getting more and more finely detailed as you go up in L values. And the power spectrum is basically a plot that has the L values on the x-axis. So you're looking at the strength of the different fluctuations in each wave number, like in each multipole of L. So the shape of the power spectrum was predicted by basically having you basically are showing like the acoustic oscillations in plasma as the two bounds are t equals 0 and t equals 380,000 years. And then when you have those bounds, those temporal bounds to those waves, then right at that cutoff point, which is when the CMB was theoretically formed, right at that cutoff point, you only have certain like wavelengths that are at maximum and certain ones that are minimum. And so that pattern that was predicted is what was predicted in the 70s and then was observed and verified decades later with like the Planck and WMAP data.
And the problem is that you want it to go away, and you think it might not be real. Is that if it is real, there's no reason why it isn't. What are the implications of that? Do you know, Base? There's three options if that's real.
So I'm not exactly sure what three options you're hinting at. I know that Lawrence Krauss has a famous quote as saying that if it is real, then that means that we're at the center of the universe. So maybe that's one of the options that you're talking
That's one
about.
of the options, yes.
I don't know exactly what Lawrence Krauss's logic was, but I mean he is a professional physicist, so whatever.
The logic is that it makes the Earth the preferred field of view, and it puts the Earth in the center of the universe.
I don't know how it puts it at the center of the universe. That's what I don't understand, but I'm sure I don't know. Maybe Lawrence Krauss has a lab.
Basically, there should be no preferred direction, right? But
Yeah.
but there is a preferred direction based on the observer position of the Earth.
And
So
the solar
my
system is
understanding
elliptic plane.
my understanding was that like saying that there should be no preferred direction kind of depends on what model of inflation that you have, and that there are models of inflation that do have some sort of axis to the CMB. So to my understanding, it like there can be different cosmological models that could give a preferred direction, but it would I would agree that it would be a different model than what is currently used in like
I mean,
consensus.
there's no way you got nowhere to go from there, right? Like it's supposed to be homogeneous and isotropic, and so for it to be inhomogeneous and anisotropic doesn't work I mean, because now you have
Yeah,
the
I've got
issue
a
of
paper on that too.
because you say,
The
oh, there's a
theory.
you say there's a singularity, right? But there's no preferred direction, there's no center, blah blah blah. Now you have anisotropic distribution, but it's even worse than that. It actually directly correlates with that 23.4 degree alleged tilt of the Earth beyond the local system, meaning that there's an anisotropic distribution of temperature and energy far out beyond the local area, directly intersecting on the Earth. So not only should there not be a preferred direction, the preferred direction far away from here intersects with our observer position.
So, Witsit, why, if you're saying that all that is real, I'm just curious, why would it only show up in the lower multipoles? Why wouldn't it be in every multipole?
It does show up.
Yeah, did you see the picture I posted? There was one in the octo
It
poll
does
that you were
show
talking
up.
about.
It shows up in all poles.
Yeah,
That's just not my understanding of it. So, I mean,
Yeah, I don't
if
know.
I'm wrong, I'll admit to being wrong, but I would just like to see a source, I guess.
Let me read
The
this. Let me read this
op-
quote for the
the
room
op-
here. Dr. Tegmark, MIT professor of physics. Right. So not just some random dude by any stretch. He said, we found something very bizarre. There is something extra so far unexplained structure in the SMB. We had expected that the microwave background would be truly isotropic with no preferred direction in space, but that may not be the case. The octopole and quadrupole components are arranged in a straight line across the sky along a kind of cosmic equator. That's weird. We don't think this is due to foreground contamination. It could be telling us something about the shape of space on the largest scales. We did not expect this, and we cannot yet explain it.
So, it sounds like it is only in the octopole and quadrupole components.
Now look at that picture. It's in the
Yeah,
dipole.
look in the chat.
Yeah.
I mean, I'm seeing it in the. I mean, I posted that picture in the chat. I just like, I'm not sure if I'm really seeing it aligned super
You're
good in
posting
the
your own
octopole.
evidence.
Okay, look, now I'm going to post another quote here from Amazawa. I can't pronounce his name, but who cares? So, this is University of Michigan, and this specifically addresses the dipole. Wait for it. Sorry.
Yeah,
Here
because
it is.
I had only heard kind of what Tegmark is talking about, where it's in the octopole and the quadrupole only.
So, in the Friedman universe, one possible interpretation of the coordinates is that the whole space is on the surface of an expanding balloon and has no center. But in such a universe, there is no cosmic microwave background dipole, even in the presence of a peculiar velocity. In other words, the observation of a CMB dipole excludes such an interpretation of the coordinates for the Friedman universe. And that's the CMB dipole in the existence of a Center for Expansion of the Universe, Michigan Center for Theoretical Physics, University of Michigan.
Okay, well, I'll read that. Sounds interesting. But yeah, I didn't even know that there was a dipole in the CMB. I thought that the lowest was the quadrupole.
No, and like the really like crude layman way to say this is, again, it should be homogeneous and isotropic, meaning smooth, evenly distributed, right? Evenly distributed and with no preferred direction. But it's inhomogeneous and anisotropic. It is, for the most part, somewhat homogeneous, but the homogeneity is not like consistent throughout. So it should be smooth, but there are areas that are bumpy. And just so happens that those bumpy areas intersect on the Earth, giving it a preferred direction relative to our observer position. And there's no logical reason for that at all. If there was anything that would show like lack of homogeneity, it should have been completely random, right?
My question, I guess, was just why was it? Because it still seems like, I mean, unless somebody provides a source, it still seems like it's pretty much just in the quadrupole and octopole. At least that's what Tegmark seems to be talking about. So, like, why isn't this axis of evil showing up in higher multipoles?
Look up the chat and look at what was it Alan posted.
It's in the
It's
chat,
the
bro. Like,
dipole.
Again, that was still the octopole and quadrupole. I don't
No, that's the
understand.
there's a
dipole.
picture with all three, bro.
That's the dipole.
There's a picture. It's here. Let me reference it and tag you in it.
I see that it says dipole. I mean, I posted that
dipole.
picture before Alan posted it. I mean, I clearly see it.
Okay.
But
I mean,
again, that's a lower value of L. Like a dipole would be a lower value of L. So I'm asking for higher than octopole values. I'm asking for a higher multipole than the octopole.
You think about it as a harmonic. That's what you can do. You got the primary signal, you got the first harmonic, second harmonic,
Yeah.
whatever. A
That's
dipole
true.
is the second harmonic.
I know. I'm asking for
data
a
set.
higher multipole than the octopole. Why is it only in the lowest values that, again, every value of L has a corresponding number of M values, 2L plus 1. That's your sample size for your measurement. So why is it that this effect only shows up when we have very low sample sizes at the lower multiples?
I've got a question for you, Base. You just mentioned the M values. Have you got the paper? Have you got access to the paper?
The paper from 1970?
Oh, yeah, I don't know which paper it was. The one that's proposing this.
Sure, yeah, I could link that.
I'm
have a
dropping
look
some
at-
pretty damning quotes in here for anyone
Have
that
a
wants
look
to
at
read.
have a look at the paper and see where it says that they chose M values, based on the idea of a multiverse.
Well, I never mentioned multiverse at all. I was talking about
No, that
multipoles,
is-
but all
No,
the
the
language
paper
I'm
does.
using has nothing to do with like this
The paper
topic in
does.
specific. This is all just basics of spherical harmonics, like L values, M values, multipoles. All that stuff is just like basic like spherical harmonics. It has nothing to do with.
I'm talking about what the paper says.
Uh-huh.
When they chose
Yeah, well, you were
the
asking me
M
about
values,
the M values.
when they chose the M values, they used the principle of multiverse for it.
No. I think that I don't know what you're talking about, but we're not talking about the same thing if you're bringing in multiverses.
Well, you look at the paper. I'm not saying anything that's not in the paper.
All right, I'll go to the paper and I'll do a search for multiverse and see if it's in there.
Dude, these are I forgot how damning some of these quotes are here.
You're posting a lot of them. I'll have to go back and read through them.
Yeah, I don't care. I'm posting them for the room, but I just pulled up my geocentric presentation. And did you ever watch that video?
What is the name?
It's called Geocentrism on YouTube.
Anybody ever? Oh, sorry. Go
I'll
ahead.
post
Sorry.
it. That's all good. I'll post it.
No, I haven't seen that one in particular, but I have done a debate with Robert Sanchanis. The only debate I've ever seen him rage quit.
So, did you see the Wang patent yet? Did you look at that?
Yeah, I did look at it.
Did you see the circuit diagrams?
Mm-hmm.
Yeah, go spend some time like looking at all. I mean, it's just he has so many, bro.
I've got it open in the background for after this combo.
Yo, I posted it with it.
Thank you. So yeah, we can look at a couple of these quotes because they're pretty damning. Like, let's look at this last one here. I mean, these are like very revered people, right? Additionally, we must take seriously the idea that the acceleration apparently indicated by supernova data could be due to large-scale inhomogeneity with no dark energy. Observational tests of the latter possibility are as important as pursuing the dark energy or exotic physics option in a homogeneous universe. Theoretical prejudices as to the universe's geometry and our place in it must bow to such observational tests. Precisely because of the foundational nature of the Copernican principle for standard cosmology, we need to fully check this foundation. And one must emphasize here that standard CMB I hate that word. But
Anisotropy?
yeah, studies do not prove the Copernican principle. They assume it at the start. The reason that that's relevant is because we're seeing a pattern here, right? Like it's not just the CMB data. According to the standard concordance model of cosmology, over 95% of the energy content of the universe is extraordinary dark matter or dark energy, whose existence has been inferred from the failure of the standard model of particle physics plus general relativity to describe the behavior of astrophysical systems larger than a stellar cluster. So whenever we tell people that the model doesn't work and they run around saying it does, they're just wrong, right? while the very homogeneity and isotropy and inhomogeneity. What's going on here?
ACD.
Almost done. So while the very homogeneity and isotropy and inhomogeneity of the universe owe to the influence of an inflation field whose particle physics identity is completely mysterious even after 3 decades of theorizing, testing the cosmological principle should be one of the key goals of modern observational cosmology. Now, the reason I bring that up is this is not these aren't even recent quotes. I mean, these are, 10, 15 years old, and it still hasn't been done. So like these are lifelong astrophysicists saying like, okay, we have this reoccurring theme here. We need to step back and actually reconsider the base assumptions of the Copernican principle. And to this day, that's not even on the table. People aren't doing that. I mean, and in fact, when we bring it up to people, we're gaslit. It seems obvious to me that it's not working out, man. It's not something is special about this observer position, yeah.
So one of
Yeah.
the cosmologists at my local university kind of does work kind of similar to this in terms of like he's very interested in cosmological tests of dark energy and general relativity. So I think I'm gonna ask him about some of these quotes and get his thoughts on them.
Yeah, critical
very cool.
base. Also, just to kind of add to what Wizzy was saying, like you had said that you didn't understand why Lawrence Krauss said that it made it look like we were in the center of the universe, but that's not like, bro. Lawrence Krauss didn't call it the axis of evil. You know what I mean?
I know.
He's just that's literally what the only logical conclusion of the data is, that we're at the center of the known universe, and that's why it's called the axis of evil, and that's why we can pull up all these damning quotes. So Lawrence Krauss has nothing to do with it. He's just a guy commenting on what everybody logically is seeing as the issue.
And it's simple. It's like when you look out at the universe, the idea is that the Earth does not occupy a special or unique position. It is a random position. So when I look out and I see this energy distribution, right, it should be smoothly distributed, right? I mean, in fact, it has to be because we have the horizon problem, right? So we have the flatness and horizon problems of modern cosmology. The horizon problem being that if you take the 13.5 billion year time period that you have, you use the universal speed limit of light, meaning no information can go faster than that. You have a maximum distance that any particle could have traveled. But for this homogeneous distribution, the particles would have had to be interacting, right? But they're far away from each other. They're far beyond the horizon they could have traveled in that time. So then they had to introduce the inflation theory.
Yep.
Okay, so now we have the inflation theory. We have to have like homogeneous distribution coming out from that insanely high magnitude of expansion, basically. The
Yep.
output of expansion was insane. So we have to have homogeneous. So we should just see this evenly distributed temperature and energy, and it shouldn't even care at all where the Earth is, right? And it's creating this illusion that we're in the center, blah, blah, blah. We didn't see that, and that's one mark against the idea. It should have been homogeneous, but it was mostly homogeneous in the area that was not homogeneous, and it showed a preferred direction that intersected on the Earth. The statistical odds of it are insane. Like it's not even, it isn't something that can be explained, right? Like the only option is that the readings are wrong. Either the
That's what I
data is
was asking.
wrong. Yeah.
Sorry,
all I'm
I do agree that like that was a good rundown of like the horizon problem, how inflation was proposed to solve the horizon problem. Like I agree with all that. I just was asking like when in terms of whether or not the axis of evil is a real thing or is an artifact of like the data processing. That's what I was asking about. Why is it that it only seems to show up in the lower multipoles, like the lowest
Well,
multipole?
it shows up in all of them, and this is the problem that you can't map away.
I know that you keep saying that it shows up in all of them, but like,
Well, you got the picture in the, you can see it yourself. You can see
but
it
the
in the dipole.
picture was only for the lowest ones.
No,
That's what I keep
it-
saying. Like the picture that people keep posting is the dipole, the quadrupole, and the octopole, which are the 3 lowest multipoles allowable. So
And it's
can
in all of
anybody
them.
show me a picture of this axis of evil that is present in higher multipoles.
Wait, ask your question again.
I
Like,
thought you said originally
my
that it was
understanding, and with that Tegmark quote that you had, was that the axis of evil primarily only shows up in the octopole and the quadrupole. And so I was asking, is there any evidence that this axis of evil is present in higher multipoles above the octopole? So, like the octopole, I think is an L value of 3, and the quadrupole is an L value of 2. So, like, is there any? Because there's like literally the L values goes up to like several thousand. So, like, is there
Well,
any higher multipole where
well,
we can
you've got
still
to
see
think
the axis?
Well, I mean,
octopole.
doesn't it clearly show the axis? So you're saying the image
Yeah,
is wrong, where it shows the axis drawn to the dipole there, because
But the
octopole is
dipole
8.
is still that's like a super low L value. I'm just asking, is this axis still present in higher L values, higher multiples?
Are you getting something confused? The dipole is 2. The quadrupole is 4. The octopole is 8. So you're saying, is it in 16 and 32?
Yeah,
let me
yeah,
show
that's
the.
what I'm asking. So
Well,
like
that's
this
not
is
the L
This is
value.
the real death blow to it, bro, is that it's in line with the plane of the assumed solar system. Okay, so you have the ecliptic plane that's
I
supposedly
get that.
based on the tilt of the Earth.
Regardless of the poles.
That should only be locally observed. It's not. It's
No, I
observed
get that.
far beyond the. There is no answer for that. There's no way in the world that we should see that 23.4 degree tilt far beyond our local system.
I get that. I'm just asking because, like, in terms of how, like, spherical harmonics works, like, the sample size for each of these is the number of M values corresponding to each L, and that is 2L plus 1. So, like, these lower L values have much lower sample size, and so, like, once you get higher L values, you have a much higher sample size and a much more reliable picture. So, like, why is it that this axis of evil effect is only showing up in those lowest values of L?
Like, if you want to send me some stuff that says that it's only observable when there's more sparse data, I'll happily look at it.
Okay, that Tegmark
But
quote.
that does boil. It boils down to the answer of the data must be wrong, and implicitly that's a concession that if the data is not wrong, which, mind you, when they first got the data, they said must be wrong. Let's do it again. You know, they got the data again, must be wrong. Got the data again, and they're saying it again, right? And so, I think that everyone can at least come to the agreement that if the data is not wrong, it's a very serious problem for modern cosmology at the very foundation of the.
And by the way, this data was collected by a $1 billion WMAP satellite.
After they literally they got the first results and they were like, whoa, this must be wrong, right? Like, I mean, every time they got it, they didn't want to accept it for what it is. So now the newest argument is just that it is still wrong. Like, so, okay, well then go do it again. Like, go do it and show us that it's not showing the Earth as a preferred direction.
They do it more accurately and it's more wrong.
And you can even do this with high altitude balloons. Which
It's
is
the
less
problem
frequent.
unless you're a theist. If you're a theist,
I
you can
guess
say
I
that
was
God
just
didn't-
asking
No,
why
it's a
it's
problem if you're a heliocentrist, because the 23.4 degree tilt can only be observed on the local system. If the reason we see the 23.4 degree tilted ecliptic plane of the sun is because the Earth is actually tilted, right? If the reason that we see the angle is because it's the Earth tilted, then that's only going to affect your observations on the immediately local region, right? You're not going to see far beyond our solar system out into deep space and see that preferred angle because it's the Earth tilted in this small little local system. We specifically see that tilt far beyond our local system, which means it cannot be caused by the tilt of the Earth.
Yeah,
That is a
can be-
major problem.
Yeah, it can be caused by it, but maybe God designed it to match on purpose for some reason.
Okay. You know, and like that's where you are a very confusing individual for me, right? Where it's like maybe God created the Earth to be tilted to create the local, but also created this random distribution of energy that goes against the model and even the proposed physics of the model to coincidentally line up with it beyond that. But still, the Copernican principle must be true.
To
Is it
telegraph-
possible
yeah.
that Is it possible that maybe the assumption the Earth doesn't occupy a special position is just wrong and it is closer to a preferred position of observation, right? Like, wouldn't that make more sense as a theist?
Yeah, I don't have any problem with that. I would say that maybe God did put the solar system in the center. Maybe this whole tilt in the WMAP data is God telegraphing his preference for this one spot in the universe.
So just FYI, real quick, I did post a paper in the chat that's basically showing that like the axis of evil is basically defined as the preferred axis in specifically the quadrupole and octopole. So just two of the thousands of different multipoles. So that's what I was asking was why does it only show up in those?
Well,
It
and
does
now we
show up
figured
in
out if it shows
dipole.
up in the dipole, you just think it's not enough data in that dipole that it shows up.
Yeah.
Um,
And the
well, like
quadrupole
in
and
all of the lower values, like the lower multipoles, like the sample size is going to equal 2L plus 1. And I think that the L value is either 2 or I think it's L value is 2 for the quadrupole and 3 for the octopole. So you can look at the sample size just 2L plus 1. But yeah, that's just what was my question was why it only shows up in those and not the others.
That it shows up at all is the silver bullet.
Well, this, I mean, like I said, they're in a really tough position here. So, like, just casting like any gray area into it is kind of where they're forced, right? I mean, because say hypothetically what you're saying is true, and the only reason it looks like there is an axis of evil in the dipole is because there's basically less data. And when you get more, you don't see it anymore. So then there is now a suggestion of a repetitive coincidence from the octopole, quadrupole, and down to the dipole until you get more data that just creates the illusion, right, that there's an anisotropic inhomogeneous preference on the Earth. Like even that doesn't logically hold, right? It makes much more sense that the data from all the different quote unquote missions have consistently shown the same thing because it's something's there.
Like my question is just like if the axis of evil is really a real thing, why doesn't it show up in the higher multiples?
why would it be random though? Like, why wouldn't it be random? It's 23.4. You know, like why does it match and correlate perfectly? Don't you think? Like
But don't you see that that's like not what I asked? Like I'm trying to be specific with my question here. I'm
Well,
not coming with a
you're
bad faith question. I'm genuinely
it is
curious what your
it is
explanation
coming
is.
across based as a bit of a science denial kind of thing.
Well, I think I specifically addressed. I'm saying I downloaded your paper. I retitled it. I'll read it. I will see the Stillman, and I've talked to like even actual astrophysicists, and they basically just they admit that the data must be wrong or they have no explanation, right? Then I'll read it, and I can't speak for anyone else in here, but I'm telling you that I'm not familiar with the claim that it definitively never shows up when we get more data. But cool. What I'm saying is to move the conversation forward, unless someone else actually has a specific answer to that, even if we were to assume that's true, it still doesn't logically make like it doesn't actually provide us clarity other than to say all the other times, even when we have more data, it's just a coincidence, an illusion, right? So if there's like an outlier, then like it doesn't really logically hold to say, well, since it doesn't show up as much here, then we can dismiss the rest. That's what I'm asking you is like, what is like the logical implication for you that you're suggesting if what you're saying is true? Because I don't know that it's true. I don't think that you're making it up. I think you probably read a paper that seems to only talk about the quadrupole and the octopole, and you're kind of assuming that you don't see it, right?
Well, I get what you're saying. It's a good question. And I just like it's not just this paper, like the quote that you provided from Tegmark also specifically says that this is in the quadrupole and octopole. But like I wasn't trying to say like that you can just hand wave dismiss like the axis of evil because it's only showing up in like the lower multipoles. Like I still like I'm not gonna pretend like I have some explanation for it. Like again, it's like a huge open question in cosmology. I was just curious about like if it is like a real thing, why would it only be appearing in these lower multipoles? Like I'm sure like if it was a real thing, then there would be an explanation for that, or I'm just wrong and it does show up in higher multipoles, but that was not the impression that I got. So I was
Well,
just
okay, so
curious.
let's get to the bottom of it, like, though. So are you just kind of assuming that it isn't showing up because certain papers and quotes focus on the quadrupole and octupole, right? Because obviously what I'm gonna want is to see this like higher L value, more data of the dipole specifically not showing it. Right? If every time I Google it and I see depictions of the quadrupole, the octupole, and the dipole showing this axis, right? Then like the fact that people focus on the other two doesn't really cut it, right? Like I need to see this data set that doesn't show it specifically because I've never heard that in my life. I've talked to a lot of people about it. All they try to tell me is that they think there's like foreground contamination, and the improper statistical analysis.
Are
That's the
you
only two I've ever heard from anyone with
Are
credentials or
you
anything.
sure? Yeah, sorry, I didn't want to talk over you. Are you sure that that only wasn't supposed to be also, or wasn't actually also? Because that's far more plausible than only, because it is in the dipole and the quadrupole and the octupole, so it may have been also instead of only.
Well, I mean,
Here's
yeah.
I found an image of like the different L values here. I'm just gonna post that. Again, this is just something that I found quickly, so I don't know if I don't know if I could completely vouch, but that's just what I found for like the different L values. So I think L equals 2 is the octupole, L equals 3 is the quadrupole, and then you can see the L values keep increasing. And you can see the kind of rough patterns in them.
But you're not like, and to be fair, you're not really addressing Witset's a point to you that like even if we were to grant you that you're right about this, which is a massive if, because it sounds like nobody here has really poured over that data. I certainly haven't heard about that either. But even if we were to grant you that, what's your explanation for why all of the observations up until what you're claiming is we finally got enough data where we could just parse out the previous axis of evil observations? What's your explanation? What would you say to why we have those observations to begin with?
I feel like I did answer that in that I was saying like this is a huge. I said I don't have an explanation. This is a huge
Okay,
open
so you
like
you don't
question
have
in
an explanation.
cosmology.
Okay.
I don't know what is causing that behavior in the lower multipoles. I was just asking why it seems to be just in the lower multipoles. So you can see like in the image that I posted with the higher L values, if you draw that same diagonal line that was shown in the image above it in the octopole, like that is not doesn't seem to be a line of symmetry in the higher L values.
Well, I love when stuff like this happens because now I'm going to get to the bottom of it. Kosho, are you at your mic? Okay, Kosho is going to be your best friend here, and he's going to invoke Chronic, and Chronic's going to be your real best friend, as is Professor Parks. So we'll get to the bottom of it. This is similar to the radar to the sun. Once people kept bringing it up, and I'm like, okay, let's go get to the bottom of it, and then it just got destroyed. And so I am interested in this. So I'm going to read this paper. Like I said, all I've ever heard is that is wrong. The most popular thing, and some will say it with like outstanding confidence, bro, right? Like that the actual program that the data is analyzed with is wrong, right? Like that the actual coding was improperly applied. Okay, that's the number one thing. And then they'll claim that people have even shown that there are other ways to do it or better ways to do it or whatever. And that it's still debated as to whether or not that's even the proper interpretation of the data. And then number two is foreground contamination of the data. So in both of these scenarios, they dismiss it. Now, to me, that is retarded, frankly, right? Because that's just like saying Dayton Miller is instrumental error. Foreground contamination just coincidentally causes the illusion that the Earth's in the center in deep space, right? Like, what? What does that mean? Like, that doesn't even make any sense. really neither does the code, unless the insinuation is that someone actually interpreted that data with an extreme bias. And actually, I went and read the writing of the guy that initially created the statistical analysis, and he said he kept on trying to work with it to not see that, because he assumed he must be wrong, right? Like he had a bias against it, and said that he begrudgingly had to step back and reconsider everything due to the implications. So you see what I'm saying? Like when people say, like, for example, that Mickelson Morley and Dayton Miller's subsequent tests, et cetera, is instrumental error, like that doesn't make any sense, because it's like consistently with the preferred direction, changing with the time of year. Like instrumental error doesn't do that, right? It doesn't change based on cardinal direction or points in space or times of the year, like, or altitude. And this is a similar situation where, like, we can't really even take the foreground contamination argument seriously unless someone wants to articulate with some specificity why that foreground contamination would give us like this specific intersection, right? This specific axis. And it doesn't make any sense. The best option that I've heard is that the data is just improperly analyzed. And then you're bringing up that I think I've never heard specifically that a higher L value, all of a sudden we don't see it.
If the foreground contamination aligns with the solar system plane, then you could expect that the foreground noise would produce that effect.
Yeah, I mean, like maybe the fact that like as you add more poles, right, it will be more greatly affected by the slightly canted or off-centeredness of it, and cause it to spread and like the pole to shift to a non 23.4 degree direction, right? Because you could still draw a pole somewhere, take the average of the function of that space, but it would be all over the place after you add so many poles.
Yeah, I'm not sure if I quite understood what was like that last comment that was said, but I do understand that it's like, it's frustrating when people kind of try to dismiss things like without like looking at them with an open mind, and like they're just kind of reasoning that their conclusion has to be right, so they're going to dismiss anything that disagrees with their conclusion. And I certainly don't want to like give the impression that that's what I'm doing with the axis of evil, because like, I couldn't talk specifically about Dayton Miller. I haven't like really done a deep dive into Dayton Miller's experiments, but I would never like just dismiss them out of hand without like actually like looking at them like seriously. So I'm
Oh,
not
that's
trying to
cool.
give that
You just
impression that I do that.
you just see the logical point I'm making though. Like
Yes.
I'm not, yeah, like I'm not even insisting that you are doing anything like that, but it's like it really has a grasp at straws fill, right? I'm interested in this aspect of it because I've never heard it. But
Um,
it's like instrumental error or foreground contamination. Like you can basically, if you can say that, even though it doesn't logically make sense, you can say that about anything, right? And so that's just useless to me. But basically, to stillman your argument is that when you have more data, like let's make sure we're on the same page. Like, so when you invoke the L value, like really lay out why it is you're saying, like what exactly your critique here is, right? Like when you say a higher L value as it applies to the CMB, and then how it would suggest that this axis of evil may not actually be there. Like just lay out exactly what your
yeah. So like the L and the M numbers, those are not like specifically like something that comes from like just this analysis of the CMB. It's like just broadly like in spherical harmonics. Anytime that you like use the mathematical process of spherical harmonics to like break down complex spherical data, you're going to break it down into a series of multipoles, and each multipole is defined by an L value. And then each L value has a corresponding number of M, like there's like a total number of M's. So like within each L value, there's 2L plus 1 different M values. So
Initial assumption.
when you're doing this analysis, you're basically averaging like over the different M values. So your sample size for each L value is going to equal 2L plus 1. Because like no matter how much data you do, no matter how many times you repeat it, you're only going to have that number of M values that is dependent on your L value. So in the higher values of L, you're going to have a larger sample size because you're going to have more M values for which that you can average over. But
How do
in
you choose?
the lower L's, you're going to have like just by like mathematics of how spherical harmonics work, you're only going to have a certain number of M values that you can look
How,
at.
how do
Which
you
is like
choose your
degrees.
M values?
How do you do your M values?
How do you choose them?
You don't choose them. You just like look at all the different M values that you have, and that's your sample size.
Well, then how do you get the M values? How do you have M values?
Like it's a different like spherical harmonic number. I don't know how to describe it differently. Like the L values are related to the wave number, and the M value. I specifically took like I first came across spherical harmonics in quantum mechanics, so I'm only really the most familiar with L and M values in quantum mechanics, where your L value is your angular momentum number, and then your M value is I think the different numbers of magnetic moments. But they're quantum numbers. That's how I'm familiar with them. So in terms of what that would mean physically for the CMB, I know that the L has to do with the wave number, which is kind of akin to like a wavelength. But in terms of what the M represents in the CMB, I'm not sure if I could like confidently answer that right now. But it's a good question. I'm definitely would have to look it up.
So it's the relationship of the indices and the degrees. And M is degrees. It's just the mathematical, basically like the mathematical description of the spherical layout itself.
Yeah.
Yeah.
So like
So,
I was explaining it a little bit earlier, with like with Fourier transforms, because like whenever you have a really complicated signal, you can break it down using a Fourier transform into like its component sine waves, and you cannot do a Fourier transform on a like spherical coordinate data. You have to use spherical harmonics. And so they're analogous to the way that a Fourier transform breaks down a complicated signal into different components. It's the same thing, but with spherical data, you use spherical harmonics, and the different components it's breaking down are the different L values, and each L value has its own set of M values. And when you sum up all of those, like a linear combination of every single L value and all the M's in it, when you sum them all up, then you get your original signal.
but you don't actually measure an M value. You just
You measure
select,
the signal itself, and then
and you
it's
select an M value.
perform.
Yeah.
You measure the signal itself, just like when you do a Fourier transform. You know, you're not individually measuring each of the sine components.
And
You're
then you
measuring the
apply
signal,
some
and
kind
then
of,
you're breaking it down into the component parts.
and then you pick an appropriate M value that you think will provide the
Okay.
No, you don't do that.
granularity.
Okay, so the L value tells you the wavelength of the oscillations. I just dropped a LibreText link that's going to explain it to you. If someone
Cool.
wants to know. Yeah.
Um,
So as you see, as the L value increases, meaning like the wavelength of the oscillations.
yeah.
I mean, I don't know. I'll have to find where there's supposedly not an axis here because I'm not really seeing that.
Did you see the picture that I posted that had like some images of the higher L values?
Yeah. Okay. Yeah, I see it.
Yeah, so and you see like the picture that levelist that had the axis of the Earth's like the ecliptic plane. If you look at that same diagonal, like that same ecliptic plane, and you draw it on the other higher L values, it's not really. I just don't see that the same alignment.
Meaning with different wavelengths of the oscillations. So it's a different aspect of the spectrum.
Yeah.
Right? Yeah. So like, good question. I mean, we would need to actually understand the phenomena, I guess, right? Because if there's isotropy or lack thereof, I mean, it's going to require an interpretive framework in general. But like, there just should be no anisotropy. I can't say it unless it's isotropy.
Anisotropy.
I hate the word so much. But
I think it's a fun word.
it's okay. So yeah, anyway, like, I don't know. Like I said, this kind of brings me back. I'm gonna read different papers about it, I guess, because
This is a great link that you sent, by the way.
yeah, it's dope. Yeah,
They
Super
talk
text is
about
really dope.
the power spectrum. That's what I was referring to earlier. I think you might have stepped away for that part, but yeah, this is great.
It's even got a couple of videos in there about scanning over the power spectrum.
Oh man, yeah, I'm gonna be. Yeah, this is an excellent link. Thanks for providing it.
Yeah, LibreText is the spot. So we'll figure it out, because for me, just on its face, right? Like, the heliocentric, or more so the Copernican viewpoint, has to say that the data is just being misinterpreted. And like, say that if I isolate like the higher wavelengths, like, well, that and I don't see as much of like a preferred direction, it isn't really going to help. Why do I see the preferred direction right with a lower L value? Like, it's still the question is still, we should never see anything even close to a preferred direction, because the Earth is so insignificant. Like, it shouldn't even. You now, I think Coach was alluded to something about the idea of like something to do with the actual process of how we gather the data itself creates that bias.
Mm.
Now, they never articulated with specificity how that would happen, but something like that, would have to be the case. As in, like, whatever the way that we're actually taking the data itself, the actual instrument is creating an observational bias. Now, what that's not really going to help with is the tilt. It's not going to help with the tilt. So I've never got, like I said, I've never really heard. I wish Coach could talk, because he's going to know more. And I think it's either J Ace or Chronic that act like we're so sure they've already shown that, yeah, like the data was improperly interpreted. That's for sure, like, the go-to.
I appreciate what you just said. I just also want to point out, in that link that you sent, in the very last video in that link is really great. It's what I was talking about earlier with the power spectrum and how it was first predicted in the 1970s, and then it literally goes through every measurement as it gets closer and closer and closer to what was predicted, and you see the data points getting closer and closer up until the Kobe, the WMAP, and then the Planck satellites, where it is literally like so, like, exactly matching the theoretical prediction for what the power spectrum should be. And the power spectrum, the x-axis is the L values for all these they're plotting all the potential L values along that axis. And you can see the error bars get bigger and bigger and bigger at the lower L values.
Okay.
So what I was saying earlier, and I'm gonna have to head out here soon, but just what I was saying earlier was that, in my opinion, specifically the power spectrum of the CMB is the strongest evidence for not just like the Big Bang model, but like the Lambda CDM model, because like dark matter is contained within that power spectrum. Like, information about dark matter is like, there's like the Sachs-Wolf effect that's in there with dark energy. Like, the power spectrum to me is the strongest point of evidence. And so the
We're
link that
gonna have,
you
we're gonna
sent,
obviously have staunch disagreement with that. So
yeah,
we,
but I
we can
like
maybe set up a conversation about it or something.
yeah, the link that you sent is like the best link that I've seen talking about the power spectrum. So definitely, I don't know. Yeah, if you could debunk that, that'd be really fascinating to watch.
Isn't it predicting what you've already predicted? It's sort of like a retrograde circular kind of thing.
No, because the prediction was made in 1970, and then the power spectrum was not observationally measured until like Kobe, WMAP, and Planck to any close degree. Like,
So apart from the power spectrum, what is your second source to confirm the original 1970s prediction?
sorry,
How do you
what
know
was
it
your
fits?
question?
How do you know that the power spectrum exactly fits what you predicted the power spectrum to be? How is that confirmed? What's your control in your
Because
experiment?
you construct the theoretical power spectrum using like just theory. So it's basically plasma processing with like linear perturbation theory, and you have like 5 or 6 like independent free parameters, which
Okay,
are
yeah,
like
sure,
coming
sure.
from like
I got that. How did you predict the original 1970s
that's what I was just
spectrum?
explaining to you. I was explaining to you exactly that, and you cut me off. I don't get it.
No, I thought you meant the same thing. Okay, no worries.
Yeah, like you construct the theoretical prediction for what the power spectrum should be based on like free parameters that you're getting from the inflation model, like your R value that's coming from the inflaton field. You're you're using like different aspects of I think there's like total baryon uh energy density, or there's the amount of dark matter is another free parameter, I think, but like they're they're putting this in based on like the lambda CDM model, and they're constructing a prediction for what the lambda CDM model would predict the power spectrum to look like, and then it was measured pretty precisely with the Planck satellite in 2013, and it's like you can look at the data versus the prediction, and it's like so dead on. Like that link that Widget sent shows it pretty well.
Have you heard of bicep 2 experiment?
Yeah, I have.
Do you know what? Can you give us a quick rundown on what was all that about?
Yeah, they thought that they had observed the polarizations, and it turned out to just be a bunch of like space dust that was that causing that.
Right. So the model predicted exactly. It's not quite. You're missing out some pretty key details that are often left out. They had a model that predicted exactly, just like the power spectrum thing, that they would get a signature in the CMB as a function of the early universe, and they found it, didn't they? They found it to a very high sigma. And what did it turn out that they were looking at?
I feel like I already told you.
Yeah,
Like space
dust.
dust.
Yeah, local dust. So they looked at the data. They found the signal to a very high confidence, and then worked out that they weren't even looking at the right thing, but they found it. Isn't that the same thing as what you're saying with like the power spectrum? They made a prediction, a testable prediction. They made an observation later on and found what they are looking for to a very high confidence, and then realised that they weren't looking for it at all. So you're saying the power spectrum is this really good evidence of the Big Bang model.
Yep.
And I'm saying, well, the bicep 2 results was like 10 times better evidence because it was a clear thing that they could measure, but it wasn't there. So is the power spectrum the same, going under the same thing? You go out and you look for something that you expect to see, and you find it. That's what happened with Bicep 2. How do you know that is not happening with the power spectrum?
Well, because like the Bicep 2 results were overthrown like very quickly. They retracted that paper. The other like the physicist community was pretty quick to point out the problems with that.
But I'm
And
talking
like
about
if
I'm
if there
talking
were
about
similar problems
scientific
with the
method.
power spectrum, then like I mean that the power spectrum data they've been measuring that shit for almost like what, 2
I
decades
understand that.
now or more.
Isn't
Like
it just a confirmation bias though? Isn't it the same confirmation bias that you use that happened with Bicep 2? You were out
no,
looking for
I
something
don't think it is
specifically,
though, Daryl.
and all right, that's fine. Justify that statement.
Yeah, I don't think it's confirmation bias because like they just made a prediction for what they should see. They measured it, and again, they could have measured the power spectrum to look like anything. It didn't have to look like what was predicted. They didn't force that in their observation. Like they didn't there was nowhere for them to manipulate the data to make it look like the power spectrum. Um, there's no reason why local dust should be able to replicate the power spectrum because again, it was
There's no
the
reason
wait,
why
wait,
local
wait, Daryl, hold on real quick. Because the astrophysicists were the ones that showed, hey, this cosmic dust can replicate the polarization effects that the Bicep 2 experiment was showing. But no one, to my knowledge, has ever shown that space dust or local dust was able to create the power spectrum that we observed. If somebody has shown that, then I will retract everything I said.
Do you not realize that it is exactly the same as the Bicep 2? And
I
you
don't
put it
realize that
you
because I
put
don't
it
think it
in
is.
wait, I'll let you speak. You put it in the same context as you're saying there was a prediction. We went out and looked at it, and you made an affirmative claim that essentially that they did see the polarization patterns, and they didn't. They didn't see them. They thought they did, and they weren't even looking at. They were looking at local dust. So how is that different to the power spectrum?
I just explained it. You're asking the same question again. I don't know where to go from here, but
Well, you just
um,
explained it.
real quick, I would like
as-
to address something that Caleb was saying in the chat, where he was saying that like
Okay,
l-
change the
that
subject. Fine.
well, because I answered you twice and you just repeated the same question, Daryl.
Well,
So I'm
you were
trying to.
literally twice exactly saying the same thing that I just explained to you about Bicep 2. You
I did
repeated
explain why it was different,
directly,
Daryl. You just didn't
excuse
like
me,
my explanation. I'm
directly
sorry, but
parroted what I said happened with Bicep 2, but it's okay with the power spectrum, but not Bicep 2.
I
Okay, well
did
if that's
explain
your
how they were
stance,
different. I don't know why you don't think I did, but okay, Caleb, with you saying that the higher L values are looking at smaller amounts of the sky is not accurate. Both of them are looking at the whole branch of like the whole section of the sky. So I don't know where you're getting that. Maybe because you're saying that the higher L values correspond to lower wavelengths, but again, they're looking over the entire stretch of sky. Minus the galactic plane because you can't really look at the CMB through that. So I just wanted to address what I was seeing in the live
Is
chat
there
there from Caleb.
is there an annotation as to the correlation between what the L value is and what the frequency range represented within the L value is? Like a table?
Like converting the L value to the like wavelength of
Yes.
oscillations.
Yes.
I could try to find one. I was about to head out, but that is a good question, and I would like to find. Did you look in that link that Witsit sent?
Yeah, I don't. So let me go back. I think I already closed it because I was looking at it already. Yeah. So here, there's charts with like L values, but there's not a chart with like that I can see so far mapping hertz to L value, right? So that's what I'm wondering.
Well, hertz would be frequency, not
I can do
wave.
that for you guys. You trying to do a calculation? What's the frequency, and you want a length from that, right?
No, he wants to go from the L value of for like each multipole, and he wants to go from that to frequency, I think.
What would you theoretically?
Yeah, I can do both. If you tell me a length, I can tell you the frequency.
Well, that's what we're trying to do is find the length. The L value is a dimensionless term, I think.
Like, I'm just curious, would there be homogeneity across, like, you know, the entire power spectrum in terms of all frequencies, or would frequency play a part in it too? I'm just wondering if that is like a factor in it whatsoever.
It's my understanding that like different acoustic oscillations of different wavelengths are gonna show up at different intensities at different L values. But I'm trying to find where you can get those numbers exactly. It's just like like the math might be a little advanced.
Yeah, it is. This is where you're gonna get into calculus, and you got to do stuff with Euler as an example. Do like an antenna calculation. Like if you have a known length, but you don't know the frequency, then you can do the math there, and you can get the frequency. If you have a frequency but don't know the length, then you can do the same thing.
Yeah, but we're talking about not just length and frequency though.
Right. Yeah. Not
Like
sure.
we're trying to get the lengths from the L values. So there's like one more added step of complication.
Right.
And this goes into spherical harmonics, which it's been a minute since I've really worked with. Um,
Well, spherical harmonic, like for example, you have like quarter wave, and then you have half wave, right? The way the harmonic there is, traditional radios, the way that works. We can definitely do calculations there. All that's known, but not sure how they're using it with what you're trying to do. I'm just a radio and plasma guy, whatnot. I can understand. I know how to do calculations there and whatnot, but not too sure what the way it's being used and with what you're doing.
it's like a way of breaking down the cosmic microwave background into its like component multipoles.
Right.
So
Different intensities that it has at different wavelengths, right?
yeah, exactly.
Yeah.
So he was just asking how specifically to like deconstruct and get wavelengths from the different L values. Like get the intensity of the different wavelengths at each L value.
Yeah,
Um,
yeah. I was just curious if there's like a relationship there to be had or not. You know.
yeah, there is. It's like they have it here in the quantitative description on that link that Witsit sent. Um,
Are you talking about like are you looking for like a standard like a length to make an antenna to suck in as much energy as you can, like an efficient length?
no, I don't think that that's the context that he's talking about, but
I'm trying to help them, like what's the goal that you want to get to it, with this data, in other words. I'm kind of a working backwards kind of guy. Like you tell me, what your goal is, and
Well, yeah. So just to see if there were any other. So right now he's like looking at data correlations between L values and exhibition or non-exhibition of this axis effect. And I was wondering, like, if there would be any way to like correlate that data with the frequency of the received radiation and see if there's any correlations there as well. Like, it's just like an intuitive question. Like, have we looked at that to see if there's anything else that does like this same thing, right?
Oh yeah, there are. Like whenever you're calculating the power spectrum, there's multiple effects that can affect like the frequency of um like the wavelengths that you're uh receiving. But again, it's calculated into your construction for what the predicted power spectrum should be. So, like,
This
they
is what
talk
it
about,
is.
like, the Doppler effects, there are certain plasma processing effects too, and
Right,
there's,
right.
like, the velocity of the plasma wave can also affect it, but these are accounted for, um, when they're constructing it. I can link you a really good lecture series that goes through exactly how they construct the power spectrum from, like, just the theory, and then they at the end, they show, like, where the data matches it.
It's the power spectrum is of the temperature variations across the surface of the CMB. It's not an RF power spectrum like you would normally consider in the radio world.
So, well, my thought is that, and I don't necessarily, I haven't looked enough into this to say this conclusively, right? But just like, as far as the dipole moment in the, well, I guess it'd be the multipole moment in this instance, but that being lower, right? Would that contribute to like a greater sensitivity to detection of these effects, whereas opposed to like taking a million different poles and putting measurements in there, like starts to like change the way that we perceive the data in terms of sensitivity?
The poles are an analytical model.
Yeah, I'm just asking questions. I'm not saying like that's what I'm saying. Is that, does that play a factor into any sensitivity of receiving measurements like this? Like basically, as you're
No,
cranking up
no.
this L value, by cranking up the L value, do you like
What you receive inside the antenna is the monopole, which is just the raw data basically, and the dipole and the quadrupolar analysis of that data set. I think that's the way it's put.
Just FYI, I did post in the chat. This is just the first lecture. I think it's like a 5-part lecture series, but this is like if you're interested in actually like the math that goes into constructing this power spectrum, this is the best lecture that I would point you to. Like this guy breaks down like each equation, like he's breaking down what each parameter that goes into it is.
there's an
It's
answer right here. Sorry, I don't, if you continue, I wanted to see if this maybe was what I was talking about in terms of sensitivity, but fleshed out in a much more specific manner. Casey Industry put in the chat, he said, I asked, are higher L values more zoomed in, showing less of this cosmic microwave background? And the answer received was yes, that's correct. Higher values correspond to smaller angular scales, and in the context of the cosmic microwave background, represent finer details on the sky. So, as you
yeah.
increase the value, you effectively zoom in on smaller scale structures in the CMB, showing less of the overall large scale features and more of the fine details in the temperature fluctuations. So, like, by changing that angular scale at which you're looking, you get a smaller picture of the overall background. So maybe by having the lower numbers, you're able to see it as a whole better, and that's why it
Yes, so I'd
contributes
like to
more.
address that.
Okay.
Yeah, you are looking at smaller angular scales, but you're still looking at the whole sky at those different angular scales. Like you're getting more fine details, but again, like you're still looking over the whole sky. It's not like you're only zooming
No,
in on one small region. That's not how this works. You're just getting smaller levels of detail across the entire sky.
So he's saying, can you give an explanation for the difference between the high and the low L values and define the differences between them? if it's not more zoomed in on the cosmic microwave background, like what's it zoomed in on, right?
Yeah,
Because
like what you just read was a good like explanation for the difference between high and low L's. I mean, they're different angular scales.
so
So
what does
like
zooming do?
basically like you're like if you think of an image, right? Like the more pixels you have is what would be analogous to a high L. Like the less pixels you have to describe that image, those are what you're seeing with like the lower L values. That would be the analogy for like how the angular scale works in spherical harmonics. It's not like whenever you add more pixels and the picture gets more HD, it's not like you're zooming in, you just have a finer level of detail.
So if you're not okay, so you're basically talking about like cranking up the resolution on a monitor more than you are
Yes.
zooming in a camera lens.
Oh no,
Yes,
it's not
exactly.
really the way it is. It doesn't. That's not how it works.
Well, that is exactly what's described in that link that Witsit sent. It was even talking about like angular resolution at a certain point. I think it brought it up.
KC was saying every explanation he's looking up is saying that's what he's saying because he's like asking AI about it, and these are the responses he's getting. His AI is telling him that it's basically like, you know, the section of the sky that's being analyzed being more narrowed as you increase in L value.
It's not that you're zooming in on a small detail. It's just that the level of detail gets more fine. So you're able to see those
Which is the
smaller
same
details that you
thing.
couldn't see at
Yeah, but
lower
like
L
you're
values,
zooming in.
but
It's
you're
the same
still
thing.
seeing the entire sky.
It's the same thing.
Wait, but hold on. Like you're only going to have so much space within your measurement, right? So regardless of how you want to like put this, if we see it at once, if we see a specific shape at a lower value, right? Like we were talking about, what we describe as the axis of evil, what all these famous astronomers have described as the axis of evil. If you take that, so you only have so much space on your say your monitor, so to say, and you start zooming in on specific details. If you start bringing those specific details into a larger field of view, then you're not actually getting less of a picture because you only have so much space on your monitor. Do you get what I'm saying?
Yeah, but you still have like you're still looking at the same total picture regardless of your angular scale. You're still seeing all the same
I
cosmic microwave
understand that, but it's
background.
like you have to think of it like focusing like a you have to think of it more like focusing a lens, right? Like or actually like more like an aperture or so you
But
have a
it's not like that. It's not
well, it's like
analogous to that.
focusing a lens as far as you only have so much field of view. You only
I
have
know,
so
but
much space within your observation.
again, you're not changing your field of view though. You're looking at the whole cosmic microwave background in every angular scale, like across all the different L values. You're still looking at the total
I
CMB.
understand that. I'm trying. Maybe my phraseology is a little bit off, so I apologize for that. I'm just trying to kind of conceptualize this idea that you're no matter which directionality you're going with, no matter I understand that that stays uniform, but if you are accentuating different values, if you're changing your harmonics, there's going to be certain harmonic ranges where you're going to you can't change the perception problem. You have a limited field of view for your picture, right? And so you're like zooming in on a certain frequency of that picture where you can drown out what you saw at a higher or at a more pulled out resolution.
Yeah, but do you have a citation like okay, like a specific when you said it's in this article? Like, what are you seeing that's talking about how it's not describing what KC is saying and the AI was giving him versus what you're saying as far as it's not seemingly zooming in?
Like you can look at the different L values. It's still the same total. Like again, I posted that picture of the CMB at different L values. It's not like you're zooming in on it. Like you are looking at like a small the details that you can resolve like become finer. Like this you're looking at the same overall global data just at a smaller angular scale. So like yes, like you see more fine details, but I really think that my analogy with the picture and the number of pixels is spot on.
Yeah, that aperture, that oval elliptical, shape of the background or the
Mhm.
aperture that they're measuring it through, right? I mean,
Mhm.
the device itself is staying the same shape. You're always going to get that shape on your reading because that's like the frame of the reading that you're taking, right? It's just based on the device. But I mean, you could still zoom in and be receiving on the other end like a smaller funnel. It's basically what it's acting like. It's like a simulated funnel. You're seemingly physically zooming in, right? As you like increase the granularity of that image. Everything's described in the AI references as something that seems like zooming, right? So we want to see if
But,
there's
like,
some kind of
okay,
reference.
when you're zooming in, you're seeing less of the overall picture. Like, by definition, if you zoom in, you're not seeing you get what I mean? But in this example, you're still seeing the same amount of space on your monitor or whatever, you're just seeing finer levels of detail, like, across the entire image. That's what it means to change the angular scale. So you're not, like, zooming in on one particular area of it.
Yeah, if you're not doing that though, then you're drowning out the other frequencies, man. That's what they're saying. So it's like bleeding out the
Well,
other
no, I
stuff in the
agree that you're
lower
drowning out other
divisions.
frequencies. I'm
Well,
not disagreeing with that part.
well then let's move on. It's a philosophical impasse
Yeah,
then.
okay. My
'Cause
my only point, and I do have to go I do have to go after this. I just wanna say my only point is just that, like, different, like, frequencies are going to be represented differently at different L values. Like, there's gonna be different intensities
Right.
corresponding to each L value, like, at so, yeah, you are drowning out certain frequencies when you change L values, and, like, other frequencies will be emphasized. So
Right. Very cool. All right, well thanks for that.
What's this you posted, Daryl?
Can I ask something real
It's
quick?
just an analysis of the
What up?
what the L value and N value is. If you look at that video at the time I've queued it up at, it's just the L value is the angular size, and the N value is the angular orientation. The angular size is like 0 for monopole, 1, 2. So it's anyway, that's explained in that video.
So L is Lorentz, right?
L is angular size in theta.
But what's the L? What is that? Is that the Lorentz transformation?
No, it's just
No, that was with
a
that was earlier. Sorry,
it's
my
just
my
a
comment
connected
confused
number.
you.
A little bit.
I was trying. We talked about Wang for like I don't know 10, 20 minutes earlier, so I was just trying to catch you up. I said Lorentz transformed Wang based on a midpoint relative to fixed space, and now we're cranking up the L values so we can drown out the axis of evil. But we're not talking about that anymore. And I understand it's sorry, I'm not trying to get a last word there.
I
No, I
understand.
mean,
You said you Lorentz transformed Wang already based on the midpoint to relative to fixed space. Now we're
I mean,
cranking up the L value. Sorry. But
oh, sorry. Go. I think the
No.
relative thing to ask here, right? The relevant question to ask is like, all right, so we see that regardless of what this L value variation is being derived from or why it's being caused or what it's actually doing, that here in these L values, right, that we see this very obvious correlation. And when we change that L value, something about what that's actually doing to our measurement obviously shows a shift in that where it goes away.
Yeah.
So first of all, step one, it's two parts. It's step one, why do we see it at all in the lower L values even, right? Because the fact that we see it in multiple L values and it's the same and it's consistent with the Earth, right? You've got L value 1, 2, 3, and then Earth frame. So 4 intersecting points with the same data, 23.4 degrees. And then after that, it changes. Why do you have it in the first place? And then after you answer why we have it in the first place, then you can say, okay, well, why do we see the data change when the L value changes?
That first part, that was what I was trying to kind of
get him to see is that, like, look, even if we were to grant you that the axis of evil is not a observation that is readily apparent at the higher L values, what is your explanation for the lower ones? And he readily admitted that he didn't have one. So right there, I mean, that's still an issue for the Copernican model.
Yeah. I mean, we were basically sitting here like, talking about the absence of an answer for a question about L value significance and why it causes alterations in the measuring, right? So
If you're changing this L value and you're getting different intensities for in terms of the power that you are detecting, it sounds like the L is related to originally what I was saying, which is antenna calculations for radio, which radio can be microwave as well. Essentially, you have a conductor, and a conductor is going to act as a inductor, as in it's going to pull energy in from its environment. So if you change that value, then you're going to also change the experiment because you're changing the size of the conductor, literally. Sounds like, at least that's what it sounds like to me.
Yeah, in radio, you consider it as gain or as your radiation pattern, angular resolution.
that's why I was asking about sensitivity, bro. Like, I didn't know by what mechanisms of sensitivity is affected by this, right? It was just like my original point I brought up like 30 minutes before all that, where he said he didn't understand what I was asking about. I was like, as you increase the number of poles that measurements are taken along, right? And then you increase these in number and it's like not perfectly uniform, it's going to lend to like, moving that whole moment in all directions. And so you get this lower number of poles, you can have, in my mind, it just seems like it would be more sensitive. And that's why I asked those questions about sensitivity.
Right. Sounds like it.
I don't know.
The
When I
less
was looking
poles,
at
the
Yeah,
more
so
sensitivity.
like if you can make your machine in this case more sensitive at will based on whenever you want, right? Then that does open up the possibility to basically make people see what you want them to see, right?
Yeah.
Because if you can just suddenly change the sensitivity, then obviously there's going to be a sweet spot for actual genuine experimentation, and then there's going to be a level where you like know that you're going to find a bunch of bullshit that you don't really want, but maybe you do want that because your hypotheses is different than what reality is actually showing you, right?
See, you know what I feel almost as if what they're doing is the reason mainstream admits it's like the axis of evil and a problem is like probably because like the dipole, quadrupole, and octopole are the only ones that like produce results that are like as relevant to reality compared to the rest of the measurements, and like probably L values higher than that they routinely dismiss. That's like my hypothesis without actually researching. I don't know because obviously they see it as a problem, and then
Well, yeah, I
some
mean, it would be a problem for me too, because that's
The
like,
cosmology.
how do you call that something
No, not
definitive?
at
It's
all.
like it's for me the same thing as in these PCR tests, and whatnot. If you scan the frickin'
Had to mute real quick.
It might be. It might be. I don't know.
Trying to explain about with the bicep too. It's the same idea. You find what you're looking for.
Right.
yeah. So
Yeah,
that's
again,
what I'm thinking.
I don't. Go ahead.
Oh, sorry, man. It's okay. That's what I was thinking that was probably happening. Like, I don't want to accuse it though, because I don't actually know. But it's like all these mainstream big name physicists who write all these articles and all these journals and stuff all talk about it as a problem, and then he comes along with, oh yeah, a year or two ago, some dude just like proposed this, and hey, yeah, we never noticed that the other L values don't show this, but these ones that we were originally worried about, well, we know that they show it. Why didn't we consider the fact that other ones didn't? We could have just dismissed it. It's almost like a rescue device, it seems to me, and that might not be true. I might not be giving it a fair shake. It's just like, why come out with this now when they've known about the whole body of data the whole time, right?
Well, for sure. Like,
Because somebody always comes in and save the day in terms of sweeping up the the mess before the standard model gets debunked. You know, and
Like,
whatnot.
Shout out to
like
Paul
missing
LaVue.
inflation.
Shout out to Shanklin.
Yo, this legit though. This was probably so far. I mean, one of the dopest ones presentations I've sat through in this Discord. You know, this was up there, man. So great job. Glad it spawned all this conversation, man.
She
We've
even
been
got
going
me
on.
confused listening to this stuff too. Normally, that's usually I'm pretty on point, but yeah.
Man, I got some stuff to just soak in and like simmer in, you know, stew in, bro, about some of these etherics, man, because and the implications of that.
Yeah. Yeah, dude, just oh. Yeah, it's pretty straightforward, really. I mean, unless you want to Lorentz transform yourself out of reality, that's what's going on.
I mean, I'm already about to like take selected numbers of my friends and maybe one or two family members and explain some of this stuff to them and just be
I
like,
just jump up and land in the same spot. But yeah, when you're talking about these experiments at these micro levels, like you're talking about, that's where I was explaining where a whole hertz, like, yeah, like that's easy. Like I can make, I can make a very accurate frequency driver. You want 1,000 hertz, easy. You know what I mean? But if you want fucking 1,000 hertz down to like 0.00000, and you also want one. In other words, I literally have to type it out in the chat. Like you want, you know, right? Like 1,000 hertz, easy to make, right? But making this,
I get what you're saying, yeah, with a bunch of trailing zeros after the decimal.
yeah, like making this, like not easy.
Right.
So
yeah,
that's where your parts, like even with military grade capacitors and shit, like I still have problems. That's where you start having to have ICs that are checking your work, and whatnot. And that's all basically, it's not really analog at that point. You know what I mean? At some point, it becomes digital. Like with the way our cell phones work, as an example, they have another chip that is detecting the temperature, right? And then that chip tells the oscillator like, oh, go up in frequency or go down in frequency because this is the current temperature, and I know that you aren't accurate unless you have me telling you like what to do, because you're never accurate temperature wise, right? Like that's the way the shit works. Like you have another chip that's detecting the temperature and all that, right? By itself, the oscillator wouldn't be accurate, in other words.
dude, something that also like this was I guess I learned this tonight, honestly, about we've already talked many times about ether drift and it changing as you go higher, right? I.e., closer to the ether, or not to the ether, but to the whatever the vortex type stuff going on above us is. And then we talk about, you extend that perfectly perpendicular line off Earth's surface upwards, and the further you stretch it out, the further you see this same exact, effect. Well, the cosmic microwave background, which is supposed to be from like a bajillion miles away, and it's also aligned with the sidereal rotation, it also correlates with that. It has a tilt, and I mean all this stuff, right? You see far distant lights exhibiting these same qualities. That's like, I mean, no wonder they're calling it at the axis of evil, bro. Like that really does force you. I mean, it was even in that quote he said that one of the options is there's three options, and the only one that actually works is that the Earth is, you know, in the center of everything. I'm kind of mind blown that this is like they admit, like mainstream physics people admit that this is a problem and seems to indicate that the Earth is geocentric and their entire model is wrong.
Oh well, they could have called it like the horizon of evil with the horizon problem, or the flatness of evil with the flatness problem, or the matter of evil with dark matter. Like all of this stuff is just dagger after dagger against their model.
Well,
Of
the
course, I
Hubble
mean
system-
the whole point for dark matter or dark energy is to fill up some missing thing in their mathematical model.
Hubble
But
space
it is,
telescope.
yeah. I love, man. That's why dark matter. It is the error margin. You know, like it's so funny. They have people convinced. They have people convinced that it's like this thing of its own, and it's like no. That's literally how much they were off by. They just took that percentage and then made it. They just claimed it was a new matter made of such exotic material that you couldn't detect it.
They had to invent something, to explain the other stuff that they couldn't observe.
Exotic matter, bro. That's just like we can't analyze it and detect it with our typical stuff because it's so exotic. But it's there. It's got to be, and we know it's there because it's got to be. Because otherwise, we'd be wrong, and we know we're not wrong. Duh.
Yep. Yeah, that's what it is. Well, and that's what's funny about kind of like all of this, like the horizon problem, is kind of the same thing where it's like, okay, well, we know that there's not enough time or space in the universe to where that could have actually happened. The way that we're told it is. So what do? Well, we just claim that apparently all of a sudden now matter can go faster than the speed of light. 13 times faster than the speed of light. And it's like, well, we couldn't just claim that. We couldn't just admit that we were wrong. We have to just keep on coming up with stuff that violates our own laws of physics. It's just, yeah, no, it's funny because that's really just what they do, and it's all to uphold the Copernican principle, which at the basis of it is just to keep trying to convince people that they're not special.
Yeah, bro. I mean, it's not even like they try to steel man it. They try to freaking like adamantium man it, dude. It's reify the ish out of it, dude.
Oh, it is. Yeah, it's just one big reification fallacy based upon another reification fallacy. But yeah, and that's why with I don't know that like when he came in and he was saying, well, Lawrence Krauss says that the axis of evil means that it's geocentric. I just don't understand why he says that. To me, like that's why that just shows such a misunderstanding of what the issue is and even is. It's like, it's not actually Lawrence. Like we have to appeal to Lawrence Krauss's authority on this. That's literally what the data shows. You know what I mean? It's like it's called the axis of evil because of what the data shows. And you got this guy Lawrence Krauss, who's a physicist, who's commenting on it and just basically putting into words what many people before him have put into words, what the people who discovered it claimed was the issue, which is why they named it at first. And then he, when he comes in, he goes, well, Lawrence Krauss said it's this way. And I don't understand why Lawrence Krauss says this. That's why I'm like, when people are looking at this information and they're looking, his whole thing was, okay, well, if we increase the data set, then we can drown out with the observations before, and then we don't have to address it. It's like, well, are you actually internalizing what the issue is to begin with?
Yeah, yeah, exactly.
Yeah, I think it's almost as if what he did is he came and diverted us down a giant rabbit hole by giving a very eloquently stated argument from incredulity, and that's based on like, well, I'm incredulous as to how it wouldn't work this way because look at the data. Like, why is this like I don't understand what I'm seeing with the data, therefore explain it to me because I'm just not getting it, and I just can't believe that he would say that because I'm not getting it.
Yeah. Yeah. Well, and it's like that, like what it was saying with the whole, it's not even close to the only issue with the Big Bang cosmology. You know what I mean? There's just countless issues with it. So it's fine. I'm not saying like we shouldn't dive deeper into each topic and try to parse it out and find out all we can about it. But at a certain point, you have to admit that like literally all of the evidence points to the opposite conclusion of the Big Bang. It's been falsified. And that's also why I was trying to get him to. I was like, hey, did you realize that the whole theory of relativity was designed based on laser interferometry? And it was interesting. I didn't get to kind of bring it back around to that because the discussion moved on. But I did want to find out why he said, yeah, partially. It was partially because of that, because you can read quotes from Einstein stating that, like, he literally claimed that the entire reason why he developed the theory of relativity was because of the Michelson-Morley experiment. So it is interesting when people are like, yeah, that's part, you know,
Who did?
again,
Who abandoned it for Mickelson Morley? Who let that cause them to abandon it?
Abandon what? Wait, what?
You say that they abandoned relativity because of Michelson Morley experiment?
No, the reason why the reason for the advent of
Oh
relativity,
yeah,
the
of
whole
course.
reason Einstein proposed it was because of the Michelson-Morley experiment.
Yeah,
That was,
yeah.
and that's why when I was asking him base theory, I had said, well, you do realize that laser interferometry was the entire reason why we have the theory of relativity to begin with. And he said, yeah, partially, that's part of the reason. But I didn't. I was interested. I kind of would like to know what other reasons he thought that there were, because in Einstein's own words, that was the reason why it was proposed.
Well,
There
dude,
was no other, like,
he's linearized. He's Lorentz transforming a linearized Sagnac effect, like a local Sagnac effect. He just came in here confidently with a paper and gave it to us, and the whole point of the paper was to Lorentz transform the speed of light so it's constant. That's what he just did. So, I mean, basically, I don't know, man. Like that's what a zealot does. That's what these people do. You crank up the L values, right? Like it's crazy the lengths people will go to not see what's plain in front of their face. For me, it's especially insane with the Wang thing because, I mean, you're measuring a difference in the speed of light, and then you're sitting there saying it didn't change.
Right, and it just so happens that we can
exactly,
predict and
exactly.
model it. We can predict and model that change, right? And you're like, nah, it's not really a change.
Dynamically, yeah, exactly.
It
Perfect distinction. Yeah, yeah.
yeah, it's just an illusion of pattern recognition that you have right there, and it's not predictable and it's not mathematically like useful. It's like, bro, like you can't deny the stuff is happening when we literally build technology off the fact that it's happening and correct for it.
Exactly.
Yeah, that paper, I read it over while we were talking about the CMB stuff, and yeah, it was exactly as we originally surmised, Toby. It
Yep.
was a preface to a thought experiment to explain the or to give the context of like, oh, we need an observer here for symmetry, right? And then they slid in a little contraction to increase the distance or to extend the time, which extends the distance. And then they were like, okay, cool. There's no invariance here. And then they were like, hey, check out this other frame real quick. That's we can place symmetrical with the axis of rotation of the first frame. And they literally did it again, like to the T. Like so they go from the thought experiment where they did that, and then they're like, okay, let's try it in for real life. Like no difference. And then they end here saying, well, that was all cool and all, but the main issue, though the mathematically it's fine, but the physical understanding of the effect from the standpoint of the observer attending the rotation remains difficult. So from the from the additional coordinate system that they invoke to watch the linearization change the speed of light, from this perspective, so that they can watch it, they're like, okay, well, we can explain hypothetically the frequency shift, but the physical fringe produced by the variance in the seed, like that still remains difficult. It remains difficult. Oh, cool. This paper's dog shit. It literally ends. It literally ends with, we conclude the original Sagnac delay. The Sagnac delay. So we conclude the original. We conclude that the origin of the variance in the speed of light, or the phase difference in the Sagnac or Sagnac-like experiment, is in the non-midpoint relative to what measurement of the arrival of time propagating, blah blah blah, right? So they again, they could only do it by changing the time and distance through contractions and invoking additional perspectives to watch the event, to claim that it's fine.
Right, I don't even understand like what is their reference frame, like relative to what, right? Like you said, it wouldn't matter. I mean, the measuring is being done on a loop, and it doesn't matter where you place like this gyroscope, you're going to encounter this effect. So, I mean, and I'm sure if you maintained altitude and latitude and just shifted it, to the right 5 feet versus to the left 5 feet, pretty sure we're still getting, the effect at both locations. So,
How dare
Yeah.
you? Listen, guy. We're gonna get a spherical or a cylindrical coordinate system, attach ourselves to the top. Like I don't know what you're talking about.
Yeah,
It's
well,
like
they're trying. I mean, what they're trying to do is they're trying to get C plus V to equal just C.
Yep.
That's what they. So it's impossible. It's literally impossible to do that. So what they're doing is they're coming up with a bunch of impossible shit to support that notion, and they refuse to accept because, like, yeah, man. I mean, what do you expect out of them? You know what I mean? It is indefensible. But if you say, well, we can apply this, we can move the observer here, and then what if we apply this, this Lorentz transform and all this stuff that we can't actually even empirically measure, just to get around admitting that C plus V is the only thing that works? Yeah, of course, it's gonna sound like dog shit on their end, but that's the tough position that they've taken on. So,
yeah.
risky.
It's a risk,
Risky
dude.
predictions.
Risky predictions, bro. That's all I'm gonna say.
Risky predictions. Yep.
Yeah, adherence to relativity leads to risky predictions if you want to continue down the path of Sagnac and Ruyong Wang.
Yeah, because, I mean, well, imagine building, precision equipment that operates at high altitude and not accounting for something that's actually happening.
Yep. Which paper was it that said risky predictions? I can't remember.
It was the one with like the 50 different configurations for the
Oh, yeah,
glass and
yeah.
fiber
It was like, I
gyro,
forgot.
where
Forgot it
where
was
the only
fucking
possible
amazing.
motion would be from the receiver, and they're like, "Do you want to take it, relativity? Do you want to take it?"
For the cases we mentioned above, the principle of relativity of special relativity gives an odd, and to put it in Popper's words, a risky prediction. That is to say, the time difference, delta tau, can neither be zero nor related to the length of the vacuum cell.
I mean, the summation of all those configurations that Ruyong Wang made in his patent would basically just be him showing, like, it doesn't matter, like, what you control or account for. Like, none of these other things give any perceivable effect to this, but simply the sidereal motion is the only thing that is causing it, right? I mean, that's the whole point of just making an absurd number of configurations just to say, this also won't affect it. This also won't affect it.
Well,
Pretty sure that was like almost
yes,
what he was trying to achieve, right?
Yeah, specifically for the Wang, not necessarily that it matches sidereal time, that the variance has a first order dependence on the velocity of the observer.
Oh, okay, yeah, because they were dragging across the conveyor belt and it was correlating with that motion.
Yep. Which is explicitly not supposed to happen.
Yeah.
Unless you're in that elusive non-inertial / inertial reference frame, depending on how closely you want to actually follow special relativity's postulates.
That reminds
yeah,
me.
and I
can
actually
science
just
that. Oh,
sorry, go ahead. No, go ahead. It's all you.
No, it just reminds me of I can science that. Like, I came in way late. Sorry, y'all, but yeah, he was arguing. It's like, well, C plus V, but also in the other direction, C minus V.
Yeah.
Just kept doing that over and over. And he's just like, well, no, it's C minus V in absolute space. Kept saying that shit. Like, I don't understand what he was saying. Like, why did he keep saying, like,
I got you, bro. He had to invoke a placeholder to preserve the distance so that he could change the parameters of the experiment, essentially, to make the speed of light stay the same, which, thought experimentally you can do or whatever, right? but in practicality, there is a physical friend shift pattern produced that that cannot be explained by a frequency shift in time. It has to be a physical, like the speed of light has to be, it has to have changed in that to produce it. There's no other mechanism for it in that thing. So the thing is he'll
Well, maybe
invoke absolute space for convenience, and then the real answer, though, for the mechanism, is the Lorentz transformation to allow the
Right.
variance, so you could watch it from another perspective.
Right. Exactly. Lorentz transformation takes you out of that reference frame.
I mean, it's annoying that we even have to say like that it traveled at a speed because yeah, it really is just that propagation rate relative to like it's not like the propagation rate actually even changed. The propagation rate stayed the same relative to the inertial frame. Like but we can't even acknowledge that, and that's where it's like insane because like
You can't.
we
Yeah,
it
you
gets a
can't
little
dispute
convoluted when
speed.
we say the speed of light like got faster or slower, c plus v. Like the v is just to make sure everyone's on the same page. Like the v is important with that. Like it's just the propagation rate relative to that inertial frame. So anything you do to invoke something outside of that inertial frame, you're doing what Bennett would describe as stepping out of the lab frame because if you want to invoke some kind of symmetry or something, that's only relative. Relative to what? The symmetry is relative to what? The length did not change. You would have to step outside of the lab to even to to observe anything along those lines.
It's yeah. Well, it's like as soon as you take it there, it's like why are you taking it there?
Yeah.
Which is basically what Jesus was saying. Like the way they have to just completely reify after reify after reify their model with mathematics. Lorentz transformation. It's another one. It's another one they do. Another covariance they like to do.
That's it. If you need C to be the same, you hit up your boy Lorentz.
That's it. Damn. Lorenz made it happen then, huh?
Sir.
Yeah.
They just stopped at Lorenz.
Essentially. Well, they got so when you get into general relativity, you got your metric tensors and such. So you got some of those, but essentially the Lorentz is like the gateway drug, right? It's like the marijuana that they brought in to get everyone addicted to crack. They were like, just take a hit of this Lorentz, bro. It'll make you feel good. Like it'll give you symmetry. And they were like, oh no way, symmetry's dope. And then all of a sudden they were fiending for it, bro. They were like, I don't know, am I accelerating? Am I in a gravitational field? I don't know. Just give me a metric tensor to calculate it. Like it got really aggressive really quickly, and that's why you don't do math.
Not even once.
Not even once, bro.
Not even once with all of that shit, bro.
Yeah, man.
Yeah, well, what's funny is as soon as it's funny because they can't even like you have to invoke like our like the actual true like you have to invoke attributes of reality to even try to defend the Lorentz transform. If you notice, I mean, I Can Science That did concede to basically everything Toby had asserted in that discussion. He conceded to C plus V. He conceded absolute space, and he literally, even if you play back the tape, he even conceded that you can detect linear motion with a friend shift. He said those words. So that was in his defense. That was in his defense of the fact that that relativity could totally explain Sagnac. So if you just take you have to step into a nonsensical, completely contradictory viewpoint to even attempt to go against reality.
Yeah.
So
by the way, I figured out your first Aether round table shirt. Repent the Lorentz.
Wait.
I want to do. Have you ever seen? There's like this really dorky shirt. If you can read this, pull me back onto the raft, and it's like upside down, and they sell it at like tourist shops next to whitewater rafting. And I want to do. If you can read this, pull me back into the lab frame, but it's like upside down. Mega nerdy.
That's actually pretty funny.
Have you noticed that there's I'm assuming you read through this whole thing, Alan, but on the it doesn't give me a page. Oh no, it does give me a page count. Page 25. There's a magic square in this book that you sent me. Experiment and observations on electricity made at Philadelphia. Did you peep that or no?
No, not at all.
Yeah, dude, right past the content table, intro table of content or whatever. This massive magic square, and it has a bunch of chevrons going up and down. It's right after the first couple diagrams of the.
What page is it on?
It's when I'm on the Google Drive or whatever this is. It's page 25, but if I zoom in on the side, I think it says page 353. So.
Shit.
Yeah.
Good luck. Yeah, I'll see if I can find it here.
It's right past you when you look at all the inventions. So it was preface. Right after the preface, it has the content. Right after the content, it has the diagrams of all the devices, and then right below the diagrams, well, actually in the middle, before the first letter, it just shows this, and it says Plate 4, a magic square of squares.
I want to know what the fuck you're talking about, dude.
I'm talking about the fucking book with the letters in it that he sent to me earlier.
Yeah, I don't know.
All books got letters, or at least most of them do.
Okay, here we go. Magic picture, magic squares. Okay, according to the squares.
You talking about John Searle and the magic squares, or what?
Let's see.
I'm talking about the thing that Alan sent to me earlier today called Experiments and Observations on Electricity Made at Philadelphia in America. He sent this to me earlier today, like a couple hours ago.
Yeah, you have to send me a
If you
screenshot of it.
scroll down, I'll do that right now. If you scroll down like 5 pages from the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Yeah, it's definitely on 25, page 25.
Share your screen out. I want to
Oh, I
see
see it.
Oh, what the fuck?
Magic squares?
Magic squares.
Dude, have you looked into these, dude?
Never
These
heard of
are
it.
apparently like super important. Yeah, there's
Yeah,
a
I've
whole.
looked into it. It does have to do with like basically numbers being real, not being imaginary.
Oh. Are you familiar with this particular thing? Like, do you know anything about this?
Apparently, they have one for each sphere, each of the 7 platonic spheres or whatever. They have a sun one. They have one that Benjamin Franklin invented. Like he invented his own. Apparently, you make these, and they're just certain patterns. They came up with this shit in Babylon, and it helped them predict eclipses or something like that. Was a thing, and it's like super occult, man. It's like they make those demon sigils using these magic squares and shit.
Yep.
But I just find it very curious that it's in this book on electricity, and that was one of the first things.
Magic squares.
Yeah, dude. If you don't know,
That's what I was saying.
look it up
It's
a
into
bit.
the vortex math. You're not supposed to know this kind of stuff, and if you do know it, then and you actualize it, you'd better have your trust set up a church, and a 3-ring circus in between you and your legal person, if you know what I mean.
I kind of know what you mean, but I wish I knew more.
Essentially, you don't want to really be using knowledge that we're supposed to them, keep hidden. Scriptures will say that we're not supposed to reveal mysteries and show people miracles because it's supposed to be faith. and you're supposed to find these things yourself, because if you are just given it, you will instantly enter the power self, which is the person who wants to like dominate people, you know, and empire, you know, and that kind of stuff.
Yeah, it also has. I think it has, dude. Like these magic squares. It's hard for me to get into because it's just kind of beyond what I can really articulate with what I've researched. But essentially, they're used for predicting things. Like somehow they're supposed to be able to predict like the future before it even happens, almost like some sort of divination type of deal thing. I don't know.
So I've been listening and I've been trying to keep up with you guys. I'm not a flat earther. I'm lost. I don't I don't think that we were talking about magic squares as like a proof to that. It's some kind of other thing.
It's
But
essentially you're talking about generating energy from shadows. Like,
magic squares?
yes, because it's the ratios between the numbers. It's not
Okay,
the
but
numbers themselves.
isn't a shadow just not light?
Okay.
Is it?
Maybe
Yes.
we shouldn't go into magic squares quite yet.
No, I just brought it up because it was in the book that Alan sent me earlier, like pertaining to what he was talking about with,
on this.
because he brought up Benjamin Franklin and that bottle of lightning or whatever,
Yeah, the
and how
Leiden
that was
jar.
an old world technology. Yeah, and Benjamin Franklin is accredited for inventing one of these magic squares that has like a bunch of like super unique properties mathematically. And I look into this fucking book, right? Because that's what I'm looking into. I'm like, fuck, okay, let me get onto this electrical bottle thing. I'm really interested in it. And the first thing I fucking see is a magic square. And I'm like, dude, that's just uncanny.
Dude, that's
And then I
awesome.
was just yeah, and I'm just explaining the significance of magic squares to the chat historically because I don't think Alan knows about it. That's all I
shared
brought.
that
That's
in
the only
chat
reason
by
I
chance?
brought it up for Billy.
I got you.
Have you shared that at all? I'm gonna see this.
I got
you. Posted
Yeah,
it?
I shared a TED talk with John.
You posted it. Noah posted a screenshot.
Yeah, there you go. There you go. The lost
I
symbols.
want to see it
Yep.
because I do know a little bit about electricity.
I got you, bro.
And I want to see this.
I posted his screenshot.
I don't want to interrupt. I'm sorry.
Yeah,
but
yeah.
I had to.
Told you,
dude.
Got
Andrew,
Ben and Yog in here. He's always on that wavelength with me. It seems to be.
I gotta say, we're one of the best groups ever, like hands down when it comes to just absolute sauce and gravy. I just
By the way,
want to take
whoever
the time to
said
say I
that I'm
appreciate
not a
you
flat
guys.
earther,
Shout out to
you
Alan.
will be. Just give it time. You'll understand.
Oh, I won't be, but especially if we're talking about magic
Oh.
squares.
Well, why
Magic
are you
squares
here?
are, figuring out what's up.
Magic
I
squares have
do.
nothing to do with the shape of the earth.
I'm
it
very
has to
glad
do
for
with
that.
is math. Yeah, it's just a mathematical game that you can
Yes.
play.
Yes, I'm good with that.
Hey, are you scared of being special, bro?
Scared of being special? I'm not special.
So you're scared of it?
I mean, that's not what not means, but that's cool.
Is the idea of being special scary to you?
No.
Oh.
What are the implications?
Yeah.
The implications of being special?
Yeah.
Yeah.
That you're special.
Very profound.
I don't know what other implications there would be for that.
You know what the Copernican principle is?
It's been a minute.
Okay. It's the idea that the Earth doesn't occupy a special or unique position.
Okay.
You're like sitting right beside a fan or something, because that's not very special.
It's the most special. I'm sorry. It's freezing out here. I'm in my garage. It's a heater.
Okay. So yeah, it's like the fundamental idea of cosmology. Right? So like, do you agree that if the Earth, well, okay, let me.
Yeah, hold on
Personal
one second.
question here. You don't have. Go
Can
ahead.
you mute while you or while What's It's talking because your fan's picking up? It's messing with
Yeah,
the
no
audio.
problem. Sorry.
Yep, no worries. Thank you.
So personal question, you don't have to answer, but are you an atheist or like an atheist agnostic or something like that?
Yeah.
Gotcha. So would you agree that if the Earth was in the center of the entire universe, then it was more than likely placed there by something?
No, I would not agree that the Earth was placed anywhere. Doesn't matter where it is, just happenstance.
So you think the Earth could be in the center of the entire universe? The only thing right in the middle, right in the center, and it would just be happenstance.
It would be wild happenstance, but yeah.
Yikes. So
I
I don't
feel as
even
though he
know.
doesn't actually think that.
Yeah, like that doesn't even
I
like
mean, I
compute
personally
to me.
can't divine the thoughts of another man, but something in myself is telling me that you don't actually hold that to be true. I don't know why I had to say that, but that's just the
But
way
give him a
that
chance. I mean, give him a
yeah, that
chance to
whole thing
explain.
just transpired, bro. That I mean, yeah, he can explain, but I'm just saying what I like. I don't know what it is. I just have the strongest urge that that's not your actual
Yeah, that was
like
between Austin and him.
truthful. You
I'm nothing if not truthful. That's that would be wild. What's the word I'm looking for? I guess it would be a huge coincidence, like an immeasurably huge coincidence, but coincidences happen.
That's so weird because like this is one of the most illogical positions ever, right? Like for one, in your idea of the universe, right? Like just the fact that we can live here would be crazy. You would be compounding the ideas of like the fact that you can even there's life here. So what a coincidence that the place right in the middle could sustain life. If you look at the statistical odds of just in your perspective or paradigm of like life existing and surviving on this little dusty rock, combined with things like the sun and the moon just happen to appear to be the same size. It has nothing to do with the fact we can habitate or, like live here, right? That's just merely a coincidence on top of it. So those odds already, right, are like extremely low. And then you're going to put on top of that, just so happens that the one thing that's right in the middle can sustain life. And you think that that would just be a coincidence?
I think it certainly could be a coincidence unless you have something to back up the fact that it's not. If you have some kind of argument that would.
Oh yeah,
The problem with this argument is that you won't ever do the experiment because you don't want to see the truth. So the experiment in this case is where you do a determinism versus a non-deterministic experiment. And to do this, you must leave the self. And most people never do. They always will enter a paradigm of some kind. That's the inherent problem. You must leave the self in order to find truth.
Well, the argument would be simple. The logical argument would be that the antecedent to order is intention, specific intent.
Why would the antecedent to order be intention? Why would it be intention therefore order? What if it was intentionally disorder, or if it was intentionally anything that's not order, that doesn't
What?
that's not cogent?
That's called a non sequitur. That didn't follow what I said at all. We're talking about something that is ordered.
No, you said that the antecedent was because of the order. You're affirming the antecedent, right?
No, the antecedent to order.
Oh, I'm sorry.
Specific intent. So, like, whether or not someone can intentionally create disorder or something would be a non sequitur, but
no, it would not. No, absolutely not.
It quite literally would be, bro.
Yeah,
if the antecedent
if he's talking
to
about a
order.
system that's order, yeah, if he's talking about a system that is ordered, then
Uh-huh.
you would have to speak about that system that is ordered for it to be sequential. for you to go off of the subject and talk about something that is disordered wouldn't be speaking on the subject he brought up.
Well, simply, it doesn't follow that if order requires intent, that intent cannot create disorder. That doesn't follow, right? It's non sequitur. That's what non sequitur means. So anyway,
can you run it by me one more time?
yeah, it doesn't follow to say that if order requires intent, intent therefore cannot create disorder. You can specifically use intention to create disorder, but that doesn't mean that order doesn't require intent. Those
Okay.
are different things.
But it does mean that okay, I follow you. That I why is there nothing with no intent that could not create order? If you have an infinite possibility of things that could possibly happen.
Well, yeah, you can just
Infinite
you can vaguely
possibility
appeal
of things.
you can vaguely appeal to possibility without any like specific logical reasoning, other than like again an appeal to possibility. But that's
Sure,
your own prerogative.
you can disagree with that whole you
Yeah,
can
but and what I have to disagree with is all evidence ever, right? So like just same with information. Like I could say information requires specific intent or intelligent agency, right? And you could
It
say no,
doesn't.
Maybe it doesn't. See,
Yeah, maybe it doesn't.
But I can give you an infinite amount of examples where it specifically does. You can't give me one example, right? That it doesn't,
Sure I
and
can.
so.
But you have to be able to be, what is it, outside of the body or outside of the mind or whatever it was, and accept the possibility that there is no intentionality. And if you accept the possibility that intentionality is not necessary, then yes, absolutely.
If
Not
I
only
accept your conclusion, then you can demonstrate
if
the
you
viability of your conclusion.
in the exact same way that if I accept your conclusion, I can accept the possibility.
But I have evidence of mine.
No, you don't.
Okay, for example, the Encyclopedia Britannica is very specified ordered information, right? It was created via intelligent agency. So like I could give you a million different examples of that. You're claiming, well, that's not necessarily a requirement, but just believe me. But either way, bro, how about this? Let's just boil this all down because you can infinitely regress into appeal to possibility, right? And typically the atheist agnostic does that and then claims intellectual high ground somehow anyway. But what I'm wanting you to just be honest about, do you agree that the odds that this place would have been created are significantly higher if it isn't in the center of the entire universe and it sustains life?
No, I would still stick with you. You would have to have some kind of proof of a creator for that to happen.
Wait. You think that the odds are the same?
Well, the odds will be the same no matter what. The odds that a creator could create a world not in the center of the galaxy or not in the center of the cosmos or whatever would still be the same unless you have some kind of purview into the mind of whatever creator that is.
Okay, that again doesn't follow. You did the same thing where you're like, a creator could put you somewhere other than the center. That is not the point. The point is that if it's in the center, okay, so that's again non sequitur.
It's the exact same. It is the inverse. It's
But it doesn't follow, bro. If I say that order requires specific intent, and then you say, well, intent can create disorder, that doesn't follow. It's non sequitur. If I say
that order requires specific intent, you have to prove that intent doesn't necessitate. Sorry, you have to prove that order cannot occur without intent.
Yeah,
That's
you actually
what
don't
that means.
prove negatives. So what you do is you substantiate positive claims with
You have to
evidence.
prove that there is no other possibility.
That you
Nothing
can
else.
never do that with anything. You could never. That's not how logic works.
Yeah,
prove
that's not a
negatives.
reasonable. That's not reasonable.
It's not a reasonable standard at all. Prove Santa Claus doesn't exist. Beyond
That's
all
basic, though.
reasonable doubt.
No, I am
What
not
Witzit
saying.
what Witzit said is very basic, though. You don't prove negatives. That's like a basic fucking thing. That's not
impossible.
That's not like a cult idea. Yeah, that's not a cult idea, dude. That's very standard and basic. That's like algebra.
But either way, bro, what I'm understanding is like, let's just put like there, if the Earth is a tiny speck of dust in an ever expanding, if the Earth is a tiny speck of dust in an ever expanding universe of nothingness, okay, and then by random happenstance, it can sustain life tucked away in this insignificant corner, and then lightning struck primordial soup, and we'll skip over irreducible complexity and whatever. And just so happen we're the right distance from the sun to be in the Goldilocks zone so that we can sustain life. And just so happen, and completely irrelevant coincidence that the sun and the moon appear to be the same size, and blah, 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 blah. A list goes on and on and on. All observations make it look like we're in the center, even though we're not, whatever, right? But like the Earth just being this tiny speck of dust tucked away in an insignificant corner in this huge universe of at least 46 billion light years in diameter, right? Like, or actually more than that, I guess. But anyway, that the odds of that randomly happening are much higher than it being directly in the center of the entire universe and sustaining life. Obviously, the odds are higher, right? You have a higher statistical probability of randomized outcome in the first situation, right? I mean, that's just like basic stuff, bro. Like, no one in the history of mankind or philosophy or astronomy or astrophysics or cosmology would ever disagree with that. I mean, that's actually what the Copernican principle is. It literally says the Earth does not occupy a special or unique position. Special and unique answer this question. If it's special and unique, then it's statistically more likely that it could be random if it's not special or unique, right?
I lost you there for a second. If it's not just the last sentence you had.
If the Earth is not if it's not special or unique, then it's statistically more likely to be. It could be random.
If it's not special or unique, it's statistically more likely that it would be random.
Yes.
I mean, yeah, I guess sure.
Okay, so therefore, it logically follows that if it is special and unique, then it is less likely to be random.
The problem with these types of experiments, when we're talking determinism versus non-determinism or intention versus non-intention, is being able to trust the person who does the experiment. I'm the person who's like, I'm literally Illuminati, which is number one rule: trust nobody, trust only knowledge from within, right? So I'm the kind of guy I had to do the experiment myself. That's me. If you don't test the experiment yourself and you instead want to like listen to me or to anybody else who's done 20 reps, like I explained, 20 reps of determinism versus 20 reps of non-determinism, right? Well, is that enough? Yeah, of course, for me, maybe it's enough, but for somebody else who did 1,000 reps and 1,000 reps, they might be looking at me and thinking like, oh, that's what the fuck this guy talking about? He only did 20 reps, whatnot, and he's a fool. He doesn't know what the fuck he's talking about, right? So I don't know. That's where you started out.
I have a
Right,
question.
like,
Good example.
I am
A very
We were right at the crux of the entire thing, right? We were right at the crux of the entire thing. We've walked through the logic of how one is more likely to be random, therefore the inverse is true, right? So it's less likely to be random if it has a special and unique position, right?
Yeah, like if you were to come across an encyclopedia and it was just sitting there, would it be less likely, in your opinion, that that somebody had created that encyclopedia, or would it be less likely that it had just arose there by like a storm coming by and assembling the pages and the ink on the pages and everything perfectly in perfect order to produce the encyclopedia? Would you say it was more likely that the encyclopedia was created, or more likely that the encyclopedia just arose upon random events?
Well, in that case, we have examples of encyclopedias. We know that encyclopedias are written. You would
all examples of ordered information are from being created. Can you list one example of ordered information without it being created?
Can you Give me a definition of what I'm aiming for with ordered information.
Information that's and like such as an encyclopedia, such as any information that's in a set order.
Sequential conveyance of knowledge. You know, what is interesting or data, but like, just to answer his question, bro. If I take the world's most complex watch, and it has like 5,000 little bitty pieces and little bitty screws and quartz crystals and all this stuff, right? And I throw it in a mason jar and I just start shaking it, right? Your idea is that eventually it can create the world's most complex watch randomly, right? And to me, that's asinine, but whatever. But obviously, even if you held that to be true, which is the idea of chaos theory, which is retarded, but let's say it's not retarded. Okay, it's obviously more likely if you walk upon the world's most complicated watch that a watchmaker made it. That's significantly more likely than if it was just randomly shook up in a mason jar. Right. So like it's just a simple concept that obviously basically the odds of randomness are inversely proportionate to complexity in order. I'm not trying to make it more complicated. It seems simple, bro, right? Like, can we just get to that point so then I can ask the follow-up that's important? Like, it obviously, if something is more ordered, if the Earth was in the center of the entire universe, it would be less likely to randomly be there and sustain life. There's no other position like it. It's the only thing in the center of the entire universe. There's only one center, special and specifically unique. Nothing else is like it. And just so happens that that position has a place that sustains life, the only place we know of that can do that. The odds of that randomly happening are much less than, just a random position that isn't special. There's like a trillion different positions just like it, blah, 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 right?
But we do have examples. We have places in the universe that we're fairly sure, like pretty sure, can sustain life. This is not the only position.
That wasn't the point.
Dude, do you like
that is the point.
Are you afraid of the implications or something? If the Earth is the only thing in the center, it is less likely to be random than for it to hold an insignificant position where there are billions of said positions. If there's only one position that is in the center and it occupies that, right, it's less likely to be random than it to be in a position that there are like billions of the same type of position.
Except that we have examples of these other positions. That's the problem that I have
There's
here.
only one center. There can't be multiple centers.
We're not in the center.
That isn't the
how
point.
this works.
You're so lost, bro. It's about
hypothetical, my man.
Dude, exactly. If the Earth were in the center, it would occupy the only center. Therefore, it would be less likely to be random than occupying an insignificant position.
It would be exactly as likely to be. It would be exactly as likely. Every point has this same possibility of being the location of the Earth. We'll call it that way.
It is
Now,
the
you have
most logically bankrupt thing I've ever heard in my life.
that is absolutely not. Shuffle a deck of cards. What are the odds that the first card is an ace? It is 1 in 50 or 1 in 13. Period.
Let's use the analogy of a card. We have a 20,000 square foot house. We have a deck of cards, and we're going to pull the ace of spades out, and we're going to put it on the top. Now we're going to just chunk the cards. There's one little bitty X in the center of that 30,000 square foot house. We're going to just chunk the cards. We're going to fly over. It has no roof. Drop it out of a helicopter. Let the cards fall. Okay. Are the odds greater that or less, right, that the card falls right on that X in the middle or any other position around it?
Any other position around it is more likely.
Thank you. Okay, so if the Earth were in the center of the entire universe, it is less likely that it would be random.
It is less likely for it to be there. It is not less likely for it to be random. It's less likely for it to be there. That is what random is, guys.
Dude, I kinda
random
get where
is random.
is coming from.
Now
that I've heard him say it that way, I get it. I get his point.
Please explain.
Yeah, please enlighten me, man.
He's saying, well, the way he's looking at it is essentially if you guys were playing what is that game where you play like bingo or whatever, where they do the ball in the cage and the cage comes out. He's essentially saying that like y'all pulled the Earth ball out, right? And y'all are saying like, yo, what are the odds that I got the Earth ball out of the cage? And he's saying, well, the odds of you getting the Earth ball was the same as any of the other balls in the cage.
Yeah, but that's not the
essentially.
question.
Is that a
That's
steel
not the,
man?
but that's not the question, though, right? The question is if there are 1,000 balls, right, and there's one that's an Earth ball, are the odds greater that you pull the Earth ball or any of the other balls?
Any of the other balls for sure, but the
Thank
fact
you.
that the fact that one of those other balls is the center of the universe, that is an independent
No,
uh,
the
pull.
center of the universe is the Earth ball, bro.
No, the
Hey,
Earth ball is the Earth ball. The
no.
center
Oh
of
my
the
God, you're going.
universe is like so.
Talking about a for your sake, he's going in a hypothetical, bro. Yeah, he's just saying if the Earth was in the center of the universe, there's only one center.
Mhm.
Wouldn't it be more likely for it to be not in the center, right? But if it
Yeah,
is in the
it's
center,
just like so basic, bro. If
yeah,
there's a billion pennies and
Mhm.
only one of them has a X on it, the odds are way greater. I'm gonna pull a penny without an X on it, bro.
Yes.
The X is the center. There's only one of them. There's only one penny with an X on it. There's only one center. The odds are much greater that you wouldn't pull a penny with the X on it.
Yes, the odds are much greater that you would be anywhere else. The odds of that being the random location are the same.
Bro, how are you conflating? Like, I don't see how this is
So
even possible.
to try to even draw out the analogy more, it would be like if I then picked out the penny with the X in it multiple times in a row, right? The odds are that the person knows how to grab the penny with the X on it. And those numbers, the odds that he knows how to do it increases with each time he pulls it. Anyway, this is just insane.
You lost me on that one.
It doesn't matter. We've agreed that if there's 1,000 pennies, there's one penny with an X on it. You're much more likely to pull a penny without an X on it. Okay, the X is the center. Okay, the odds that the Earth would be in the center is much less likely when you have a quadrillion options other than that would put it somewhere other than the center. Obviously, if it's in the direct center of everything, that would be a special and unique position, which is literally what the Copernican principle is about. Is that the Earth doesn't occupy a special or unique position. Right? That's based on the inverse being true. It was originally thought to be in the center. So then they moved to heliocentrism. Then they moved to this Big Bang cosmology, right? And the idea is the Earth is not special. Okay, so here's my point. Whether or not you think it's still possible or viable that the Earth could be in the very center of all existence and sustain life randomly, whatever, right? Like, would that not make you would that make you step back and at least re-examine the possibility that it was placed there?
Like I said, you have to, if that's the angle that you're going at, you have to prove there's a thing, or you have to give me some evidence that that's a thing that could happen, that there is a creator that could place something there.
This is just a subjective question, bro. If you were to find out that the Earth were in the center of the entire universe, would that make you step back and at least reconsider the possibility that it could have been placed there?
No.
It wouldn't even make you reconsider it at all.
No, those are mutually exclusive claims.
he said
Alright,
no,
bro.
don't bother, bro. It's
Yeah, it's like that's one of those situations
try
where
it.
it's like, I mean, you may just not be able to, yeah.
Now, if you have some proof that that mutually exclusive claim is true, or some evidence for it, or any kind of argument for it, anything like that,
yeah,
then I'll consider that.
I can debunk atheism in my
false.
sleep, bro. It's not the
Bro,
point.
you just
Take
said
a
that
nap
it
and
wouldn't
prove me
matter
wrong.
if it was in the center. You just
Well,
said it wouldn't matter if it was in the center, and then you said if you give me proof, though, I would like the proof. Why would you
I
want
mean,
the
no,
proof
he's
if it doesn't?
saying
Yo,
proof
Wit.
that some type of creator would have placed it there. What's up?
Or evidence,
Yo, Wit,
argument.
I think this guy is not even ready for the stationary talk. I think you need to just go straight for the
I think
Atheist.
he might be trolling with
Yeah, let me
sophistry.
try.
I think you
Everyone,
should just go straight for the atheism.
yeah,
That's what I
yeah.
think is
If the room will
the
be patient with me, give me a couple minutes. We'll do the atheist thing. Okay, so like, would you identify as like a naturalist? Do you know what the philosophy of naturalism is?
That all things are natural.
Yeah, that basically everything is within the natural world.
Yeah,
Right,
there
like
is no
all,
supernatural. Yeah, I'm fine
yeah,
with that.
all that is. Okay. So it's the idea that the universe is governed by natural laws and forces, not supernatural ones. Okay. So that you would identify as that being your philosophy?
Yes, sir. Sorry,
Okay, cool.
I'm like juggling mic muting and turning on the heater again.
You're good. You're good. So, all right. Then the things that do govern the universe would be natural laws, right? And not supernatural ones. So there are two very famous natural laws that we're going to talk about. Okay. The first one is the first law of thermodynamics. And the second one is the second law of thermodynamics. Okay. Do you know what the first one is? It's not a big deal if you don't.
Matter cannot be created or destroyed.
That's right. Matter or energy cannot be created nor destroyed. Okay. So we're naturalists, right? So we have to adhere to natural laws. Natural laws are not theories that people came up with or anything, right? It's just something that always happens all the time. It's observation. It doesn't even propose a cause claim at all, right? It's just an observation. It's natural law. Okay. So if matter and energy cannot be created nor destroyed, now we know we have matter and energy in the universe. Okay. So we have two options. Option A is it was always here. Or option B is it came from outside of this material natural universe, right? Because if it can't be created or destroyed inside of this universe, then the only options we have is either it wasn't created or destroyed, it was just always here perpetually, or it came from outside of this universe. Do you agree?
In naturalism, where we have no supernatural, we have no outside of the universe.
Do you agree that's the only two logical options? If matter and energy cannot be created or destroyed, either it was just always here, or it came from somewhere outside of here because it can't be created here.
What do we mean by outside of here?
Outside this material natural world that adheres to natural law.
Then no, definitionally, if I'm a naturalist and
We
I have
know.
if I have a belief that everything arises from natural property
Right.
or natural, causes,
Correct.
that supernatural things are discounted,
Yes.
then no, as a
I'm not
naturalist, you cannot have that second
Right.
premise.
Right. Well, I'm not asking you if you believe one of those two. I'm asking you if you understand that those are the only two options.
No, I'm saying the second option is a non-option in
It's a
naturalism.
non-option for you, but
No,
we're
it's a
talking about.
non-option in naturalism, not for
We're
me,
just talking.
in naturalism.
Okay, this is so ridiculous. We're just talking about logic. Anyway,
Okay,
logically
so let's
speaking,
talk about logic
logically-
real quick. So naturalism, the philosophical belief, everything arises from natural causes and there are no supernatural explanations, everything is discounted. How do we get to a supernatural premise?
We're not even there yet. Look, okay,
You
so
just
I
gave
gave
me
you,
a supernatural premise.
buddy, listen. I gave you two options. I didn't.
And
Okay, I gave you
one of them
listen.
was supernatural. Go on.
Bro, you're not listening. Okay, we get that you reject the second one. That's why this is gonna suck so bad for you in like 5 minutes. Okay, so
that's
just
fine.
stop getting ahead of yourself. The point is that leaves you with one option. Unless you can claim that that's a false dichotomy of logic and offer a third viable option, then you're stuck with one option, right?
Okay.
So then you are now you've boiled yourself down to the idea that the energy and matter in the universe has always been here.
Sure.
Okay. Now we're going to go to the second law of thermodynamics. Right? The second law is that in natural systems, entropy always increases. It never decreases.
In closed system.
No. Okay. It's natural systems. So now we're going to apply that to the universe. What that means is that the amount of usable energy is decreasing. Okay. So
Oh, okay.
entropy is always increasing, so the amount of usable energy in the universe is always decreasing. Now, this gives us a couple issues here. One is, well, eventually, then the usable energy would run out. But the most obvious issue here is that is in direct conflict with the idea that the energy was perpetually here, because a progressive decrease or increase denotes a beginning. So not only do you run into the issue of it ending, obviously in conflict with the idea of something being perpetual, but it denotes a beginning, right? And I can quote some of the most famous people, some of the most famous atheists, cosmologists, etc., right? Explaining this, Arthur Eddington, Stephen Hawking, etc. So this used to be debated until we started making more intricate observations of natural law, etc. And now we're stuck with the universe having a beginning. This is why the Big Bang is accepted across the board of, modern cosmology and atheism. Okay. Big Bang denotes a beginning, of course. So now we're going to go back and visit the first point, right? Because we looked at the first law of thermodynamics and we're like, oh, well, matter and energy must be here, always have been here perpetually. Now we've applied the second law and entropy is increasing, never decreasing. The amount of usable energy is decreasing. Therefore, it denotes a beginning. So we cannot say that the matter and energy has always been here, because now we're stuck with a position where it had a beginning.
Why does entropy denote a beginning?
I just explained it.
I lost you. You said because entropy is increasing, that denotes a beginning.
Yeah, because the amount of usable energy is decreasing.
Why does that denote a beginning?
Because it had to start from somewhere.
Yeah, let me read. What I'll do is I'll read Stephen Hawking's quote about it. Maybe that'll resonate with you more. But okay, so and it's just like it's the analogy he uses is like human progression, right? The idea of evolution or the human progression. Well, if there's human progression, then it's progressing from somewhere. As you track that back, it has a beginning stage to progress from.
Okay, sure.
Okay. All right, so let's read my boy Stephen Hawking here. And you can see that we're running into an issue right now, right? Look, I'll read it. The argument about
yeah.
Oh, okay. The argument about whether or not the universe had a beginning persisted into the 19th and 20th centuries. It was conducted mainly on the basis of theology and philosophy, with little consideration of observational evidence. This may have been reasonable given the notoriously unreliable character of cosmological observations until fairly recent. The cosmologist Sir Arthur Eddington, from, of course, the famous Eddington experiment that supposedly verified relativity, even though it didn't, it's all a lie, once said, "Don't worry if your theory doesn't agree with the observations, because they are probably wrong. But if your theory disagrees with the second law of thermodynamics, it is in bad trouble. In fact, the theory that the universe has existed forever is in serious difficulty with the second law of thermodynamics. The second law states that disorder always increases with time. Like the argument about human progress, it indicates that there must have been a beginning." Stephen Hawking. Okay.
Can I address that question?
I see. That's where he's full of shit, though, because there doesn't have to be a beginning. It can just always have been, always is, and ever will be.
That's not rational, because then we would have crossed an infinite amount of time.
Well, you have to, you can't just baselessly assert the conclusion, right? The argument is that if the amount of usable energy is decreasing in a progressive fashion, then it is progressing from a starting point, or it wouldn't be progressive.
I agree though that entropy right? And this idea of gradual decline is just an assumption.
That's
That
atrophy.
the idea that that's always been happening is it's a presupposition.
Okay. For one, that is atrophy. Decay is atrophy. And we're talking about a naturalist philosophy, which means that the only things that govern existence is natural law, specifically nothing supernatural, right?
Can I address that question, please?
Mm-hmm. Go ahead.
Or is my audio that bad? Is it normal? What's the full wording of the first law of thermodynamics?
Are you suggesting that matter and energy can be created?
No, I'm just asking you, do you know, you're right, that first part is right, but what's the next sentence?
What do you mean? What's the next sentence?
Right. Matter and energy cannot be created or destroyed, but it
Only
can be
transferred.
converted. It can be converted from one form to another.
That's
We
not
know.
non sequitur.
Well, you can. All right. Well, you can say that. We know that we can convert matter into energy and energy into matter because we have nuclear bombs. So you've got to consider the second part of the first law as well as just the first law. So there's not two options, there's three options.
No, but that isn't that's non sequitur, because even if the matter and energy are transferring back and forth, that doesn't answer the question of how it got here. And so
No, it
the
doesn't.
answer has
But
to
it,
be that it was perpetually here in one state or the other.
but it means that there's no fuel tank to run out of. It's just a balance of matter and energy in the universe.
Okay, cool. Like I said, the only two options applying the first law is that either this matter and energy came from somewhere outside the material and natural universe, or option B is that it was always here.
It's
So,
always here.
okay,
And it
cool.
can be always here.
Well, we've just proven that's not true by applying the second law of thermodynamics, which is one of the most bulletproof, unquestionable natural laws that exists. It's not even up for
Not to
debate.
me. Not to me.
The second law just says that the
Maybe
number, the
I
total
don't care
number
what it
of
is
energy
to you. If you have
in a
actual
closed system.
evidence of it, then that's one
I don't need to
thing.
have evidence. The world has evidence.
Name one piece of evidence that's contrary to the
No,
second
go
law.
find it and go look. I'm not
Yeah,
that
so you
guy.
got you got nothing. You got nothing. So
No, I do. I'm just not the guy who feeds energy to a person who's, wanting a certain outcome.
no, you can't even name one thing, and that's just a fact. So in reality, we do not observe anything in the natural world that defies the second law of thermodynamics. It's well known that any attempt to explain
Well, we
something in
do.
terms of physics going contrary
actually
to
do.
that is just a futile pursuit destined to oblivion. If you have a
Well,
specific
no, the physics is going to say that it's something different. The person, you and me, being the observer of the experiment, we're going to say this is definitely working because we can see it working. But the physics will say otherwise.
Do you have an example?
Yeah, it's called orgone.
It's called what?
Orgone.
What is that?
Yeah, what is that?
Not something that defies the
That's
second
you have
law.
not looked hard enough if you don't know what orgone is.
Why don't you
You're-
explain it, dude?
Yeah. I mean, you're claiming it defies the second law.
Yeah,
I'm very curious. I'm very curious about this orgone.
Okay, here, I just looked it up. It's
I would
it's
want to
now
know about it.
now we know
if you
Google.
look it up, you're gonna literally look at the first one or two or three links that are gonna say it's pseudoscience. Okay, and I'm here to tell you that I've done the experiment and it's not pseudoscience.
But you're arguing for something metaphysical. It's like you're not actually following the conversation. You just want to like you just want to you just want you just want to conversation rape us, dude.
If the energy is coming from, then you can't patent it because they want to know where it's coming from.
Oh,
Okay, dude,
okay,
that's totally
dude.
not the subject at hand.
What's the
You're trying to
example?
fucking talk to
Say like, oh, it's coming from
rehabilitation.
ether or it's coming from radio waves or whatever.
Listen, dude.
Jesus, bro. Okay, first of all, this is what he did earlier. We were talking about the center discussion, and you just jumped in talking about you have to leave your body and only you can understand it, and then something about doing it 20 times or 1,000 times. And we get it, dude. You're proud to be quote unquote Illuminati. You think Luciferianism is cool. Like But
was gonna
isn't the
ask that. Is
discussion?
that what he said earlier? But I didn't want to
Yes, but
interrupt.
that's just,
Oh,
and I don't even care. It's just not even the discussion. You're basically conversation raping us, bro. Like like, can we just finish the conversation?
You guys don't know what orgone is, so
Yeah,
it's,
but
It's a concept variously described as an esoteric inner. Holy fuck!
It's
And then
not
we're gonna let
esoteric
him
because it
derail the
means that
conversation. What a joke!
let me try to
Everybody.
bridge the gap. Let me try to bridge the gap between you two.
One at a
real
time.
quick. Yeah, so essentially we're talking about the first and second laws of thermodynamics and how it either gives us a start and end date for the universe, or is the universe perpetually evolving. This man had a disagreement with the second law of thermodynamics. When asked the first time, he didn't actually want to give an example. But then he came around, he actually was going to give us some sort of Oregon example of an experiment. And I say, if he could keep it on the subject, give the example briefly, maybe we discuss it, and then go back to the subject at hand. That would be fair. I don't know.
Okay, but the
Let's hear
reason
him
it's not
talk.
fair though is because I just addressed he's invoking a concept of something metaphysical. Okay, which means that it isn't within naturalism. He's not a naturalist. He doesn't say that only things within the material natural world exist and that everything adheres to natural law. I agree with them, but we were discussing atheism with the atheist who is a naturalist, right? So that's the problem. It's quite literally not what we're discussing.
we're in a
It's
naturalist frame of reference for this conversation.
and I was, and what's funny, before you interrupted me, Pro, too, I was gonna say Google says it's pseudoscientific. We know how that goes. They claim everything is pseudoscience. There may be something true to it. It says it's a concept variously described as an esoteric energy or hypothetical universal life force. And anyone that acknowledges the metaphysical would probably agree with you. Nikola Tesla said there's a life-giving force called the prana. It's an ancient concept that there is a life force outside of the material world. Right? You're this assumption that you have superior knowledge to everyone here, and blah blah blah. But is the atheist still here?
Yeah, he's showing.
Yeah, I'm still here. I was taking the opportunity to heat up my garage, so I appreciate
there you
the.
go. If he wants more conversation, go for it, you guys.
And you're using the second law, by the way. So, like, I guess my point is, I just want to see if you understand the connection here, which is like, as a naturalist, we have to adhere to natural law, right? Because like we think that that's basically all that dictates existence. And so then when we apply the first law, well, energy and matter must have been here perpetually. But then when we apply the second law, right, it denotes the amount of usable energy decrease and entropy always increasing, disorder increasing. Therefore, it's progressing from some point. Just like human progression, like if you believed in evolution, for example, like, well, there still was a starting point to progress from. You can't, if you were to track back progression, you couldn't just like infinitely regress, right? You couldn't go into infinity constantly regressing. It just isn't logical. Like if it's progressing from a starting point.
I agree with most of that. I'm fine with, starting point, singularity, Big Bang. I'm fine with all that. Now, that's as far back as we can look, and that's where understanding breaks down.
Right. So now, if we denote a beginning, like the singularity or the Big Bang,
sure.
Right, we have a beginning. Now, when we go back and revisit the first question, right, we can no longer say that the matter and energy was always here perpetually because we just invoked a beginning.
Yeah, that's when we say we don't know after that, or
well,
prior to that.
What logical people do is continue going and not just tapping out when it goes against bias, right? So, like now applying logic, the matter and energy could not have perpetually been here because there was a beginning. So now what was the second option on the table that you had an aversion to? It was that there was an external source of the matter and energy. Now the naturalist, unless they say what you just said, which is I'm tapping out, we just don't know. If the naturalist actually answers the question applying logic and their own worldview with natural laws, then literally the atheist must now invoke an external supernatural source well, this is the reason why. The definition of supernatural is something that is not limited to natural law. Well, of course, if something can create matter and energy, it isn't limited to the first law of thermodynamics, which would mean by definition, the etymology of it would be supernatural, right?
Per your, example there, yes, if there's some kind of source from outside the universe, but we don't have any reason to come to that conclusion. Like, that's where the understanding breaks down. So at that point, that's where you say, this is where my understanding breaks down. It could be something supernatural. That's a perfectly viable option logically, but it could also be something natural that adheres to different laws of nature before that point, or prior to that point, or it gets weird talking before because that's
Okay. Okay, but so you said something before that point. So it would obviously be external, right? Because it would be
no.
before the singularity.
It-
That would be external to this material universe.
No, it would be external to this. What am I looking for? This presentation of the laws of nature.
Okay, well, that was a different. It's a different subject, but it's getting worse, right? Because again, the definition of supernatural is it's attributed to a force beyond the laws of nature, right? And the etymology of supernatural, it literally comes from the Latin meaning beyond nature. And the
So
laws
we
of
can-
nature are called natural laws. If something is, you're claiming that there's a time period before the singularity that didn't adhere to natural laws as we know it, then as we know it by definition, that would be classified as supernatural, right?
As long as that's the definition we're going to stick with, and we're not going to, swap it around, because the issue is not that this is necessarily something that comes from outside of the universe. The issue is that's where our understanding of natural law breaks down. That's where the natural laws that came, prior, like worldline prior to that point, could have been different. Could be completely different, could be the same, who knows? Like, that's where the understanding breaks down. Everything past that is just purely, I don't know.
Okay, so I mean, now I've taken enough of the mic. I'm just going to repeat what has happened, right? Which is naturalism is a philosophy that all that exists adheres to natural law. It's only what's in the natural world, the physical, material world, right? It's akin to materialism. All that exists is material or comes from material or some version of. The idea that matter and energy can be transferred back and forth from state to state brings us into the first law of thermodynamics, which is one of the most famous natural laws ever. The idea that matter and energy cannot be created or destroyed. As a naturalist, you have to adhere to natural laws. That's the entire point, right? And so that gives us two options. One is that the matter and energy in the universe was perpetually here. Or option two is that it was created. Well, obviously, it can't be created within this natural world because that would defy natural law and therefore defy the philosophy of naturalism. So it would have to be external, some external source that doesn't adhere to that natural law, which would by definition be supernatural, which is defined as beyond nature or the limitations of natural law, attributed to some force beyond natural law, right? Now we could say it was perpetually here, but then we looked at the second law and we see that entropy is always increasing in a natural system, right? And some people throw around the word isolated system. There are no isolated systems in nature. That's an idealized concept. In a natural or spontaneous system, entropy always increases. It never decreases. Therefore, disorder increases. Therefore, usable energy decreases. In very, very simple layman terms, and I'm wrapping this all up, sorry, but simple layman terms would be that process of seeking equilibrium or entropy increasing is utilizing energy. Therefore, the usable energy is decreasing proportionate to that entropic pursuit, right? So now that we have a progression, well, that denotes a beginning. So now we invoke the idea of a singularity or a Big Bang. And then we go back to the first one. The matter and energy could not have perpetually been here. So now the atheist must invoke something that by definition is supernatural, meaning it isn't limited to the current laws of nature as we understand them. It was external, meaning it's not inside of this natural world, because naturalism denotes that everything must adhere to the natural laws. So an external, eternal, meaning because it's not limited to space, time, and matter as we know it. So something external, eternal, supernatural was actually the source that created the matter and energy that we observe in the universe. So that sounds like a god to me.
It does, because you're bad at definitions. The issue, the problem is you
Bad at
smuggled in
definitions,
something
dude.
there. You smuggled in created. At the very beginning, prior to singularity, well, I'll go with prior to. That's fine. You smuggled in created. That energy had to be created from somewhere. Had to come from somewhere outside of the natural universe. That's not the case. That there is no logical entailment that would necessitate that energy being created from somewhere else or coming from outside of the universe. What happened at the singularity there, have no idea. That is where our understanding of natural law breaks down. Like, once you go past that point, nobody has any idea. I mean, people may have ideas, but no good ones. So anything prior to that point is something, and I don't know what it is, and you don't know what it is, and none of us know what it is.
Well, a simpler way to say what Witzit is saying is that naturalism doesn't provide a plausible explanation for the beginning of the universe.
You are absolutely correct.
Okay, so I mean, therefore, it isn't even a viable philosophical framework or etymological approach or ontological perspective. And
It's
I
the
will just
only
say,
honest one.
I didn't smuggle create in. It was one of the first words I said because I defined the first law, which is that matter cannot be created nor destroyed. We actually, the entire conversation was engineered around that concept of can matter and energy be created? And if it can't be created, how did it get here? We showed that it couldn't just have perpetually been here because there's a beginning. Now that leaves us with it being created. I didn't smuggle that in.
That's
it just
fair.
makes it uncomfortable to say that there's an external, eternal, supernatural force that's not limited to natural law, space, time, or matter that created the matter and energy we perceive. Because when you say all of those things together, which we just broke them down piece by piece, it clearly sounds like a god. And so the atheist kind of sits there with no leg to stand on or no like philosophical value to input. Like basically you can't sit at the table of the discussion rather than to throw your hands up and say, I don't know. And, I mean, that doesn't really cut it, frankly, with no disrespect, but I'm not claiming to know. I'm not claiming to know all the answers.
Though, is that we don't
Oh,
know.
lordy.
The honest truth to the matter is that we don't know where the energy is coming from, and that's why we can't patent the machine that violates the law, you see, because to receive the patent you must know how it works.
Well, I'm not claiming to I'm not even making a claim about a creator or who he or she is or anything like that. I'm not claiming personable benevolence. I'm simply claiming the antecedent to what is observed, right? Like that there's an external source that isn't limited by the laws of nature. And what you're invoking says the same thing. If it violates the second law of thermodynamics, it's by definition supernatural, it's metaphysical. This is all that I'm saying. So yeah, I agree that no one can know for sure exactly what it was, but we can know what it is not. We can know characteristics of what it must be, right?
Well,
And with it, real
can't.
quick, if you guys don't mind, and me asking a question is okay, the Big Bang, the singularity, what was it in? If it created the universe and created everything, created space, what was the singularity like hung in? Like, where was it at?
What did it expand into if there was no space to expand? Yeah.
I don't understand. It makes no sense to me.
No one understands.
Right.
What's it still expanding into? Because they claim it's still expanding faster than the speed of light. So what? First of all, how is it expanding faster than the speed of light? And second of all, what is it expanding into?
What did it
Yeah.
expand into? Like, where did it start? What?
If there's no space, then what was it sitting within and what did it expand into? Yeah, there is no answer.
It didn't even have a place to be in, a medium or any kind of thing. Huh?
Well, if something's expanding, it's expanding from a starting point.
And into something, right? Like the antecedent to expansion is space.
Very point. How did it start? What was it in?
Well, they don't even claim there's a center either. Their starting point is that's a misnomer in terms of Big Bang cosmology as well. There is no center of the universe. They claim it's
Well,
expanding everywhere.
that's another contradiction, right? Like first it wasn't like
Exactly.
that, right? Because if there was a singularity, meaning an infinitesimally small point that can't even be understood or conceived of, right? Like you can't even apply any relativity equations to it or anything, right? It's just a concept. If there was an infinitesimally small point called a singularity and everything expanded out from that point, then there is a center, right? But now that we've made the observations in cosmology that we have, they have to say there is no center. So then they just claim, well, there was a singularity, everything expanded from that point, but there's no center, whatever that means.
I haven't
But they'll
heard the
still
no
use
center
the
thing.
balloon. They'll still use the expanding balloon analogy, even though a balloon has a center. So there is no way to even visualize what the argument of the Big Bang cosmology is. There's no way. It is it's contradictory to everything that you could ever explain. It's nonsensical. Yeah.
I'm sorry. I mean, I'm not trying to put anybody's beliefs down, but I mean, this is the one for me that goes, this makes no sense. Even when you go to church, no matter how you look at this, and you know what viewpoint you have on it, it goes back to it makes zero sense, right? A singularity that's sitting from where? It starts from where? It doesn't make any sense, y'all. I don't understand why people will have faith in this, but they won't have faith in a higher power creator being or something, right? But they can have faith in a system of this that makes zero sense.
Well, it's bias, yes, philosophical bias. But the same reason that geocentrism is not considered. Philosophical bias is very dangerous. I mean, this applies to religious people as well, right? So.
So
Well, I think
in on that conversation you guys were having, but for me in my head, I'm breaking it down, going, you guys just sit and go back and forth about natural, not natural. But what is this person even thinking that it's sitting in? Like already in a universe, this little singularity or something? Like you have to like vision this. And if you're trying to imagine this, how are you imagining it? Even in your own head.
They're not.
Yeah, rehabilitation, man. Can we get an answer to that, please? Just obviously we're not trying to attack you or anything, but
Yeah,
just
no.
what go ahead if you wouldn't mind addressing that. I'm actually very interested in your opinion on that.
Yeah, the first off, I know there was a bunch of chat and stuff. There's a bunch of chat and stuff going back and forth. I just want to make sure Witsit heard me. Like, I apologize. I retract the smuggling in. You are right.
No, yeah, no worries.
Okay. As far as the center of the universe thing, I think
Well, just
that
address what is it expanding into first. How about that? Because like she had just alluded to, look, when you're saying that it began in a singularity and there was nothing but that singularity, they say it was like smaller than the head of a pin or whatever, and then within a couple microseconds it expanded bigger than yada yada. You know the story. So what did it expand into, and what was it in? So you're
two Big Bangs now.
From a naturalist, you define yourself as a naturalist, even though I would argue that Witsit just showed you that you can't be a naturalist. It's impossible because it's a violation of basic logic. But even just from your viewpoint, what did the Big Bang? What exactly happened as it expanded? What was it expanding into?
I don't think it was expanding into anything. It's the thing that's expanding. The now expanding from. I don't think I've heard the expanding from nowhere thing. To my knowledge, this is the first time I've heard that.
Place to be in, you know what I mean? Like this singularity has no space to even be in to expand into, because
they say that the universe is still expanding. So it's what is on the other side of the universe. If it's still expanding, that means the space is getting larger inside of the universe, which means like what is it expanding into in your mind?
The expanding into thing is what gets me. I don't really understand the. I mean, like I get the idea, the thought concept, I guess, that you have to have a place for the thing to expand into, but the universe itself is the place that's expanding. The balloon thing works pretty well, I feel like. Obviously the balloon, when it's deflated, is not a singularity. It's not that collapsed. But if you inflate that balloon, it expands, it goes out. As far as the center of the universe, like, I think the issue there is it's not like a spherical expansion. I don't think that the expansion's uniform in all directions, but it probably is. I'm not a cosmologist. But
You're
the
not
expanding,
a cosmologist, but you're letting them build your entire worldview, right? So
yeah,
they're
because I
telling you
don't.
where you are and you're believing them. So why would you believe them if you
I'm,
can't even visualize what they're saying?
No, I can visualize what they're saying. I mean, at least my understanding of it. You start with singularity expands.
Well, let's take the balloon analogy, right? With the balloon, I can visualize what's happening with the balloon because I know that the balloon, as I blow air into it, is expanding into the air outside of it. There's stuff outside of the balloon. If I'm in a room, it's taking up more space in the room, right? If I blow it up even bigger, say it gets bigger than the room, there's air outside of my house. It can blow out the windows, and there's always space for it to expand into, right? In the balloon, there's a central point in the balloon. So I could, if you ask me, where's that? Hey, look at all the dots on the outside of the balloon. They're growing apart from each other equally. I could say, yeah, but there's a central position. And I can tell you exactly, we could measure it and find exactly where the central position is of that balloon. You don't have those attributes in your visualization of your universe. Your universe is expanding into, you just said the question doesn't even make sense because you don't have an answer. And then as far as the center goes, you said, well, I don't really know about the center either, even though, so the balloon analogy is not comparable in the least bit for you. So how are you visualizing your representation of reality?
In the same way, say you imagine a dog-shaped balloon. It's a dachshund shaped balloon, and you're blowing it up. It's not uniform in all directions. You would be a lot harder pressed to come up with a central point of the wiener dog balloon, right?
It would still be you could still come up with a central point, though.
Sure,
I mean,
but
you could still.
You could probably
But
come up with multiple central points, on different axes and that sort of thing. And I'm not super like keen on the shape of the universe or the size of the universe. I think I've heard something about uniform expansion in all directions. I've heard no, that can't be right because that's the whole cosmological problem is ununiform expansion. Or at least
expanding into though. Like you're talking
the
about it expanding into what?
nothing. It is not expanding into something. Is my understanding. It's just getting bigger and bigger and bigger.
Nothing cannot exist, bro.
Yeah, that's true.
And nothing is an abstract concept that only exists in our minds. So if you're saying that it expands into nothing, what does that even mean?
That doesn't mean anything. It is expanding.
Think of
It
everything
doesn't
is
need
the
a
surface
thing
of the
to
balloon.
expand into.
But see that's where I'm confused here because he just explained it perfectly to me like a balloon. You blow it up, you can see right that it's inside of like a room and it's expanding into that room until it fills that room. I'm trying to figure out what the heck this thing singularity was in that it's expanding into and becoming bigger and bigger and bigger in space and everything. What did it expand into?
Yes, think that the entire universe is the surface of the balloon only. There's nothing outside the balloon and there's nothing inside the balloon. The universe is the surface. So when you blow
It's
the
very
balloon
illogical.
up, the surface gets bigger, but it doesn't get bigger into anything. It just gets bigger.
Yeah, but that's contradictory to that's contradictory to everything. The physics, basic logic. I mean, there's no.
It absolutely does get bigger into something. It's in a medium called air.
Yeah, he's saying that you take away the air outside of the balloon and inside of the balloon, and all we have is the surface of the balloon. And as you blow the balloon up, just the surface exists, and that's the analogy of the universe, right? Am I correct? And that's what you're saying?
Correct. Yeah.
But that doesn't make sense because
Yeah,
it's
that
still
doesn't make sense.
expanding into quote unquote space, or even in a vacuum chamber,
Well,
right? Like
space is the surface of the balloon. Space is the rubber of the balloon. So the rubber of the balloon is not expanding into the rubber of the balloon. It's just expanding.
No,
But
it's
in real
absolutely
life,
expanding into space,
yeah,
right?
in
So
real life, you can't use the balloon as an analogy then, because you're just saying balloon, but you've taken away all physical attributes of what we know a balloon to be.
Well, the
So
rubber
it's
of the balloon is space. The analog for space is the rubber of the balloon.
what about the area inside the surface of the balloon?
It doesn't exist. Neither does the area
What?
outside. That's right. The 3 dimensions of space and 1 of time is the rubber of the balloon. Not outside the rubber and not inside the rubber, is the rubber of the balloon. That's
So
what,
it
once you get that in,
expands from a singular point, which would be
once
the
you get your head
center.
around that,
No,
it
he says
starts
he's
making a
saying
bit
it's
more sense.
he's saying it's expanding in the 5th dimension. He's saying that the first 4 dimensions, i.e., the 3 Euclidean ones, and the 1 time component, that's one thing. The rubber of the balloon, the space-time fabric is the fabric of the balloon, and he's saying that it is expanding into the 5th dimension essentially. Is that correct?
It's, if you think about the rubber of the balloon as space,
Motherfucker, that was a yes or no question.
yes, the answer is yes.
Okay. See, 5th dimension.
Yeah, how is this
No,
not a religion?
no, it's not a 5th dimension.
Man, it's always going to go back to how did those get there and how did that start and how did this get. You're going to never have a beginning point.
It just doesn't even make any sense whatsoever. We're
It's a
supposed to
religion, bro.
This is the crazy part, right? We're supposed to grant like repetitive anomalies, right? And then pretend that it's the most viable situation. It's like, no, it's just like anomalies and appeal to like incredulity and possibility, and it just doesn't even logically follow at all, bro. It's wild.
Literally what
It's
you'd be
depressing.
illogical about, like don't care, don't think, don't have a mind that actually works.
All right, I'm headed to bed, lads. Thanks for coming out. I hope you guys had a good time. Catch you tomorrow for Flat Earth Fridays. I think that'll be at, what time is that? 8 or 9 p.m. Eastern, give or take. All right, peace, y'all.